Kotlin versus Java. Which language is best for Android development in 2021? New Android developers want to know which language they should learn for building modern Android applications. Development teams want to be sure that Kotlin will not have a negative impact on their application's performance, their ability to hire qualified engineers, or on their overall developer productivity. To help inform your decisions, I have curated a list of some of the most frequently asked questions regarding Kotlin versus Java for Android development. Which is better for Android development, Java or Kotlin? Kotlin is the preferred language for Android development in 2021. Both Java and Kotlin can be used to build performant, useful applications, but Google's libraries, tooling, documentations, and learning resources continue to embrace a Kotlin-first approach, making it the better language for Android today. Does Google recommend Kotlin for Android development? Yes. Google recommends developers start building Android applications with Kotlin and has taken an increasingly Kotlin-first approach to modern Android development. Many Android Jetpack libraries have been either written completely in Kotlin or support Kotlin language features such as coroutines. When did Google start supporting Kotlin for Android? Google announced official Android support for Kotlin at Google I/O in 2017. When did Android become Kotlin first? Google adopted their current Kotlin first approach to Android at Google I/O in 2019. Will Android stop supporting Java? It's unlikely that Android will stop supporting Java anytime soon. The Android SDK is still mostly written in Java and Kotlin. Is Kotlin enough for Android development? Yes, absolutely. You can build Android applications using Kotlin, and as documentations, tooling, and libraries become more Kotlin focused, building applications with Kotlin will become even easier than this. Should I learn Java or Kotlin for Android? You should learn Kotlin first. If you have to pick between learning Java or Kotlin to start developing Android applications, you will have an easier time using current tools and learning resources if you know Kotlin. Is Kotlin easier than Java? Many will find Kotlin is easier to learn and write than Java. A number of things factors into this experience, including Kotlin's concise syntax, type inference, explicit nullability, and extensive standard library. Can I get a job as an Android developer without knowing Kotlin? Yes, but Kotlin is becoming an increasingly desirable skill for hiring managers looking for qualified developers. A LinkedIn search for Kotlin Android developer jobs turns up 7,700 job postings, while a search for Java Android developer returns 5,800 results in the United States. The relative number of postings is similar balanced in India with 11,100 results for Java Android developer and 15,000 for Kotlin Android developer. Is Kotlin faster than Java? No. Out of the three answers depends on what performance metrics you are interested in. So Java is not faster than Kotlin, of course. At runtime, the performance of the language is very similar. At compile time, however, Kotlin is immeasurably slower than a little bit Java. The extent of the slowdown depends on a number of factors, such as the usage of annotation processor and presence of mixed Java plus Kotlin source sets. So after this versus, Kotlin wins.
Hey guys, in this video I'm going to show you how you can download and install Android Studio on your Windows 10 operating system. So for installing Android Studio on your Windows operating system, you need to first have Java installed on your Windows operating system. So first we are going to see how to install Java JDK on our Windows operating system, and then we are going to see how we can install Android Studio. So let's get started. We are going to just open our browser and search for Java JDK. And the first link which will appear here will be from oracle.com. I'm going to provide the link in the description of this video also. So just open the link which is from oracle.com. So once this website is open, you can see at the time of making this video, Java 14 is the latest version available, and you can download it by just clicking on this JDK download link. So I'm going to just click on JDK download, which is going to open this kind of web page. So here you need to just scroll down and locate the Windows operating system executable file. So you can see Windows x64 installer. We will choose this one, and you can see this executable file we can download for Java 14. So just click on this link, which is going to start the download of this executable file. In between, you will be asked to just check this checkbox and then click on this download button. So once this executable file is downloaded, I'm going to just click on this file, and now you can see that this installation wizard has been started. So I'm going to just click on next here. And this will be the location where your Java JDK will be installed. So if you don't have the good reason to change it, just leave it as default and then click on next, and then just wait for the installation to complete. And after some time, you will see this message which says Java SE development 14.0.1 successfully installed. That means Java is installed on our Windows operating system. So I'm going to just close this window. And let's see where Java is installed on our Windows operating system. So just go to this PC and then click on local drive. And then we are going to go to the program files. And here you can see the Java folder. So I'm going to go inside the Java folder. And once you are inside the Java folder, you will see the JDK directory here. Now in the newer version of Java JDK, you will not see a JRE folder here. So JRE comes with the JDK bundle, so you don't need to install it separately or do anything here. So just go inside the JDK folder, and now we are going to set the environment variable for our Java command to work with it. So you need to go inside the bin folder for that, and then just copy this path up to bin folder inside the Java. So to set the environment variables, you just need to search for environment variables, and you will see this result here which says edit the system environment variables. So search few letters of environment and you will see this result. So just click on this result which says edit the system environment variables, and then here you need to go to this section which says environment variables. And now you can add the Java bin environment variable here. So under system variable, you will see this path variable. So just select this and then click on edit. And here you need to click on new and add this path which you have copied. So this is the path up to bin which we have copied. So you just need to click new and then paste this path. So once you have added this, just click on OK. Also, some application requires Java Home to be added into the environment variables. So to add Java Home in your environment variables, you can just click on new under system variables. So just click on new and then under variable name, just write Java home in capital. So Java underscore home all in capital, and then the variable value will be the JDK folder path. So you just need to go up to JDK folder. You don't need to go inside the bin folder. Okay. So up to JDK folder, just copy this path and then just paste it as the variable value and then click OK, which is going to add this Java home variable into your system variable. Once you are done with this, just click on OK and then click on OK. So this means that Java home variable and Java environment variable is added into your environment variables. Now what we are going to do is we are going to check whether Java command is working with our command prompt or not. So just close any other command prompt which you have previously opened and then just open the command prompt once again. So just write cmd and then just click on command prompt here. And here we are going to check once again Java version command. So I'm going to just write Java hyphen version here, and it's going to show the version of Java which you have installed. So we have installed Java 14.0.1. So it's going to show us this result. You can also run Java C command. So Java C hyphen version, and it's also going to show you the Java C version. So once you have installed Java JDK on your Windows operating system, we are ready to install Android Studio on our Windows operating system. So for that, just open your favorite browser once again and then search for Android Studio, and you will see the first result here will be from developer.android.com. So we are going to just click on this link. I'm going to give this link in the description of this video also. Once this website is open, straight away you can see this download button. And at the time of making this video, you can see 4.0 for Windows is the latest version of Android Studio. Also, if you want to see the system requirements for installing Android Studio, you can just scroll down at the bottom, and at the bottom you will be able to see the system requirements. So we are using Windows 10. So these are the system requirements for installing Android Studio on your Windows 10 operating system. So make sure all the system requirements are met on your Windows operating system before installing Android Studio. So once your laptop or PC fulfills all these requirements, we are ready to just download this executable file. So I'm going to just click on this download button and then click on I have read and agree with all the above terms and conditions, and then click on download. So you can see it's around 871 megabyte file, so it will take some time to download. So I will wait for the download to complete. So once this executable file is downloaded, I'm going to just click on this executable file and I'm going to minimize my browser. And first of all, you just need to select yes here, which is going to start the installation wizard for Android Studio. So here on this first window, you just need to click on the next button, and then you will see this section here. Also leave everything as default and then click on next. And this will be the location where Android Studio will be installed on your Windows operating system. So if you don't have the good reason to change it, just leave it as default and then click on next. And then here on this window, you don't need to do anything. You just need to click on install and then wait for some time for the installation to complete. So now you can see the installation is finished and it says setup was completed successfully. So at this point, you just need to click on next button and then just leave this checkbox as checked and click on finish, which is going to launch Android Studio for you. Now for the first time, when Android Studio starts, it will ask you if you want to import the config from the previous installation of Android Studio or not. Otherwise, you can choose do not import anything. So just leave it as do not import settings if you are installing Android Studio for the first time, and then click on OK, which is going to start the Android Studio. Now at this point, you can see this message which says allow Google to collect anonymous usage data of Android Studio and its related tool. If you want to allow Google to do that, just click on send usage statistics to Google. Otherwise, click on don't send. In my case, I'm going to just choose don't send. And now on this Android Studio setup wizard, you can set up your Android Studio according to your needs. So here just click on next, and in the install type you can see there are two options, standard and custom. For the new user, I will recommend the first option, which is standard, which is recommended for most users also, and then click on next. And here you can select the UI theme. So some people like darker theme, other people like light theme. So it's totally depend on the developer's taste. I'm going to go with the light theme, but if you want to have the darker theme, you can just select the darker theme and then click on next. And now you can verify all the settings which you have selected. So you can see there are so many settings which are selected here. You can verify them, and then if you are happy with all those settings, then you can click on finish. At this point, the Android Studio will start the download of some extra tools which were listed in the verify steps. So here also you need to wait for some time until this download and the setup is finished for the Android Studio for the first time. And as you can see, I have pressed show more, so I am seeing more details about this process here. So once this process is finished, you will see this finish button here. So I'm going to just click on finish here, and then you will see this Android Studio window. So now let's create a sample Android Studio project. So I'm going to just select on start a new Android Studio project from here. And here you can choose between phone and tablets, and Wear OS, TV OS, automotive, and Android things. So I'm going to select phone and tablet. So I'm going to just select empty activity because we are going to just test our Android Studio, and then click on next button here. Here at the top you can provide the name to your Android application. For example, I'm going to just provide my first Android application name as Hello World here, and then just leave package name as default. You can also change the location where this project will be saved, and also you can select the language in which you want to develop this Android app. So for now, I want to develop this Android app in Java. So I will select Java from here, and minimum SDK. So you can see by default API 16 Android 4.1 Jelly Bean is selected. You can select the newer version or the later version from here also. And it also depends on how many percentage of Android device you are targeting. So let's say I'm going to just select Android 5.0. It says that your app will run on approximately 94.1% of devices. Okay, so here I'm going to just select API 16 Android 4.1 Jelly Bean, and then click on finish, which is going to start the Android Studio for the first time. So now as you can see, it will take some time to load, so just wait for some time. So we will start from the right hand side. You will see this window in which you can see what's new in the newer version of Android Studio. If you don't want to read it, just minimize this option because our project is created here. On the left side you can see the project view, and here on the right side you can see the code for your project. Also you will be able to see the activity main.xml file where you can design your Android app. One more thing you will observe here is this bottom bar here, and here you will see the Gradle is downloading some packages. So you need to wait for those packages to be downloaded. So just wait for this progress bar to reach to the 100% mark. Also you can click on terminal here, which is going to show you the terminal, or if you want to see the build, then you can see the build status also here for your Android app. So now as you can see, this sync is finished. So my build is successful, and as you can see on the activity main.xml window, I can see this design view, or I can see the split view in which I can see the design and the code for that, or I can see only code. Okay, so you can choose between these three modes, whatever you want to use. So right now when I just maximize this design view or zoom it, I can see there is one text message here which says hello world. So when we are going to run our app, it's going to show hello world message on the app. So now let's run this project. So in order to run this project, you need to select some device. Now right now you can see there is no device selected here. So when you will run your app, it will say that error running app, no target device found. So what you need to do is you just need to click on this no device here and then click on open AVD manager, which is going to open this kind of window. So here we are going to create a new virtual device. So I'm going to just click on new virtual device. And from here you can choose the device on which you want to test your Android app. So all the devices which you see here are from Google. So here I'm going to select this Pixel 3 device from here, which is around 5.43 inches. And then I'm going to click on next button. So here on the next window, you can select a system image. So you can see different release names and API levels. So for now, I'm going to choose this release name, which is Oreo, and the API level is 27. So just click on download link here, and it's going to open this kind of license agreement window. So just click on accept and then click on next, which is going to start the installation of the requested component. So once the installation is finished, just click on finish button. So when I click on finish, you can see when I select Oreo, which I have downloaded, on the right hand side, it says HAXM is not installed. So in order to install it, you just need to click on this link, which is given here, which says install HAXM, and then leave everything as default, which is 4 GB in my case, which is also recommended. If you want to increase it, you can increase it. It's totally dependent on your operating system. And then click on next and click on yes. And now I can see that Android SDK is up to date, running Intel HAXM installer, and then Intel HAXM update is successfully and done. So click on finish now, and once again click on next. Now I can see that I can choose from these two modes. One is portrait and other is landscape. So I will leave everything as default here and then click on finish. So now I have this virtual machine which I have created recently, right? So now as you can see, I have created one more device, which is Nexus 5 API also, just for the demonstration. So in this way you can create multiple virtual devices here, and then once you close it, you will be able to select between those virtual devices. So after that, you can just select one of the device and then click on this run app button, which is going to run your app and show you the app in the virtual device. So this is how you can download and install Android Studio on your Windows 10 operating system. I hope you've enjoyed this video, and I will see you in the next video. Hey guys, in this video, I'm going to show you how you can download and install Android Studio on your Ubuntu operating system. So the prerequisite of installing Android Studio on your Ubuntu operating system is you need to have Java installed on your Ubuntu operating system. So if you don't have Java, please install Java on your Ubuntu operating system. I have already installed Java on my Ubuntu operating system. So let's check which version of Java I have. So I will just press Ctrl-Alt-T to open my terminal, and once the terminal is open, I'm going to just give this command, which is java version, and it's going to give me the version of Java. So if you don't see any response related to Java version here, then most probably Java is not installed. So I have already created a video about how to install Java on Ubuntu operating system. So I will put the link in the description of this video, so you can just watch that video and install Java. So once you have Java installed on your Ubuntu operating system, just open your favorite browser and search for Android Studio download. And here the top link would be from developer.android.com/studio. So I'm going to just click on this link. We are going to just check which version of Android Studio is available for the download. We are not going to download Android Studio from this website. I just want to check which is the latest version, and at the time of making this video you can see the latest version is 4.1.2. so we are going to download this version of Android Studio on our Ubuntu operating system. So once again, go to your terminal, and let me clear the terminal, and we are going to use a utility called Snap to install Android Studio. So Snap is basically our package management system which will help you to download and manage your softwares, right? So first of all, we are going to find Android Studio on Snap. So just write snap find, and then in the double quotes you can just write Android-Studio here, okay? And when you click on enter, you will see some results here, and you can see the version available here is 4.1.2, which is same as available on its website. So we are going to install this version. So to install Android Studio using Snap, you can just write sudo snap and then install, and whatever software you want to install, Android Studio. So we are going to write Android Studio -- classic, which is the note here, right? So sudo snap install Android Studio -- classic, which is going to install the latest version, and give your Ubuntu's password, which is going to start the download of this Android Studio package. So after some time you will see this message which says Android Studio 4.1.1 or whatever version you have installed from Snapcrafters installed. That means Android Studio is installed on your Ubuntu operating system. So you can close this terminal, and now we are going to go to the applications section here, and then we will search for Android Studio. You can directly see this Android Studio icon here, but if you don't see this icon, just search for Android here, and you will be able to see Android Studio icon here. So I'm going to just click on this icon, which is going to open Android Studio on my Ubuntu operating system for the first time. Now when Android Studio starts for the first time on your Ubuntu operating system, it's going to show you this kind of window, which will ask you if you want to import Android Studio settings if you have the previous version of Android Studio already. I don't have any Android Studio previously installed, so I will just leave it as it is, which is do not import settings, and click on OK. Also you will see this window at the time of the start. So I don't want to share any data, so I will just click on don't send, and now you will see this kind of window which says Android Studio setup wizard. So I'm going to just click on next button, and I want to install the standard version of Android Studio, so I will leave it as it is, which is standard, and then click on next. And here you can choose which theme you want for your Android Studio, Darkula or the light theme. I will choose the Darkula theme for this Android Studio installation, and then click on the next button. And now on this next window you will see the verify settings window, and here you can verify all the settings, and if you don't want to install some of the settings, you can click on the previous button and change those settings. So once you have verified all the settings, you can just click on next and then click on finish. And now at this point Android Studio is going to install all the components which you have chosen. So just wait for the download of those components. Also, if you want to see the details of this process, you can click on show details, which is going to show you what's happening right now. So once the downloading of the components are finished, I can click on the finish button, which is going to start my Android Studio. So when Android Studio starts, it's going to look like this. So you can create a project, You can open an existing project from here, and also you have all these other options. So let's create a new project in Android Studio and let's see if everything is working fine or not. So I'm going to just click on create a new project, and then you can select the template from here. I'm going to choose the default template, which is empty activity, and then click on next. And here you can give the name to your project. I will leave it as default because I just want to test, but you can change the name of your project from here, and also you can change the package name from here. You can also choose the language in which you want to create your Android Studio project. You have the option to choose Java or Kotlin here. For now, I'm going to choose Java, but if you are comfortable with Kotlin, you can choose Kotlin from here. Also, you can choose the minimum SDK version from here. You can see all these versions. By default, Android Studio is going to suggest you some version, and if you want to choose other version, you can choose it from here. So let's say I'm going to choose this version, which is API 26 8.0 Oreo, which is going to cover around 60% of devices. And then I'm going to just click on finish, which is going to create this Android project for me. So let me just maximize this window. So when you create your Android project for the first time, it might take a little bit of time. Here you can see what's new in Android Studio 4.1. I'm going to just minimize this window from here, and now I can see these two files, which are main activity.xml file and main activity.java file. You will also see at the bottom that Gradle is installing some packages, so I need to wait until all the Gradle packages are downloaded. So now once the Gradle download is complete, I can see all the project files here, and I can click on the main underscore activity.xml file, and when I click on this XML file, I can see 3 modes here. One is the design mode, where you can design your UI. Other is the code mode, where you can write the UI design in the form of this XML file. And the third is the split view, where you can see the design as well as the XML file also. Also, you can see the terminal option here, so you can open the terminal inside the Android Studio. And you have this build option, where you will be able to see if your build was successful or not. So you can see the last build was successful, and it says build successful in 5 minutes and 30 seconds. Also, when you go on the top, you will be able to see by default the device on which your Android program is going to run, which comes with the Android Studio by default. And let's run this program, and let's see what happens when I click on this run button. So because the build was already successful, I can just click on the run app button, which is going to open this kind of Android emulator on my Ubuntu operating system, which comes with the installation of the Android Studio. So this emulator is installed at the time of the installation of Android Studio. So I haven't installed this emulator separately, right? So when you run your app, it's going to open your emulator and show you the output. So just wait for some time until this output is shown. So this process might take few seconds to few minutes if you are running this Android Studio and this emulator for the first time. Now, for some reason, if your emulator doesn't show the output, as in my case, you can also add a new device using the AVD manager. So to open the AVD manager, you can just click on tools and then click on the AVD manager, and you can see right now I have one device which supports API version 30, which is different than my project, right? So I can just create a new virtual device, and here I can choose any phone. I will just choose the phone. So let's say I'm going to choose Nexus 5 for this demo and then click on next, and you can see which version you want to target from here. I'm going to choose this one, which is Oreo, because I have selected Oreo in the creation of the project also. So I'm going to just click on download and then click on accept, next, and then it's going to start the download of this device. And once this device is installed, I can just click on the finish button here, and you can see this device is added. So I can just select once again Oreo API level 26 and then click on next, and then I can choose the setup orientation from here and the AVD name from here. I will leave everything as default and then click on finish, which is going to add this device in my virtual devices list, right? So once this device is added, you can just select this device and then close this window, or you can just choose this new device which you have added. So I can choose this Nexus 5 API 26 here and then click on the run button once again. And now I can see my app is launched on this emulator, and also I can see this success message which says operation succeeded, and it says hello world because by default this text view contained this text which is hello world, right? You can see this text here also. So now we have successfully installed Android Studio on our Ubuntu operating system, and we have also successfully created an Android Studio project on Ubuntu operating system. So I hope you've enjoyed this video, and I will see you in the next video. Hey guys, in this video I'm going to show you how you can download and install Android Studio on your Mac operating system. So before installing Android Studio, you need to have Java installed on your Mac operating system. So if you want to check whether Java is installed on your Mac operating system, you can just start the terminal. So just search for terminal, and when terminal opens you can just write java -version, and if it gives you some kind of Java version, then Java is installed on your system. If not, you might want to install Java on your Mac operating system. So I will put the link of the video how to install Java on your Mac operating system if you don't know how to install Java on your Mac operating system. So once you have Java installed, you can just open your favorite browser and search for Android Studio, and the first link which will appear here will be from developer.android.com. We are going to just click on this link, and once this link opens, you will be able to see this download Android Studio button here. So I'm going to just click on this button, which is going to show me this kind of window. So here it's going to give you this kind of pop-up window where you need to agree with the license terms and conditions. So if you agree with all these license terms and conditions, just check this checkbox and then click on download Android Studio for Mac, which is going to start the download of this Android Studio DMG file on your Mac operating system. So I will wait for the download to complete, and once this DMG file is downloaded, I'm going to just click on this Android Studio DMG file, and I'm going to minimize my browser, and now this kind of window is visible. So what you need to do, you just need to simply drag this icon to your applications folder. So I'm going to just select this Android Studio icon and then drag this icon to my applications folder. So it's going to copy this Android Studio inside your applications folder, and once it is done, you can just go to the launchpad. So just click on launchpad icon and you will be able to see this Android Studio icon. So now I'm going to just click on this Android Studio icon, which is going to start the installation of Android Studio on your Mac operating system. So first of all, you will be able to see this window which says this app downloaded from the internet, and are you sure you want to open it? So I'm going to just click on open, and now you will be able to see this kind of window. So it says config or installation folder, and it also says do not import settings. So because I don't have any previous installation of Android Studio, so I will leave everything as default and then click on OK, which is going to start the Android Studio on your Mac operating system. So the first window you will see here will be this kind of window, which will tell you to share your data. If you want to share your data, you can click send usage statistics to Google. I will just click on don't send, and now I can see this kind of window. So here on this welcome window, I just need to click on the next button, and on the next window, the installation type, I will leave it as standard. If you are advanced Android Studio user, you can also select custom option here. For now, I'm going to leave it as standard and then click on next. And now you can choose the UI theme. I'm going to choose the dark yellow theme. You can also choose the light theme, and then I'm going to click on next. And here you will be able to see the settings. So if you want to review or change any of your installation setting, click previous. So here all these tools will be installed. I'm going to just click on finish, and this is going to start the installation of all these components. So just wait for the download to complete. You can also see the details of this process when you click on show details button. So now the installation of Android Studio is finished. So you will see this kind of window, which is the welcome window for the Android Studio. So we can create a new project from here. So let's create a new project. I'm going to just click on new project here, and then we are going to create an empty activity project. So just select empty activity here and then click on next, and you can provide the name to your application. For now, I'm going to leave it as default. You can also choose your language, Kotlin or Java. I'm going to choose Java for now, and then you can also choose the minimum SDK. So I will leave it as default, which is API 16, which will cover approximately 99.8% of devices. You can also choose different API version from here. So once you are done with the setting, you can click on finish, which is going to create your Android Studio project. So you can see this project is loading. So just wait for some time until the project loads. And on the right hand side, you will see what's new. You can minimize this window. So at this point, when your project is loading, you will see this process, which is the Gradle process. So it's downloading some Gradle related libraries. So you just need to wait for some time until those libraries are done downloading, and you will see this process bar here. So just wait for this process bar to reach to the 100% mark. So now the process of Gradle package download is completed, and you will be able to see on the left side this project view, and on the right side this kind of code view for your main activity. Also, when you click on activity_main.xml file, you will be able to see the UI view of your app. So by default, it has this one text view and there is hello world written inside that text view. Now here you can split this UI view in 3 modes. So you have this design mode by default selected. You can also see the code behind this UI, and also you can click on the split view, where you will be able to see the UI component and the code behind it, which is the XML file. Okay, so you can choose if you want to see the code view, split view, or the design view from here. Also, you will see the terminal option here. So you can click on the terminal option and you will be able to see the terminal here. You can also see the build process, which is the next option here. So when I click on build process, you can see build successful in 4 minutes 26 seconds. That means the build was successful. So now let's try to run this app. So I'm going to just click on this run app button, and let's see what happens. So when you click on run app button, it's going to run your app in your emulator, which is downloaded at the time of the installation of your Android Studio. So this emulator will come with the download of Android Studio on your Mac operating system. Also, you can see this message which says Android Studio would like to access the microphone. An application in Android Studio request access to device microphone. So if you want to allow this, you can also allow this microphone, or if you don't want to allow this, you can just select don't allow. So for now, I'm going to just select don't allow for now. And you can also see here at the bottom it says waiting for all target devices to come online. So it's waiting for this emulator device to come online, and once this device comes online, you can see this Pixel phone is starting. So now I can see this app which is running on my Android emulator, right? So I can see this hello world in the message here. So now let's just say that I want to change this hello world message from here. So I can just select this text edit from here, or text view from here, and then I can just write hello from Android Studio. And then I'm going to rebuild my project by just clicking this hammer button. And once it's done, I can just relaunch my app. So I can just click on this button once again, which is going to run my app once again, and it's going to relaunch my app in the emulator. And now I can see this message which says hello from Android Studio. So everything is working. That means we have successfully installed Android Studio on our Mac operating system and tested it with a sample project. So this is how you can download and install Android Studio on your Mac operating system. I hope you enjoyed this video, and I will see you in the next video.
In this lecture, we will familiarize ourselves with the life cycle of an Android application. The idea is that a computer program has a life cycle. Might sound strange at first, but it will soon make sense. Let's change to our slides here. The life cycle is that way that all Android applications interact with the Android operating system, in the same way that the life cycle of humans enables them to interact with the world around them. We have no choice but to interact with the Android life cycle, and we must be prepared to handle numerous unpredictable events if we want our applications to survive. We will explore the phases of the life cycle that an application goes through, from the creation to distraction, and how this helps us know where to put our Kotlin code, depending on what we are trying to achieve. In this lecture, we will explore the life and times of an Android application, the process of overriding and the override keyword, the phases of Android lifecycle, what exactly we need to know and to do code our applications, a lifecycle demonstrator and application we're going to create as well, and you will learn how Android code is structured and preparation for going deeper into Kotlin coding in next lectures. So let's start learning about the Android lifecycle, and let me change our slides here to IntelliJ IDEA screen, Android Studio screen. The life and times of Android application. We have talked a bit about the structure of our code. We know that we can write classes, and within those classes we have functions, and these functions contains our code which gets things done. We also know that when we want the code within a function to run, that is to be executed, we call that function by using its name. As like we did earlier chapter, let me create a function test here. And let's create this function, this is useless function because this doesn't do anything here. As you can see, we call test function here and create a new function. In this lecture, we will examine what happens through the life cycle of every application that we write. That is when it starts, ends, and the stages in between. I want to show that slides again. What we will see is that Android interacts with our application on a numerous equations each time that it runs. Android interacts with our applications by calling functions that are contained within the activity class. Even if the function is not visible within our Kotlin code, it is still being called by the Android's appropriate time. If it doesn't appear make any sense, and let's continue. Have you ever wondered why the onCreate functions has the unusual override keyword before it? Let me show you here. As you can see here, override function onCreate. So when we override a function, let me change. Okay, when we override a function here, has the unusual override keyword, we are saying to Android that when you call onCreate, please use our overridden version because we have some code in it that we want to execute here. Furthermore, you might remember that unusual looking first line of code in the onCreate function here. This is telling Android to call the original version of onCreate before proceeding with our overridden function. There are also many other functions that we can optionally override, and they allow us to add or cut at appropriate times within the life cycle of our Android applications. In the same way that onCreate here is called just before the application is shown to the user. There are also other functions that are called at other times, but we haven't seen them or overridden them yet. But they are there. They are called and their code executes. The reason we need to know that and understand the function of our application that Android calls whenever it wants it, because these functions control the very life and death of our code. For instance, what if our application allows the user to type an important reminder, then halfway through the typing the reminder, their phone rings, our application disappears, and the data, that is the user important reminder, is gone. It is a vital and thankfully quite straightforward to learn when, why, and which functions Android will call as part of the life cycle of our application. We can then understand where we need to override functions to add our own code and where to add the real functionality code that defines our application. Let's examine the Android lifecycle. We can then move on to the ins and outs of Kotlin and gain an understanding of exactly where to put the code that we write. I want to explain you the simplified explanation of the Android lifecycle. If you have ever used Android device, then you have probably noticed that it works quite differently to many other operating systems. For example, you can be using an application on your device, perhaps checking what people are doing on Facebook. Then you get an email notification and you tap the notification to read it. Halfway through reading the email, you might get a Twitter notification, and because you are waiting on important news from someone you follow, you interrupt your email reading and change application to Twitter with a touch. After reading the tweet, you fancy a game of Angry Birds. However, halfway through the first fling, you suddenly remember the Facebook post, so you quit Angry Birds and tap on the Facebook icon. You will likely resume Facebook at the exact same point that you left it. Afterward, you could then go back to reading the email, decide to reply to the tweet, or start an entirely new app. All this doing and forwarding takes quite a lot of management on their part of the operating system and is independent from individual applications themselves. The difference between, for example, a Windows PC and Android in the context of what we have just discussed is notable. With Android, although the user decides which application they are using, the operating system decides when to close down or destroy an application and our user's data, such as hypothetical note, along with it. We need to consider this when coding our applications, just because we might write code to do something interesting with our users' input. That doesn't mean that Android will let the code execute. Let me change these two slides again for better understanding. The Android system has a number of distinct phases that any given application can be in. Depending upon the phase, the Android system decides how the application is viewed by the user or whether it is viewed at all. Android has these phases so that it can decide which application is in current use and can then allocate the current amount of resources, such as memory and processing power, to the application. In addition, as the user interacts with the device, for example, touches the screen, Android must give the details of that interaction to the correct application. For instance, a drag and release movement on Angry Birds means takes a shot, but in messaging application, it might mean delete a text message. We have already raised the issue of whether the user quits on application to answer a phone call. Will they lose their progress, data, or imported note? Android has a system that, when simplified a little for the purposes of explanation, means that every application on Android device has phases, like being created, starting, resuming, running, pausing, stopping, and being destroyed. These phases will hopefully appear logical. As an example, the user presses the Facebook application icon and the application is being created, and then it is started. This is all straightforward so far, but the next phase is the list is resuming. So let me run it again here. Resuming. This is not as illogical as might first appear. If for a moment we can just accept that application resumes after it starts, then all will become clear as we continue. After resuming, the application is running. This is when the Facebook application has control of the screen and has the greater share of system memory and processing power, and is receiving the details of the user's input. Now, what about our example where we switch from Facebook application to the email application? As we tap to go to read our email, the Facebook application will have entered the paused phase, followed by the stopping phase, and the email application will enter the begin created phase, followed by the resuming and then running. If we decide revisit Facebook, as in the previous scenario, the Facebook application will probably skip being created and go straight to resume and then be running again, most likely at the exact same place that we left it. Note that any time Android can decide to stop and then destroy an application, in which case when we run the application again, it will to be created at the first phase all over again. So, had the Facebook application been inactive long enough, or perhaps Angry Birds had needed so many system resources that Android had destroyed the Facebook application, then our experience of finding the exact post that we were previously reading might have been different. The point is that it is within the control of the application and how it interacts with the lifecycle to determine the user's experience. If all this is starting to get confusing, you will be pleased to know that only reason to mention these paces is due to you know they exist, you will occasionally need to interact with them, and we will take things step by step when we do. How we handle the life cycle phase. When we are programming an application, how do we interact with this complexity? The good news is that the Android code was auto-generated when we created our first project does not most of it for us. As we have discussed, we just don't see the functions that handle this interaction, but we do have the opportunity to override them and add our own code to that pace if we need to. This means that we can get on with learning Kotlin and making Android applications until we come to one of the occasional instances where we need to do something in one of the paces. If your application has more than one activity, they will each have their own life cycle. It doesn't mean have to complicate things, and overall it will make things easier for us. So, I want a quick explanation of the functions provided by Android to manage the lifecycle phases. To clarify our discussion of lifecycle functions, they are listed. For example, I want to write it here. Or we have slider, right? Yes, we have our slider here, and all our function is written here. So, onCreate function, onCreate. This function is executed when the activity is being created. Here we get everything ready for the application, including the UI, such as calling the set content with graphics and sound. On start. This function is executed when the application is in the starting phase. On resume. These functions runs after on start, but can also be entered most logically after our activity is resuming after being previously paused. We might reload the previously saved user data, such as important note, from when the application had been interrupted, perhaps by a phone call or the user running another app, so we can reload the previously saved data. On pause. On pause, this occurs when our application is pausing. Here we might save unsaved data such as the note that could be reloaded on in resume. Activities always transition into a paused state when another UI element is displayed on the top of the current activity, for example, a pop-up dialog, or when the activity is about to be stopped, for example, when the user navigates to a different activity. On stop. This relates to the stopping phase. This is where we might undo everything we did in onCreate, such as releasing system resources or writing information to a database. If we reach here, the activity is probably going to get destroyed sometime soon. And on destroy. The on destroy is when our activity is finally being destroyed. There is no turning back at this phase, unfortunately. This is our last change to disassemble our application in an orderly manner. If the application reaches this stage, it will need to go through the lifecycle phases from the beginning the next time the application is used. So I want. I think you have bored these all of theories, but in order to create real applications, you need to learn these theories. So in this now, we will get practical and create a practical explanation of lifecycle applications. So let's find the onCreate method here. As you can see here, and let's create an add 2 lines here. For example, here log.e let's info on create function run it executed. Okay, so let me, yes, it's recording. So, and let's make an toast message here, which you will see what is the toast message, and later of our course, later lectures in this video. Just be in the process and watch and try what I'm doing here. So let's make a toast that make text. Oops, let's add this import toast that make text here, and the context is this, and our message is on create function here, and our toast message long is toast dot length long. So leave one line clear here. Oops, here, and let's add another function on start function. For example, override function on start here, and as you can see here, we have run on start function here. Let's code our code, but copy our code to on start function, but let's change to on start instead of on create, because we're running on start function here. And let's create again lifecycle function here, override function on resume. Okay, so let's copy that as well and paste it here, and let's change it on resume and on resume here, and let's create another function here, override function on stop or on pause after on resume. It's more logical. It's not there is no different if we can if we write on resume before on start. It's don't make difference, but for clean coding it's nice. Because as you can see here, on create, on start, on resume, on pause, and then we will create, on stop, and then destroy here. So on pause here, and super oops, what is that? Because we have returned super of this function, super dot on pause. And let's copy our code here on pause and on pause here, and let's create on stop now, override function on stop here, and return super dot on stop, and copy our code as well here. Every time this function runs, this code will run and tell us what function is executed on stop and on stop as well. And we have another function as well, which is on destroy, and our last lifecycle event. After that, our activity does not exist anymore. We have to create all over again. So function on destroy and super on destroy, and copy, and let's change to on pause to on destroy. So, and here on destroy. So before running the code, let's talk about the code itself. Notice that the function names all correspond to lifecycle functions at the related phase. As you can see in onStart, we printed onStart, in resume, we printed to log on resume and to toast on resume as well, and like that. So the Android calls our functions at the various times that we have already discussed. The override keyword, as you can see here, all of these override keywords shows that these functions replace or override the original versions of the functions that provided as part of the Android API. Note that we don't see these replace functions, but they are there. And if we didn't override them, these original versions will be called by the Android instead of yours. There's super ons here. You can see here super dot, which is the first line of the code within each of the overridden functions, then calls these original versions. We don't simply override these original functions in order to add our code. We also call them and the code is executed too. Finally, the code that you added will make each of the functions output on one toast message here. You will see what toast is later lectures. And now, not later lectures, we will run our lifecycle demo application now. However, these messages that are output vary, as it can be seen here, these different outputs here. The messages that are output will make it clear which function produced them. So let's run our application here, and I want to show emulator as well. Our application is built. In 10 seconds it will be launched. As you can see here, let's open the logcat. And let's filter, because we have so many logcat info. Okay, so as you can see here, the first is onCreate function executed here. As you can see here on create, the first function is executed because, as you've seen in functions, our sliding functions, sliding photos, you had seen these onCreate functions. If you don't have any, the onCreate function will start firstly. So, and after that onStart function executed, and after that onResume function executed. So let's tap the back button on the emulator or device. Notice that you get the following toast message here, as you can see here, and this is the exact on pause here. As you can see here, on pause executed, then on stop and on destroy executed as well. So let's go run another application here. For example, let's run settings here. And let's run it again. our developed application Kotlin functions here. And as you can see here, on create, on start, and on resume activated as well. And when we click this last application button, the first is on pause function is executed, and then on stop function is executed here. Can you see? Yes. So let's delete the last used application now. As you can see here, on destroy function is executed. So let's run again. As you can see, on create, on start, and on resume function executed that each time we running application. Now let's use a task manager button, which in the lifecycle demo app, and we will see that on create here, as you can see, on pause, on stop function is executed, and let's tap it again, and on resume function executed here, as you've seen here. So when we started the lifecycle demo application for the first time, we saw that the on create, on start, and on resume executed. Let me close our emulator. We don't need for now. So when we started the lifecycle demo application for the first time, we saw that on create, on start, and on resume functions were called. Then we have closed the application using the back button. On pause, on stop, and on destroy functions were called. Furthermore, we know from our code that the original versions of all these functions are called because we are calling them ourselves with the super on, as you can see, super on resume, super on start, super on pause, super on stop, super on destroy here. So the quirk in our application's behavior came when we used the task manager to switch between application, and when switching away from the lifecycle demo application, it was not destroyed, and subsequently when switching back, it was not necessary to run on create. It is entirely possible, but not likely, that you got slightly different results when you followed the preceding steps. What is for sure is that when our applications are run on thousands of different devices by millions of different users who have different preferences for interacting with their devices, Android will be calling the lifecycle functions at unpredictable times. For example, what happens when the user exits the application by pressing the home button? If we open two apps one after the other and then use the back button to switch to the earlier app, will that application destroy or just stop the application? What happens when the user has dozens of applications in their task manager and the operating system needs to destroy some application that were previously on stepped to save system memory? Will our application be one of the victims? You can, of course, test out all the preceding scenarios on your emulator, but the results will only be true for the one time you test it. It is not guaranteed that the same behavior will be exhibited every time, and certainly not on every different Android devices. At least there is some good news. The solution to all of this complexity is this follows some simple rules. Set up your application so that it's ready to run in the onCreate function. Load your user's data in the onResume function here. As you can see here, set up your application on onCreate and load your user's data on resume. Save. I want to explain this to you. Load user's data and set up your application here. I'll want set up application, and for on resume function, we on pause function save users data, and tidy up your application to make it a good Android citizen in the on destroy. Do last things. So if we follow the preceding rules, we will see that over the course of this course, we can simply stop worrying about the life cycle and let Android handle it. There are 5 more functions that we can override as well. So let's take a look at them. Firstly, you may have noticed that there are other auto-generated functions in the code of all our projects using the basics activities template. They are on create options menu and on options item selected menu, which later on the next lecture will be about them, and I will see some overridden functions to you. So thanks for watching, and I'm waiting to the next lecture. A tour of the Android Studio user interface. While it's tempting to plunge into running the example application created in the previous lectures, doing so involves using aspects of Android Studio user interface, which are best described in advance. Android Studio is a powerful and feature-rich development environment that is to a large extent intuitive to use. That being said, taking time now to gain familiarity with layout and organization of the Android Studio user interface will considerably shorten the learning curve of later lectures of our course. With this in mind, this chapter will provide an initial overview of the various areas and components that make up Android Studio environment. Let me check, is this recording? Yes. So, I want first start with the welcome screen here. The welcome screen is displayed any time that Android Studio is running with no project currently open. So open project can be closed at any time by selecting File, close project menu option. If Android Studio was previously exited, while the project was still open, the tool will bypass the welcome screen and the next time that it launched, automatically opening the previously active project. In addition to a list of recent objects, here you can see here, I don't want to open, I just wanted to show you. As you can see, this is a list of our recent projects. So the quick start menu provides a range of options for performing tasks such as opening, creating, and importing projects here. And can you see my mouse actually? Yes. So, and creating an important project along with access to a project currently under the version control, as you can see, get from version control here. So in addition, the configure menu, as you can see here, menu at the bottom of the Windows provides access to SDK manager along with a vast array of setting and configuration options. So a review of these options will quickly reveal that there is almost no aspect of Android Studio that cannot be confirmed and tailored to your specific needs. The configure menu also includes an option to check if updates to Android Studio are available for download. So I want to now show you the main window in Android Studio, which is our project. We will work on it. So for example, let's open our Kotlin fundamentals here. And our project is loading now. Here we can create an Android virtual device here as well, but in this lecture you will learn about Android user interface, so this will be easy for later lectures, for not finding anything in later lectures here. The knowing Android user interface is very important thing in Android development. So let's let Gradle builds the project, and Let's stop our video now. Our Gradle project is initialized here, and I will talk about what is this actually. Now let's close this or just no. Let's open actually. So methods context main activity here, and so layout here. Let's give an ID, and here this will our so when a new project is created or an existing one is opened, the Android Studio main window will appear here. When multiple projects are open simultaneously, each will be assigned its own main window. So the precise configuration of the window will vary depending on which tools and panels were displayed at the last time the project was open, but will typically resemble like that. Here, as you can see, we have project files here, and we have resource manager as well, which is there is a dravables, colors, layout, map, string is here, and navigation here. So this is an menu bar here. So contains a range of menus here, performing task with an Android Studio environment. Let me can you see it? Actually, I want to see it. So okay, if I click here, yes, you actually see it. Yeah. So this is the menu bar here. Contains a range of menus for performing tasks within Android Studio environment: file, edit, window, navigate, code, analyze, refactor, build, run, tools, VCS, window version control, and help here. So then let's go to toolbar actually. So this is the toolbar here in Android Studio, as you can see here. So a selection of shortcuts to frequently performed actions like play, run application, debug, and here attach debugger to Android process, SDK manager, IVD manager. So the toolbar buttons provide a quicker access to a select group of many bar actions. The toolbar can be customized by right-clicking on the toolbar and selecting Customize menu and toolbars here, as you can see here. So if the toolbars are not visible, it can be displayed using here View, click on View, and then Appearance and Toolbar here, as you can see here. This is the toolbar, but in toolbar we display it, so we don't need it now, as you can see. Then let's look at navigation bar here. So what is the navigation bar? The editor window here, this is the navigation bar. Can you see it? Right? Yes, you can see it actually. So this is the navigation bar here, as you can see here. The editor window displays the content of the file on which the developer is currently working. So this is not the editor actually. So navigation bar is a navigation bar provides a convenient way to move around the files and folders that make up the project. Clicking on an element in navigation bar will drop down a menu listing here like this. As you can see here, will drop down menu listing here. So so then you will see subfolders, methods, as you can see here, packages, and like that. This provides an alternative to the project tool window here, as you can see here, and hide and display this bar using View here, Appearance, and then selecting navigation bar here. As you can see, we have not navigation bar anywhere. Let's undo our action here, navigation bar. Now let's I want to talk about your editor window here. So the editor window displays the content of the file on which the developer is currently working. What gets displayed in this location, however, is a subject to context. When editing code, for example, the code editor will appear. When working on user interface layout file like this, or like this, or like this, here. when working on a user interface layout file, or on the other hand, the user interface layout editor will appear as follows here. When working on a user, for example, when multiple files are open, each file is represented by a tab located along with the edge of the editor, like this. For example, in here we are working with multiple files. For example, let's open. As you can see, we have tabs here, which will can change our editor window here. So then, I want to talk about your status bar here. Is this recording? Yes. Status bar. The status bar here. The status bar is the status bar displays informational messages about the project and activities of the Android Studio together with the tools and menu button located, as you can see here, located on far left corner. Hovering over items in the status bar will provide a description of that field. Many fields are interactive, allowing the user to click to perform tasks or obtain more detailed status information. Now I want to talk about is the project tool window. The last thing I want to talk about you, and later we will get tool windows in Android user interface. So this is the project tool window here, as you can see here. The project tool window provides a hierarchical overview of the project's file structure, allowing navigation to specific files and folders to be performed. The toolbar can be used to display the project in a number of different ways. The default settings is the Android view, which is the mode primarily used in the remainder of this lecture course. So the project tool window is just one of a number of tool windows available within the Android Studio environment. So now I want to talk about the tool window. In addition to the project view tool window, Android Studio also includes a number of other windows which, when enabled, are displayed along the bottom and sides of the main window. The tool window quick access menu can be accessed by the hovering mouse pointer over the button located here, as you can see here. The tool window quick access menu can be accessed by hovering the mouse pointer over the button located in the far left corner of the status bar here, and selecting an item from the quick access menu will cause the corresponding tool window to appear the main window here. Then alternatively, a set of tool window bars can be displayed by clicking the quick access menu icon in the status bar. These bars appear along the left, right, and bottom edges of the main window, as indicated here, and contain buttons for showing and hiding each of the tool windows. When the tool window bars are displayed, the second click on the button in status bar will hide them. Here. Clicking on a button will display corresponding tool window, while a second click will hide the window. Buttons prefixed with a number, for example, project here, and resource manager here, as you can see here, indicate the tool window may also be displayed by pressing the Alt key on the keyboard here, or Command key for macOS, together with the corresponding number. The location of a button in the tool window bar indicates the side of the window against which the window will appear when displayed. These positions can be changed by clicking and dragging the buttons to different locations in other window toolbars. Each tool window has its own toolbar along the top edge. The buttons within these toolbars vary from one tool to the next. Throwdown tool windows contain a setting option here. As you can see here, clicking and dragging the buttons to a different location in order the tool will appear. So all of the windows also include a far right button on the toolbar, providing an additional way to hide the tool window from view. It's a search of the items made with a main tool window can be performed simply by giving that window focus by clicking on it and typing search term, for example, name of the file in the project tool window here, or clicking Ctrl plus F. So Android Studio offers a wide range of tool windows, the most commonly used which are project, structure, favorites, build variants, and like that. So the project view provides an overview of the file structure. It makes up the project, allowing for quick navigation between files. Generally, double-clicking on a file in the project view will cause that file to be loaded into the appropriate editing tool. So the structure tool provides a high level of view the structure of the source file currently displayed in the editor here. So this information includes a list of items such as classes, methods, and variables in the file. Selecting an item from the structure will take you to the location and source file in the editor window here, as you can see here. So favorites. A variety of projects item can be added to the favorite list. By right-clicking on a file, the project view, for example, provides access to add to favorites menu button. So similarly, a method in a source file can be added as a favorite by right-clicking on it in the structure tool window. Anything added to the favorites list can be accessed through the favorites tool window. Build variants I won't tackle, but first let's check is a lecture recording. Yes. Build variants. The build variants tool window provides a quick way to configure different build targets for the current application project. For example, different builds for debugging and release versions of the application, or multiple builds to target different device categories. So here I want to talk about you in this lecture. Last is to do, and next lecture we will go so far about Android user interface. So to do as you can see here. So to do, as the name suggests, this tool provides a place to review items that have yet to be completed on the project. Android Studio compiles this list by scanning the source files that make up the project to look for comments that match specified to-do patterns. These patterns can be reviewed and changed by selecting the file, settings, and menu option here, settings, and here Android Studio and preferences like that. Let's close. And these patterns, for example, the look here, as you can see here, look we will use so much look in later lectures. The look window provides access to the monitoring log output from a running application in addition to options for taking screenshots and videos of the application and stopping and restarting a process. Here we have a terminal as well. The terminal provides access to the terminal window on the system on which Android Studio is running. On Windows systems as the command prompt interface, while Linux and macOS system this takes the form of terminal prompt. Here we have build as well. Build. The build tool window displays information about the build process while project is being compiled and packaged, and displays details of if any errors encountered. We have run here as well. So what does run? The run tool window becomes available when application is currently running and provides a view of the results of the run together with the options to stop or restart the running process. If an application is failing to install and run on device or emulator, this window will typically provide the diagnostic information relating to the problem. So we have an event log as well, as you can see here. Event log. So the event log window displays messages relating to events and activities performed with Android Studio. The successful build of a project, for example, or the fact that an application is now running, will be reported within this window, tool window actually. A Gradle here. So what is Gradle? The Gradle tool window provides a view onto the Gradle tasks that make up the project build configuration, as you can see here. As you can see, this is the Gradle window. The window lists the tasks that are involved in compiling the various elements of the project into executable application. Right-click on the top-level Gradle task and open Gradle here. Top-level open Gradle config menu option. Load the Gradle build for a file for the current project in the editor. The Gradle will be covered in greater detail later in this course. We have a profiler as well, as you can see here. Let's close actually Gradle. So we have a profiler as well. What is profiler? The Android profiler tool window provides real-time monitoring and analysis tools for identifying performance issues within running applications, including CPU, memory, and network usage. This option becomes available when application is currently running. We have device file explorer as well. Let's close this. So this is the device file explorer tool window provides direct access to the file system of the currently connected Android device or emulator, allowing the file system to browse and files copied to the local file system. We have resource manager as well, and what does the resource manager do? A tool for adding and managing resources and assets here. Assets such as images, colors, and layouts files here. Community derivable is image actually. Colors, layout files here. So in later lectures we will learn more about Android user interface here. But I want to talk about you more about little shortcuts here, and then end the lecture. So Android Studio keyboard shortcuts. Android Studio includes an abundance of keyboard shortcuts designed to save time when performing common tasks. A full keyword shortcut key map listing can be viewed and printed from the Android Studio project tool window by clicking help and then clicking key map reference. Key map reference here, and after that you will see a vast majority of Android Studio. For example, this is the for Windows and Linux here, and this is the Mac OS here. This is for Windows and Linux. And then this is the for Mac OS. Here. So let's return to Android Studio. Yeah, and then I want to show you how to change Android Studio theme here. The overall theme for the Android Studio environment may be changed either from a welcome screen using configure settings option, or via the main window here, clicking on file and then settings here. And once the setting dialog is displayed here, select the appearance here and option in the left hand panel, and then change the setting of the theme menu here. So we will system settings, file colors, editor version control, actually appearance, and here you can see, click on appearance behavior appearance, and then once it's which you can select an IntelliJ light and high contrast and regular. Let's try IntelliJ light here, and as you can see here, our code is now IntelliJ light. So let's try high contrast as well. You can change your custom font here, like 14 here, and as you can see here, this is now high contrast. I like Dracula. It's a more convenient way to work with Android Studio. It doesn't hurt your eyes. It's user friendly. So then you can change editor font as well. My editor font is bigger for lectures, but you can edit arrange size by your views here. Then the primary elements of the Android Studio environment consist of the following: welcome screen and main windows. Each open project is assigned its own main window, which in turn consists of a menu bar, toolbar, editing and design area, status bar, and the collection tool of windows. The tool window appear on the sides and the bottom edges of the main window and can be accessed either using a quick access menu located in the status bar or via the optional window bars. There are very few actions with Android Studio which cannot be triggered via keyboard shortcut. A key map of default keyboard shortcuts can be accessed at any time from within Android Studio main window. Developing applications for Android involves a considerable amount of programming work, which by definition involves typing, reviewing, and modifying lines of code. It should come as no surprise that the majority of developers' time spent using Android Studio will typically involve editing code within the editor window. Modern code editor needs to go far beyond the original basics of typing, deleting, cutting, and pasting. Today, the usefulness of code editor is generally caused by factors such as the amount by which it reduces the typing required by the programmer, ease of navigation through the large source code files, and the editor's ability to detect and highlight programming errors in real time as the code is being rewritten. As will become evident in this lecture, these are just few of the areas in which Android Studio Editor excels. While not an exhaustive overview of the features of the Android Studio Editor, this lecture aims to provide a quite guide to key features of the tool. Experienced programmers will find that some of these features are common to most code editors available today, while a number are unique to this particular editing environment. So Android Studio Editor here. The Android Studio Editor appears in the center of the main window when a Java, Kotlin, or like XML here, XML or other text-based file is selected for editing. So, for example, here we're our document tabs here. Can you see my mouse actually? Oops. Yes. Right? Yes. You can see my mouse. So here is a document tabs, and there is the editor gutter area, and as you can see here, here is code structure location, and there is, as you can see here, this is the editor area, and this is the validation area here. Oops, not this. This is the validation area here, and like that. So I want to talk about firstly document tabs here, which as you can see here, there is a document tabs here. Then what is this? Document tabs. Android Studio is capable of holding multiple files open for editing at any one time. As each file is opened, it is assigned to document type like this. For example, let's open another file, for example, strings here. So we opened and this stays here until we close it. So each file, as each file is opened, it is assigned a document tab displaying the file name in the tab bar located along the top edge of the top edge of the editor window. A small drop-down menu will appear in the far right hand. If far right hand corner of the bar when there is an insufficient room to display all of the tabs. So for example, let's open another value. So as you can see, this is the drop down menu which we can select, or for seeing a large amount of files here we need a large monitor, or we can just close it. And as you can see here, we now usable now, but it was useful as well. So clicking on this menu, as you seen here, will drop down a list of additional open files. A wavy red line underneath a file name in a tab indicates that the code in the file contains one or more errors here. For example, let's take this. As you can see here, our code is error, as you can see here. So to detach switching between files is simply a matter of clicking on the corresponding tab or using Alt left here, Alt left and Alt right here. Let me click. As you can see here, we can change this like this by Alt left and Alt right shortcuts. To detach an editor panel from the Android Studio main window so that it appears in a separate window, click on the tab and drag it on area on the desktop outside the main window here, as you can see here. As you can see here, we now can use this, and we can put it back. To return the editor to main window, click on the File tab and separate editor window and drag and drop into the original editor bar in the main window. And then I want to talk about the gutter area here, the editor gutter area. So this here, as you can see here, this is named gutter area. The gutter area is used by the editor to display the informational icons and controls. Some typical items, among others, which appear in this gutter area are debugging, breakpoint markers, control to fold, and unfold block of code, as you can see here. As you can see here, we can fold, unfold our codes here. Okay, so then which appear in the gutter area are debugging, breakpoint markers, controls, and fold and unfold block of code. So line numbers are switched on by default, but may be disabled by right-clicking on the gutter and selecting show line numbers. As you can see, we disabled our line numbers here, and let's activate it again. And by default, but may be disabled by right-clicking and in the gutter selecting show line numbers option. We can set bookmark as well, as you can, and we can clear bookmarks here. So the code structure location, as you can see here. So code structure location here. This bar at the bottom of the editor displays, as you can see here. I'll change to activity main here, constraint layout, and let's add another text view inside our text view here, and text view here, and as you can see here. So this is the code structure location. Oops. This is the code structure location here, as you can see here. So this bar at the bottom of the editor displays the current position of the cursor as it relates to the overall structure of the code. In the for example, the bar indicates that the for example, text view is currently being edited, for example, like this or like this. As you can see now, we are editing constraint layout. Now we are editing inner text view, and selecting any element within the bar will move the cursor, as you can see here, and to the corresponding location with the code file. So let's add here, as you can see here, saved instance state and activity main. So now I want to talk about the editor area. The editor area is here. The editor area, this is the main area where the code is displayed, entered, and edited by the user. Later sections of this course will cover the key features of the editing area in detail. The validation and marker sidebar. So the validation and marker sidebar is here, right side of our editor. So Android Studio incorporates a feature referred as on-the-fly code analysis. What this essentially means is that as you are typing the code, the editor is analyzing the code to check for warnings and syntax errors. The indicator at the top here, as you can see here, indicator at the top of the validation sidebar will change from gray checkmark, no warnings or error detected, to yellow square, as you can see, warnings detected. And as you can see, we have used 5 imports. Yes, and if we clear that, as you can see here, there is no problems found, and this is the validation green checkmark. So or red alert icons if errors have been detected. Let's create an error here. As you can see here, there is an error, and it changed to warning mode here. Let's do the recording. Yes. So the sidebar also displays the markers at the location where UGS have been detected using the same color coding. Hovering the mouse pointer over a marker, the line of code, as you can see here, is visible in the editor area, will display a pop-up containing a description of the UG. As you can see here, install the reference we here because we signed our activity main name not properly. So hovering the mouse pointer over a marker for a line code which is currently scrolled out of the viewing area of the editor will display a lens overlay content block code where the problem is located. So allowing it to be viewed without a necessity to scroll to that location in the editor. It is also worth noting that the lens overlay is not limited to warnings and errors in the sidebar. However, any part of the sidebar will result in a lens appearing containing the code present at the location within the source file. So, I want to talk about you lastly the status bar. Status bar here. So, what is the status bar? Through the status bar actually part of the main window as opposed to the editor. It does contain some information about the currently active editing session, and this information includes the current position of the cursor, as you can see here. So we are 10th line and first character. For example, we are 6th line and 43 characters. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7. and 43 characters here. And in terms of line, and this will show the encoding format of the file with UTF-8, ASCII, and etc. Clicking on this value status bar allows the corresponding setting to change, as you can see here. Clicking on the line number, for example, displays go to line dialog. Let's go to line 5 and 6th character here. As you can see, we are 9.5. So splitting editor window. By default, the editor will display a single panel showing the content of the currently selected file. A particularly useful feature when working simultaneously with multiple source code files and the ability to split the editor into multiple panes. To split the editor, right-click on the File tab within the editor window and select the Split Vertically here, and Split Vertically here, and or Split Horizontally menu option. For example, let's click on Split Vertically here, and we can use the like that here. Let's close our, as you can see here, strings here, or activity main here. So the orientation of the split panel may be changed at any time by right-clicking on the corresponding tab here. Let's change to split horizontally here, as you can see here, and we can close that, as you can see here, and split horizontally here, as you can see, split it horizontally. So as I said earlier, the split panel may be changed at any time by right-clicking on the corresponding tab and selecting the change split orientation menu option. Repeat these steps these two steps to unsplit a single panel, this time selecting the unsplit option from the menu here, or you just close this. Click on unsplit here, and as you can see here, our split is gone. Window splitting may be used to display different files or provide multiple windows on the same file, allowing different areas of the same file to be viewed and edited concurrently. And I want to talk about the code completion here. Okay, let me check is this code completion is recording, because it may be okay, let me check. Oops. Yes, it's recording. And so now you will learn code completion here, and let's check how many minutes we have. So in the next lecture you will learn code completion here, and I'm waiting you in the next lecture. So goodbye, thank you. Code completion. The Android Studio editor has a considerable amount of built-in knowledge of Kotlin programming syntax and the classes and methods that make up the Android SDK, as well as the knowledge of your own code base. As code is typed, the editor scans what is being typed and, where appropriate, makes suggestions with regard to what might be needed to complete a statement or reference. When a completion suggestion is detected by the editor, a panel will appear containing a list of suggestions. For example, let's delete our setContentView method, r.layout.activity main parameter here, r.layout here. As you can see here, we have one layout because of the code completion suggests one layout. So let's create an let's make an example. For example, main activity main here, and let's create a string here, var name string here, and let's string. As you can see, we have classes that starts with stri characters, and this code completion feature of our Android Studio will suggest these characters to us. So if none of the auto-compilation suggestions are correct, simply keep typing and the editor will continue to refine the suggestions where appropriate. So for example, string here, string. As you can see, the first case is a string, so we can use string but in some cases, if this is not a proper way, then write your class name properly here and click on enter. So to accept the topmost suggestion, simply press the enter or type tab here to accept top suggestion. Press here enter or tab key. So to select different suggestions, use the arrow key to move up and down the list. For example, let's a string here, and you can by using arrow keys you can move down and up here, and if you want to choose then click tab or enter key as I did. As you can see here, string prepares exception, but we will not use that because we just want to create an var the name string here, but we can use as well, but not in this case. Code completion suggestions can be manually invoked using the control space keyword sequence. So you can activate code completion suggestions by pressing control and space at one time. And as you can see here, there is an vast variety of our classes, built-in Android classes here. As you can see, by clicking control and space, you are manually activating this to code completion suggestions here. So in addition, for example, to the real-time auto-completion feature, the Android Studio Editor also offers a system referred to Smart Completion. Smart Completion is invoked using the Shift control space keyword sequence, and when selected, will provide more detailed suggestions based on the current context of the code. For example, let's Shift control space. As you can see, we have no suggestions because we didn't give anything. We just declared the one name, and for example, we can do it like that. Var name here, string here, or string my name here, and we can do like that. For example, no suggestions here. Oops. If we do like that, oops, control shift space, no suggestions here, and let's use control plus space, and as you can see, the first suggestions is string. So code completion can be a matter of personal preference for many programmers. In recognition of this fact, Android Studio provides a high-level control over the auto-completion settings. So this can be viewed by modified by file, clicking on file, and then settings menu option. Then go to editor here, editor, and here you will have code completion. Let me find that. Editor code completion, actually. As you can see, editor general code completion. So you can control code completion as well, like this parameter. So parameter name hints on completion. Show the parameter info top up, and you can do whatever you want. If you want to reset in resetting Android Studio is so easy. So statement completion. I want to talk about you. So another form of auto-completion provided by the Android Studio Editor is a statement completion. This can be used by to automatically fill out the parentheses and braces for items such as methods and loop statements. Statement completion is invoked by let me create a new function. Okay, let's write here statement completion is invoked by or using shift plus control plus enter. Then let's create a new method here. You will create all of strings methods here, and in later lectures you will learn a lot of things about Kotlin, but I want just to show you the basics of Android Studio editor and UI before diving into more professional things. So let's create a new method. You will learn about how to what is method and how to declare them. Method here, as you can see, when I press Shift Control Enter, these these braces were automatically added. So when I click the Shift Control Enter, triggering statement completion will cause the editor to automatically add the braces. So let's try another method, fun example method here, and when I click Control Shift Enter or Shift Control Enter, doesn't matter, this will add braces to it. It's so useful sometimes when you're coding big applications. So I want to talk about the parameter information here. It's also possible to ask the editor to provide information about the argument parameters accepted by a method. With the cursor position between the braces of a method call, for example, Control P here, so we can use this. Well, let's ask what this method wants from us by clicking keyboard Control P. So with most likely, for example, let's click on this. So this parameter wants a view from us, or a view or layout res ID. This can take 3 arguments. So view, layout res, and view params, view group layout params here. You will learn what these are that layout, that activity main. So I want to talk about the parameter hints here. So the code editor may be configured to display parameter name hints within the method calls. So let's create another function here. For example, my function, my silly function, and this will be string, or actually it's, for example, fun name and surname, and the first is takes name string and surname string, and then clicking on pressing on Control Alt Enter, Shift Control Enter, Control Enter. This will create an example here. So when I want to show you in the parameter name hints here how using functions. Well, so let's call this so, and as you can see here, let's John Matilda here. As you can see in this shows the what name and surname is parameters. So this shows parameter name hints here. In addition to completing code as it's typed, the editor can, under certain conditions, also generate code for you. So the list of available code generation options shows here. For example, let click Alt and Insert. Here, when we click this code generation method will assign, but we will use these methods in later lecture actually. I want to show you how to do this. So you can click on override methods here. As you can see, we have so much methods by activity that, as you know, main activity is inherited from activity classes, from multiplicator, callback, and so you will learn all about that later. So now we have code folding here. Let's delete, or just let's. So code folding here. Once a source code file reaches a certain size, even the most carefully formatted and well-organized code can become overwhelming and difficult to navigate. Android Studio takes the view that it is not always necessary to have the content of every code block visible at all times. Code navigation can be made easier through the use of the code folding feature of the Android Studio editor. Code folding is controlled using the markers appearing in the getter, as we discussed it at the beginning, and at end of each block of code in source file. So clicking on either these markers will fold the statement, and such that only signature line is available as shown here. We can do like that. As you can see, we can do like that. As you can see, we closed all our main activity, but it's not deleted, it's visible anymore. We can, by clicking these codes here, we can bring them back. So I want to talk about you now the quick navigation, quick documentation lookup, or how to use them. Context-sensitive Kotlin and Android documentation can be accessed by placing cursor over the declaration for which documentation is required, pressing Ctrl and Q. As you can see, there's a navigation here, keyboard shortcut. This will pop up containing a relevant reference documentation for the item. For example, this shows Android set coordinate view functions documentation. So once displayed, the documentation pop-up can be moved around the screen as needed, as you can see here. Clicking on the push pin, the icon located on the right hand corner of the pop-up title bar will ensure that the pop-up remains visible once focus moves back to the editor, leaving the documentation visible as a reference while typing code. So code reformatting here. In general, the Android Studio editor will automatically format the code in terms of intending, let me check, oh yes, in terms of intending spacing and nesting of statements and code blocks as they are added. In situations where lines of code needed to be reformatted, a common occurrence, for example, when coding and passing sample code from a website, the editor provides a source code reformatting feature, which, when selected, will automatically reformat code. So we will learn about code reformatting later lectures. So in this lecture, we done actually this was the 3 lectures, right? Yes, this was 3 lectures actually. So we done Android UI and Android editors as well. You learned so much about Android Studio so far, and you will learn so much things in later lectures like Kotlin and so many other things. So I'm waiting you in next lecture. Thank you. All of the above data types are actually objects, each of which provides a range of functions and properties that may be used to perform a variety of different type-specific tasks. These functions and properties are accessed using so-called dot notation. This notation for dot here. Dot notation involves accessing a function or property of an object by specifying the variable name followed in turn by the name of the property to be accessed or a function to called. A string variable, for example, can be converted to uppercase method here. For example, my example, let's make a string and add var here and add to my little string here, and after that let's use my example dot up to uppercase here, as you can see here. So this will convert to uppercase our string literal. So for example, let's print our string literal to our activity main 1 minute text view. Okay, refactor. So let's find our text view here, which don't be worry, I will discuss this code later in course. I just want to show you example. For example, my text view text view text view here equals find view by id r.id dot text view here, and let's print our string to our text view dot my text view dot set text my example yes, my example, and let's run our code and let me show you our emulator here. As you can see here, this our Gradle is building now, so I will stop this video and continue after building Gradle. So our Gradle is built here, so let's wait for application to open here. Installing. As you can see here, they're launching layout activity, and applying filter here, and our activity will rank here. So as you can see here, our text view is not changed. Because of that, we make an uppercase here. For example, look at this. If we write this code here, we're gonna see an uppercase letter of my little string literal here. So let's run it again, and you will see that the string will change. But why this is not change? Because we don't change our string. With this method, we just wanted to return an uppercase version of our string, but we don't apply it to our string object, which we will discuss later later course about that. You will see more examples and how to do that proper way. As you can see here, we can see now our string literals uppercase method. So I will tell you as well, so just be patient, and we can do like that as well. For example, my example equals, assign it to my example dot uppercase, and let's do the same thing, and you will see that we are printing our uppercase letter as well here. As you can see here, our string is uppercase as well, but we declared it as lowercase words. So I want to talk about you the second example of type annotations and type interference. So Kotlin is categorized as a statically typed programming language. The essential means that once the data type of a variable has been identified, the variable cannot subsequently be used to store data of any other type without inducing a compilation error. This contrasts two loosely typed programming languages where a variable once declared can subsequently be used to store other data types. There are two ways in which the type of a variable will be identified. One approach is to use a type annotation the point the variable is declared in the code. This is achieved by placing a colon after the variable name followed here, and we put it here colon, and then we used text with class here. For example, this line of code, for example, user count here, integer and 10. This absence of type annotation in the declaration. The Kotlin compiler uses a technique referred to as type interference to identify the type of the variable here. When relying on the type inference, the compiler looks to see what type of value is being assigned to the variable at the point that is initialized and uses that as the type. Consider, for example, this declaration var signal strength is, for example, 2.200 okay, 2.231 here, or company name here, while company name equals TechPens here. During the compilation of these lines of code, Kotlin will infer that the signal string variable is the type of double here. And that the company name constant is string. But as you see, we don't write it in declaration here because Kotlin compiler will know it and assign right here string for us here. So when a constant is declared without the type annotation, it must be assigned a value at the point of declaration here, as you can see here. So if the type annotation is used when the constant is declared, however, the value can be assigned, for example, val is book nice, for example, and false here, or val course title here, and it's assigned to string here, as you can see here. So as you can see, we declare two variables that which is without declaration. As you can see, we can put the string, but it will throw an error because false is not a string value, so we can write this like this, but it will not a boolean, it will a string. Kotlin nullable types are a concept that does not exist in most other programming languages, with the exception of the optional type in Swift. The purpose of nullable types is to provide a safe and consistent approach to handling situations where a variable may have a null value assigned to it. In other words, the objective is to avoid the common problem of code crashing with the null pointer exception errors that occur when code encounters a null value where one was not expected. By default, a variable in a Kotlin cannot have a null value assigned to it. For example, let's assign a null value to some variable, and you will see more explanation. For example, val user name, and let's make it string and null. As you can see here, null cannot be a value of a null type string. So if a variable is required to be able to store a null value, it must specifically declared as a nullable type by placing a question mark after the type declaration. As you can see here, our error is gone. The username variable can now have a null value assigned to it without triggering a compile error, as you can see here. But if we delete the nullable type question mark here, this will throw an exception and our code cannot compile anymore and will contain our error. But after adding this question mark, the error is gone. Once variable has been declared as nullable, a range of restrictions are then imposed on the variable by the compiler to prevent it being used in situations where it might cause a null pointer exception to occur. A nullable variable cannot, for example, be assigned to a variable for non-null type as like this. For example, I want to show you some example. Val surname, and let's create an string here as well, declare, and username. Let's assign to username. So as you can see here, we will get an error, a type mismatch, because required string but without nullable, non-nullable, but our username variable here is string but nullable string. For basic explanation, the only way the assigned will be permitted is if some code and condition is added to check that value assigned to the nullable variable is non-null. So for example, we can do like that. If username is not null, you will see conditions and expression as well. You will learn about it. We just want to create an example here. If username is not null and val dot first val dot first name string here, string for example username, or Mamma Mia here. As you can see here, we have not error because Kotlin knows it. So the assignment will only take place, in this case, the assignment will only take place if the username variable references a non-null value. The save call operator. A nullable variable also cannot be used to call a function or to access a property in the usual way. Earlier in this lecture, we used two uppercase function was called a string object, given the possibility that this code caused a function to be called on a null reference. So this code I will write here is disallowed by the compiler here, and this will give an exception, an error here. Val, for example, val my name, and this net assigned to string here, use string and make this string nullable and assign to null here, and val uppercase my name, and let's do this and assign it to username and uppercase. Oops, no, username my name dot uppercase, as you can see here. The exact error you will see here on save or null null asserted calls are allowed on nullable receiver of type string. So in this instance, the compiler is essentially refusing to allow the function call to be made because no attempt has been made to verify that variable is non-null. One way around this is to add some code to verify that something other than null value has been assigned to the variable prior to making the function call here. Let's make an add condition here as we did earlier. So if my name is not equals to null, you will see conditional and expressions later lectures, next lectures. And while uppercase my name is equals my name dot uppercase. As you can see here, our error is gone here. A much more efficient way to achieve this same verification, however, is to call a function using the save call operator. So delete this now, and let's do another condition. Uppercase my name, assign it to my name dot or a question mark and dot to uppercase. In this example, if the username variable is null, the uppercase function will not be called and execution will proceed at the next line of code. If, on the other hand, a non-null value is assigned to uppercase, function will be called and the result assigned to uppercase my name variable. Let's discuss about not null assertion here. A not null assertion removes all of the compiler restriction from a nullable type, allowing it to be used in the same ways as non-null type, even if it has been assigned a null value. The assertion is implemented using double exclamation marks after the variable. For example, while username and add string and question mark equals null, and I want val length of our username and equals username dot double exclamation mark here and dot length. This code will now compile but will crash with let's compile it. It will crash, of course. I know that it will crash. As you can see here, our code is crashed because of this 19th line code. So clearly this causes the very issue that nullable types are designed to avoid. Use of the not null assertion is generally discouraged and should only be used in situations where you are certain that the value will not be null. Nullable types and let functions. Earlier in this lecture, we have looked at how the save call operator can be used when making a call function belonging to a nullable type. Let me delete this. This technique makes it easier to check if a value is null, and if a value is null and so let me check if our video lecture is recording. Yes. So this technique makes it easier to check if a value is null without having to write an if statement every time the variable is accessed, as we did earlier. Let me show you. We did earlier that. Okay, as you can see here, we will this with save with let function. This will more or less code. A similar problem occurs when passing a nullable type as an argument to a function which is expecting a non-null parameter here. And as an example, consider the times function of the integer data type. When called on an integer object and passed another integer value as an argument, the function multiplies the two values and returns the result. When this code, for example, I want to show you here. Okay, let's delete this and let's create a val first number equals to 10 and val second number equals to 20 and val result equals first number dot times second number. So let's print our result. Text view dot set text result dot to string. I want to show you here. Okay. As you can see here, our final result is 200. Now let me close this. So now, for example, let's create an second number non-null type. A problem, however, occurs if the second number variable is integer and non-null type. Here is an example. Second number will be integer but with no null type here, and as you can see we give an error basically because of the type mismatch. So now the compilation will fail, of course, with the following error message. Let's compile. As you can see here, we have a type mismatch error, which is our program is not compiled here. So let's fix this with another solution. A possible solution to this problem is to simply write an if statement to verify that the value assigned variable is not null before making this call function as we did earlier. Let's did another again, which I will show you the best result with how to use this result here. Okay, if our second number not equals to null and print this. A more convenient approach to addressing this issue, however, involves use of the let function here. Let's delete this, and so when called on a nullable type object, the let function converts the nullable type to a non-null variable and named it, which may be referenced within a lambda statement. For example, second number and second number here, and a question mark dot let and val. Oops, no, not here. For example, second number dot question mark dot let, and we will write our code val result here and equals first number dot times dot it here. In it is the second number here with let keyword. Note use of the save call operator when calling the let function on second variable. In this example, this ensures that the function is only called when the variable assigned to non-null value. We have another way to initialize null values, which is late init function. Late initialization or late init. So as we previously outlined, non-null types need to be initialized when they are declared. This can be inconvenient if the value to be assigned to the null variable will not be known until later in the code execution. One way around this is to declare the variable using the late init modifier. This modifier designates that a value will be initialized with the value later. This has the advantage that a non-null type can be declared before it is initialized, and with this advantage that programmer is responsible for ensuring that the initialization has been performed before attempting to access the variable. For example, consider this variable declaration var my name string. Clearly, this is invalid since the variables is a non-null type but has not been assigned a value. Suppose, however, that the value to be assigned to variable will not be known until later in the program execution. In this case, the late init modifier can be used like this. Late init here. So, with the variable declared in this way, the value can be assigned later. For example, my name Android Studio here. Of course, if the variable is accessed before it's initialized, the code will fail with an exception. For example, let's print our my name. Print here my name. Oops, not my name. My name. As you can see here, we have not an exception here. Late init var my name's string. If you put this here, this will give us an error here. So we have an else operator as well here in Kotlin. The Kotlin else operator can be used in conjunction with nullable types to define a default value that is to be returned in the event that a value or expression result is null. The else operator is written like this. Oops. Else operator is written like a question mark and 2 colon. It's used to separate as an else operator is used to separate two expressions. If the expression on the left does not resolve to a null value, that value is returned. Otherwise, the result of the rightmost expression is returned. This can be through a quick alternative writing of an if-else statement to check for a null value. For example, let's create an example of if let's create my string var my string here and assign make it string and if it was for example hello world, and here if in traditional way with conditions without else operator, we as you learned, we've written expressions conditions like that, which we haven't been discussed conditions. You will learn condition in depth in later lectures, next lectures. And if my string not equals to null, then return my string here, else here string return string is null here. So the same result can be achieved as with else operator here. Let me do this. Okay, let's do this condition with else operator. Return my string and my string question mark and semicolon here, and string is null, so you can see here. When compiling Kotlin code, the compiler can typically infer the type of an object. Situation will occur, however, where the compiler is unable to identify the specific type. This is often the case when a value type is ambiguous or an unspecified object is returned from a function call. In this situation, it may be necessary to let the compiler know the type of object that your code expecting to write code that checks whether the object is of a particular type. Letting the compiler know that the type of object that is expected is known as a type casting. Type casting is achieved within the Kotlin used code using the as operator. I want to write code, for example, lets the compiler know that the result returned from the this code here, for example, val kmgr equals get system service here, and context dot keyword service as word manager, keyword manager here. So the Kotlin language includes both save and unsave cast operators. For example, with this unsave, this is the save cast operator, and this is the unsave cast operator in Kotlin. So this code is an unsave cast and will cause the application to throw an exception if the cast cannot be performed. A save cast, on the other hand, uses as question operator and returns null if they cannot be performed. For example, a type check can be performed to verify that an object conforms to a specific type using is operator here. For example, if kmgr is keyword manager, then do something here. In this chapter of our Udemy course has begun the introduction to Kotlin by exploring data types together with an overview of how to declare variables, and this lecture has also introduced those concepts such as nullable types, the type casting, the type checking, and the else operator, each of which is an integral part of the Kotlin programming and designed specifically to make code writing less prone to error. Throughout this Udemy course, I will use simple English to explain a number of technical concepts. I will not ask you to answer the technical explanation of a Kotlin or Android concept that has not been previously explained in a non-technical language. A note to Java programmers who are new to Kotlin: if you have done some Java programming, then things are about to get weird. You might even swear that I have made some errors. Perhaps you might even think that I have forgotten to add semicolons to the ends of all the lines of code. I urge you to keep watching our video lecture, because I think you will discover that Kotlin has some advantages over Java. Because it is more succinct and expressive, learning Java still has its place because most of the Android APIs is still Java. And even if the entire Android community were to drop Java immediately, and they haven't, there will still be legacy Java code for years to come. I won't continually point out the differences between Java and Kotlin because there are so many and such an analysis is not unnecessary. If you are interested, I recommend search in Google, and you will find sufficient answer to your questions. Ultimately, Kotlin and Java compile to the exact same Dalvik compatible Java bytecode. In fact, Java and Kotlin are 100% interoperable and can even be mixed together in a project. You can even paste Java code into a Kotlin project and it will be instantly converted to Kotlin. The Kotlin and Android communities are full of people who speak in technical terms. Therefore, to join in and learn from these communities, you need to understand the terms that they use. So the approach to that this course takes is to learn a concept or get a broad outline using entirely simple language, but at the same time introduce the jargon or technical terms as part of the learning. Kotlin syntax is the way that we put together the language elements of Kotlin to produce the code that executes as you see here. The Kotlin syntax is a combination of the words that we use and formation of these words into sentences like structures that is our code. These Kotlin words are many number, but taken in small chunks. They are certainly easier to learn than any human language. We call these words keywords, like this, and this, and of others, of course. I'm confident that if you can read plain English, then you can learn Kotlin, because learning Kotlin is much easier than learning to read English. So what then separates someone who has finished an elementary Kotlin course, such as this one, and an expert programmer? The answer is the exact same thing that separates a student of a language and a master poet. Expertise in Kotlin comes not in the number of the Kotlin keywords and we know how to use, but in the way that we use them. The mastery of the language comes through the practice, further study, and using the keywords more skillfully. Many consider programming an art as much as a science, and there is some truth to this. So the first I want to explain you the commands in Kotlin, which is necessary for programming uh, in Kotlin. So as you become more advanced at writing Kotlin programs, the solutions that you use to create your programs will become longer and more complicated. Furthermore, as we will see in our later lectures, Kotlin was designed to manage complexity by having us divide up our code into separate classes, usually across multiple lines. Code commands are a part of the Kotlin files that do not have any function in the program execution itself. That is, the compiler ignores them. They serve to help the programmer to document, explain, and clarify their code to make it more understandable to themselves later, or other programmers who might need to use the change. I want to show you some examples. So this is the single line comment. I think let's increase bit of font size. Okay, this is a single line comment. The present comments begins with the two forward slash characters, as you can see here. If we delete just the one slash, this will be no more comment. So this and is a keywords. So Java Kotlin, our IDE reads these words as a keywords, and some things that is like variables or some, but you need to be comment these words. You need two slashes here. So anything on that line is for people only, whereas anything on the next line, unless it's another comment, needs to be synthetically correct Kotlin code. For example, this code is comment, but this is not comment. As you can see here, this is not commented, and the Java will compile it and then error because there is not such a code here, and this is incorrect code. We can use multiple single line comments like this, line comment line number 2 and comment line number 3. So we can, as much as we want, we can use these comments for explanation, but more that every explanation of our code is not necessary because it takes long time. Single line comments are useful if we want to temporarily disable a line of code, so we can put double slash in front of the code and it will not be included in the program. As you can see here, there is two codes that we have main method here on create that overridden by app compat activity. When our app runs, these two codes is runs because the first code is, I will explain later. The second code is assigning our activity main layout to main activity here. So if we comment this code, this code is will no longer be runnable, and Java will not compile it as a code, but instead it will compile it as a comment. But it will not compile, of course, because comments in Java is not compiling. It just the compilers just ignore the code here, the comment here. So in this situation, the layout will not be loaded and application will have a blank screen when run, as the entire line of code is ignored by the compiler. There is another type of command in Kotlin known as the multi-line command. So the multi-line command is useful for longer commands that span across multiple lines and for adding things such as copyright information at the top of the code file. Like the single line command, a multi-line command can be used to temporarily disable code. In this case, usually across multiple lines. Everything in between the landing slash start character and ending slash character is ignored by the compiler. So let me do an example for you. Like activity main, let's add some code. R dot layout dot activity main here. As you can see here, we have 3 lines of code here, but if this code is causes some errors, we can comment this for testing our another lines of code. So for commenting multi-line codes, you just need to put these symbols here, and as you can see here, because we don't close our comment section here, these two brace comments as well, and our code throws an error here. So after commenting this, we're gonna comment the r.layout activity mains class after. As you can see here, when I press enter, the integrated development environment is closed this comment already. So this method throws an exception here as well, because this needs the super.onCreate method to be successful use. So let me add this, and our errors is gone. But these comments can be used for adding copyright information to before the code. So let me do this. Okay, copyright techbills.com. As you can see here, we added our copyright information. For example, this is not a real one or licensed one. So there is no limit to the number of lines in multi-line command. The type of command that is best to use will depend upon the situation. In this course, I will always explain every line of code explicitly in the text, but you will often find liberally sprinkled comments with the code itself that add further explanation, insight, or context. So it's always good idea to read all the code thoroughly. So in Kotlin, we have variables as well, which I will discuss in a later lecture. We can already add, take away, multiply, divide, assign, increment, decrement with operators. Now we will explore some more useful operators, and then we will go straight on to learning about how to use them. We use operators to create an expression that is either true or false. We wrap expressions in the parentheses or brackets. The comparison operator. The comparison operator is written in programming is written like double equality, and it tests for equality and is either true or false, which means 1 is corresponds to true or 0 is corresponds to false, and it is the Boolean type. Boolean. An expression such as 9 equals expression 8, for example, is false, is equals false, because 9 and 8 is different numbers, and they are false because they are different. And if this will be 9 equals 9, it will be false because they are same bits. So it compares the numbers and bits here. As you know, everything in programming is bits, which is true or false. This is not equal to 9. However, an expression such as 2 plus 2 that equals 4 is obviously true, because we firstly we are assigning something here, arithmetics, which is this is equals to 4, and we are comparing it. If 2 plus 2 equals 4, then this will return true. The logical not operator. The logical not operator is written like this, Turner operator. It's used to test the negation of an expression. If the expression is false, then the not operator causes the expression to be true. For instance, I want to show you that something in here, let's open braces, and here plus 2 is equals to, we assigning it that equals 5 here, and let's close the braces here. So, and I will tell you what is this. So as you know, here we tested them, these operators, 2 plus 2 equals 4, which is this returns true here. But 2 plus 2 is equals 4, and because 4 is not equals to 5, this will return false, of course, as you know. But if there is operator that's not operator, this is logical not operator, this will return true. So if 5 equals 5, but you are adding this here, like this normally this is the true, but if you add this before or after the comparison, this will return false, because this is true. But if this is the 5 equals comparison, 5 comparison with 4, this will return true, because this false. So this bitwising operators here. You will learn about more explanations. We will do more explanations later of our video course. So the not equal operator. So I want to show you the not equal operator here. That I think you seeing let good, but I want to increase the font a little bit for better understanding. And here, so now I will explain you the not equal operator, which is not equal operator is coded like this. One ternary and one equality operator is not equal operator, and these not equal operators test whether something is not equal. For example, I want to show you something that 10 not equals to 9 will return true, of course, because why? So if we've written like this will return false, but not equals. So if 10 and 9 isn't 10 and 9 not equal, yes, so it will return true basically. So the greater than operator, I want to show you that. Let me show you. So the greater than operator. Another comparison operator, and there are a few more like this as well, is the greater than operator. This operator tests whether something is greater than something else. The expression like 10 greater than 9 will return true, because it is asking, is 10 greater than 9? So yes, so it will return true here. Is my voice recording? Yes. I think we are going good. If you have any questions, let me ask you in your questions section, and I will answer your question as fast as possible as I can. So the less than operator I want to show you, this is the opposite of greater than operator. So less than operator is 10 less than 9. So we are asking here, is 10 less than 9? So no, 10 is greater than 9, so 10 is not less than 9, so this returns false. We have the greater than or equal to operator written like this. This operator tests whether one value is greater than or equal to other, and either is true, the result is true. This is what the operation looks like here. This is just for looking good. This is the operator of our greater than, which we have less than or equals to operator as well. I will discuss it later. So as an example, the expression 10 greater than or equal to 9 is returns true. So 10 is 10 greater than or equal to 9. Yes, we have one expression is here completing. 10 is greater than 9, but 10 is not equal than 10 is not equal than 9. So it will be return true because greater than is works, but this works as well. So then now the 10 is equal, but the 10 is not greater than 10. So this will not work. This will work here, and this returns true as well. So this is the Same operation as this less than or equal to operator. This operator tests whether one value is greater than or equal to the other. And if either is true, the result is true. This is the what operator looks like. And as an example, the expression 10 is greater than less than or equal to 9 is returns true. Because oops, I'm sorry, less than, it's not returns true, actually it returns false here. Oops, what's happened? Okay, is 10 greater than or equals to 9? Less than, oops, I'm sorry, less than or equals to 9? No, this is returns false here. And we have logical AND operator as well, which I want to explain you. This is the necessary operations, logical and logical OR. So it is, I think this is the this can be compliant of so much, because I think I have so this operator is corresponds to this, but in not same way, the other way. So the logical AND operator. This operator is known as the logical AND. It tests two or more separate parts of an expression, and both or all parts must be true for the entire expression to be true. Logical AND usually used in conjunction with the other operators to build more complex tests. The expression like this so 10 greater than 9, and to AND operator, and is 10 less than 11 here. This is true. This returns true because both parts are true. So is 10 greater than 9? Yes, it's true. Is 11 greater than 10? Is true. So true and true returns true here. So, but I want to show you more examples here. And let's copy this. So, and 9 greater than 10, this returns false, because this returns false, but this returns true, and this will return false. To be successfully to be get and true with AND operator, you need the both sides returns true. There is another expressions that logical on AND expression, which this is not this works the same but not the same way. So let's show you. So AND operator here, or logical or operator here. So logical or this operator called logical OR, and it is just like logical AND, except that only one of the two or more parts of an expression needs to be true for the expression to be true. This is the writing like that way. Take another look at the previous example that we used for logical AND here. But instead replace with and with these two pipes here. The expression I want write you here. So as you may see, this this one side, this expression's one side is false, the other side is true. So here this is the copy of this as well, but this returns true here because the OR operator for successing OR operator to getting true value from OR operator, you need to just the one side to be needs to be true. So if in operator one side in 2 is true, then operator needs returns true. But if two side is false, then operator returns false, of course. It's more not complicated, but it's just a little has little change with AND operator. So in the programming you will use this as well. Let's make another example for better understanding. Okay, so 10 is, so this is a two false here. 9 is not equal, 9 is not greater than 10, or 10 is not greater than 11. This will return false because we have not true here. They are both false. Seeing the operators in more practical context in this lecture and through the rest of the course, we will help to clarify their different uses, and we will discuss them later on this course. Now we know how to form expressions with operators, variables, and values. Next, we can look at a way of structuring and combining expressions to make several deep decisions. In this video lecture, you will learn operators and expressions. Of course, in almost any program, we are going to need to do things with these variable names or something else. We can manipulate and change variables with operators. When we combine operators and variables for a result, it's called an expressions. We already saw the first operator when we initialized our variables in the previous lecture. But we will see it again being a bit more adventurous. The assignment operator. This assignment operator, I want to, for clearly, I want to name the operators as we talked about that. So equals assignment operator. So this is the assignment operator. It makes the variable to the left of the operator the same as the value to the right. For example, like car model equals car name. Now this is the because we assigned this val here. As you remember from our previous lectures, val values can be assigned for once and cannot be changed after. It's like final in Java, but in Kotlin we are using val for final, so like Java. It's alternative. So instead of var, we're gonna use var here, and our error is gone. Now our car model name is equals to my little lowly me. So let's look at what is our car model. Log.e and log here and car model. Here you go. Yes, and let's run it on here BlueStack. Yes, now it's compiling. You will see here car model variable is equals to my little me here, and let's open the log. I will explain you later what this log means. I changed to info here. Okay. Okay, as you can see here, I want close our the emulator here. As you can see here, with log.e method, I printed into the logcat in information section here, and as you can see here, we want to print our car model here, and this log printed my little lovely BMW. This is because in car model we assigned the car name. So our car model is not anymore BMW. Instead, my little lovely BMW is car model. We can do it other bit more, like we can assign a car name to car model. Then our car name will be car model BMW, and our car name will be same because we're assigning it. We don't doing anything to car name here. So the addition operator I want to discuss about, which is here. Oops. Addition operator here. And what does this addition or operator do? It will add together values on either side of the operator. It's usually used in conjunction with the assignment operator. For example, it can add together two variables that have numeric values like this. For example, I want created new value named total, and it's equals to and it's equals to total equals to car model plus car name and plus year and to string here, to short, no, not too short, to string. Let's print total to our log here. As you see here, our build is successfully compiled, and as you can see here, our text is equals to my BMW. This is the car model, and my little Lolo BMW is car name, and the year is BMW 1998. So now we can I think this is the good explanation for you. Now we can print on to the text box, text view, which I will discuss later. Now we are learning the Kotlin fundamentals, things, how to write applications in Kotlin. Then we will learn a lot of things about Java. Once this code has executed, the sum of the values held by total and will stored on total. As another example of the same thing, it can be useful like if now val now so equals now we're 2028 the year, and we can subtract total from the year now for finding our BIMIS year. So your BIMI is and plus here what so we want if we want to how old find how old our BMW is, we have to subtract this from this. We have to subtract this from this. So now minus I think it's best to now minus year here, old, and add old here old. Oops, not like that. Old here. So now we want to print on text view, which don't worry about it. You will learn what is how to print text with and change text with text, and I will create just text equals text view here, and this equals to find view by id or dot id. No, find view by r dot id dot we want to change the activity main. What is the text view of our activity main, and change this id of our text view, and Android id here, id text. Okay, and text. Okay, so let's enter. Okay, now we can take by text dot set text, we can set to this text our last record. So font size, no, we can change this from this font family, text size, oops, text size, yes, text color, text local, text size, bigger is better. Okay, so text dot set text total here, and now run the application. Put stacks here. As you can see here, your BIMI is 23 years old, so we can we subtracted from 2028 and 1998, and we found our BMW is 23 years old by using subtraction and multiplication plus addition operator. So now I want to discuss about you that subtraction operator. We have discussed that, but I want to discuss that as well, because the subtraction operator has mathematical operators as well. So subtraction operator, I want to close our blue stack here. So this is a subtraction operator. We've done this. We subtracted now to year, and we found 23 as a result with subtraction. And we have a division operator as well. It will divide the number on the left by the number on the right. Again, it's usually used in conjunction with the assignment operator. So here an example I want to show you that, like, for example, I want to like what we can do here. Okay, just I want here. Let's make it 2, and let's make it 1000 011. So for example, we want we now want to create a var that total, and it will be integer, of course, because we're gonna divide our integers here, and we want 2022 division by 1011 here. And let's run our code. This finds the text view, assigns it to it, which we will discuss later. You will learn how to use these methods and class, and we are setting this text to total here. Let's run it again. So this is because we cannot assign, we have to assign it string, but the total of our sum is equals to 2, which we will see. So we in order to assign this as a string, we have to plus just the two braces here, or we can use that to string for changing it to string. Now the problem will not happen again. As you can see here, our total, the division of 2022 to 1011 is 2, which we will do later. Lots of things about these operators. So the one operator that has, if of course you know it, is multiplication operator. Let's write division here, division operator, and we now this I will teach you the multiplication operator here. Okay, multiplication operator, multiplication sorry, multiplication operator. This is the multiplication operator. It will multiply variables and numbers together, and as with the many of the other operators, is usually used in conjunction with the assignment operator. For example, like we want multiply, we want multiply these numbers, like 10 multiply, 10 multiply, why this happens? Yes, 10 multiply 20, 12 multiply 15, and let's print this to the our text view here. You can multiply your variables, integer variables, as well as we done earlier. As you can see here, our result is 100,000, and I will teach you the increment operator, which is increment operator. This operator is a quick way to add 1 to something. For example, like if we have integer 5, no integer, integer 5, and this equals to 5. So if you put this 5 plus plus, this will increment your 5 by 1. And then you can set to text dot set text here, and 5 equals to 5.2 string for not being problem here. So so let's run our code here. As you can see, our result is 6, because 5 is incrementing operator and increments a variable by 1. So if we do this like this, 5 plus plus and 5 plus plus 5 plus plus 5 plus plus again and again and again, you will see the this is the 6, 7, 8, 9. As you can see, there is a 9 total of our 5, because we incremented 1, 1, 1, 1, and the final result is the 9. The decrement operators works like the increment operator, but instead of incrementing, it decrements by 1. So decrement operator. So as you can see here, we have a variable 5 here. So let's make it with decrement operator and see what happens. 5 minus minus 5, oops, 5 minus minus 5 minus minus 5 minus minus 5. And let's see what happens now. As you can see here, our total result is 1 because we incremented our 5 4 times. So this is the 4, 3, 2, and 1 last result. And after 1, we're finding our text view here, as you can see. And then we setting the text to set text, and we want to use 5, and because of 5 is integer, it will give us an error. So we converting this to string with toString method. We have done so in every operators for examples. So later on this lecture, you will learn decisions and loops on Kotlin. Thank you for watching. I hope you have a nice day, and goodbye. In this lecture, we're gonna discuss about variables, and I will show you some examples of variables and how variables works. So let's get started. We can think of variable as a named storage box. When choose a name, perhaps variable A, these names are the programmer's access into memory of the user's Android device. Variables are values in memory that are ready to be used when necessary by referring to them with their name. Computer memory has highly complex system of addresses that fortunately we don't need to directly interact with. Kotlin variables allows us to devise our own convenient names for all the data that we need or have to work with. The operating system will, in turn, interact with the physical hardware memory. So we can think of our Android device's memory as a huge warehouse waiting for us to add our variables. When we assign names to our variables, they are stored in the warehouse, ready for when we need them. When we use our variables names, the device knows exactly what we are referring to. We can then tell it to do things such as assign a value to variable A, add variable A to variable B, test the value of the variable B, and take an action based on the result. In the typical applications, we might have a variable named unread messages, perhaps to hold the number of the unread messages that the user has. We can add to it when a new message arrives. Take away from it when the user reads a message and shows it to the user somewhere in the application's layout so that they know how many unread messages they have. Situation that might arise can include the user gets 3 new messages, so add 3 to the value of unread messages. The user logs into the applications, so use the tools to display a message along with the value stored in unread messages. The user sees the couple of messages are from someone that don't like and deletes 2 messages. We called then subtract 2 form of unread messages. Variables names are arbitrary, and if you don't use any of the characters or keywords that Kotlin restricts, you can call your variables whatever you like. In practice, however, it's best to adopt a naming convention so that your variable names will be consistent. In this course, we will use a simple convention of variable names starting with a lowercase letter. When there is a more than one word in the variable's name, the second word will begin with an uppercase letter. This is called a camel casting. So here's some of examples of camel custom variables names, like Uber driver. Here, as you can see, our first word starts with lowercase letter, then words after the first word, second, third, or any number of word, the first word of number words will begin with the uppercase letter. So the second examples of is friend, or boy playing in garden. As you can see here, the first letter of our boy is started with a lowercase letter, and the second, third, and fourth words started with uppercase letter, and this named camel casting. Before we take a look at some real Kotlin code that uses some variables, we need to first look at the types of variables that we can create and use. Types of variables is not hard to imagine that every simple application will have quite a few variables. In the previous section, we introduced the unread messages variable as a hypothetical example. But if the application list of contacts needs to remember each of their names, then we might need variables for each contact. And what about when an application needs to know whether a contact is also a friend or just a regular contact? We might need to code that test for a friend status and then adds messages from that contact into an appropriate folder, so that the user knows whether they were messages from a friend or not. Another common requirement in computer program, including Android applications, is the right or wrong test. Computer programs represent right or wrong calculations using true or false, or one or true. To cover these and many other of data you might want to store or manipulate, Kotlin uses variables of different types. There are many types of variables, and we can even invent our own types as well. But for now, you will look at the most commonly used Kotlin types, and these will cover just about every situation that we are likely to run into. The best way to explain types of truth numbers of examples. We have already discussed the hypothetical unread message variable. This variable is, of course, a number. On the other hand, a hypothetical contact name variable will hold the characters or letters that make up a contact's name. The type that holds a regular number is called an int, an abbreviation of integer. So it's like this, integer. And the type that holds name like data is called string. Here is the list of types variable that we will discuss in this course. This is the first is integer. Okay. So the second is string. The third is long. It's better to write long under the int, because long is number as well. The float is the number as well. The double the double is double and float is the same thing. So I first want to explain, as you know, integer is just a standard number variable. Long is the as the name suggests, long data types can be used whenever larger numbers are needed. A long variable can store numbers up to I want to copy that because it's so long. Logically, long is for that if you have more than a very long integer, then integers have excess of 2 billions. but in longs the situation is not the same. So long can store, I want right here, long variables can store up to up to that much variables long can store, but the integer can store less than long and can up to 2 billion. But there is a one variable as well, this which is short, can store less than integer. Then we have a float variable as well here. The float variable is used for floating point numbers. That is, numbers where the precision is beyond the decimal point. As the fractional part of a number takes memory space, just a whole number part. The range of a number that is possible in a float variable is therefore decreased compared to non-floating point numbers. So unless our variable will use the extra precision, float will not be our data type choice. So we have a double data type as well. Double when the precision in a float variable is not enough, we have double. So double can store more variable than float. Here we have boolean as well. Boolean, which boolean can store two variables. We will using plenty of booleans throughout this course. The boolean variant variable type can either true or false. Okay, so true or false, nothing else. The booleans can be true or false. So booleans answer questions such as is the contact a friend? Are there any new messages? If yes, then the boolean variable has to true. If no, the false. So boolean variables is just variable type can be either true or false, nothing else. We have a character as well, which is char here, and the char character, this stores a single alphanumeric character. It's not going to change the world on its own, but it could be useful if we put lots of them together. So char is like one alphabetic number or one character that uses ASCII numbers. I will discuss what is the ASCII numbers as well, like A, B, or just the character code, char code, like this. So character has very less amount of memory to allocate. So if you want long messages, you need to use string. We have a string as well. String can be used to store any keyboard character. It's similar to a char, but of almost any length. Anything from a contact's name to an entire book can be stored in a single string. We will be using strings regularly, including this lecture. This is the class after the string class here. Class, this is the most powerful data type, and we have already discussed it a little. We will take a deep dive into later of our Udemy course. And the lastly I want to talk about is array. Array, this type comes in lots of different flavors and is key for handling and organizing large sets of data. We will explore the variations of array in later of our course. So just be to be mind, arrays can be strings of array, characters of array, booleans of array, doubles of array, and arrays can be used any object and multiply use them inside of them. So we will use array later of our course with good explanation about. So arrays is not hard, but it's good to explain by another lecture. I want now to declare and initialize some variable here. Before we can use a variable type that we just discussed, we must declare them so that the compiler knows they exist. And we must also initialize them so they hold a value. For each of the variable types in Kotlin, such as integer, integer, float, string, boolean, there are two keywords that we can use to declare them: val or var here. The val type is for storing values that are decided by the programmer before the application starts or during the initialization and cannot be changed again during the execution. The var type is for values that can be manipulated and altered through the execution. Therefore, the val type is only readable here. In technical terms, it's known as the immutable object type. The var type is readable and writable, and this is called mutable. So I want to mention about that. Immutable, and val is immutable and var is mutable. So var can be changed or read it, but val cannot be changed, but it can be read from application. So writing code that attempts to change the value of val during the execution will cause Android Studio to show an error and code will not compile. There are also rules for var that we will explore it later. There are two ways that we can declare and initialize string type first by using val. So I want to delete these explanations for testing our explaining our val, how to use val here. So we want to create a string name that uses TechBeans Academy, carries TechBeans Academy inside of string. So val, we're gonna use val. And we are using val, as we mentioned earlier, val is immutable. We can read the val, but after assigning the val, we can't change it. So it's like a CDR. You can write it once, but you cannot change it later. So val contact name here, and after two dots here, and type string. So we are creating the string variable here and typing our TechBeans Academy here. So in the present this line of code, a new val variable named contact name and of the type is string is declared and now hosts the Gordon TechBeans Academy value. Furthermore, the TechBeans Academy text is not the only value that contact name can hold for the duration of the application's executions. You could attempt to change it with the following line of code, like contact name equals like techbeans.com. As you can see here, val, the integrated developed environment, introduces us that val cannot be reassigned. So the val variables you can assign once. Val can be assigned once and cannot be changed. Okay, so as you can see, we cannot compile it because it throws errors. We cannot reassign val here. But here is what we will see if you paste. Of course, we cannot change it, so we deleted it. But if we change this val to var, we can change our string variable here, like contact name equals techpins.com. As you see here, there is no error thrown, so we reassigned our Techpins Academy to techpins.com using var. So if we use val, this cannot be assigned here. This code, we use var to declare string type, and this time we successfully changed the value held by contact name to techpins.com. The point to take away here is that if the variable does not need to change during the execution of the application, then we should use val, because the compiler can help to protect us from the making mistakes. Now let's declare and initialize some different variables, like some vals, or using vals, or some vars. So let me delete this. So let's create an integer firstly, because integer are our lovely variable here, val, let's write episodes of The Walking Dead. So here, and we're gonna pair double dots and paste integer, and like The Walking Dead was 10 seasons, and I think it was 10, so 100 here. As you can see, our variable successfully declared, and we can declare p-value as well with float, of course, because we cannot declare the p-value with integer. It will throw an exception, as you can see here. Why? The floating point literal does not conform to the expected type int. So in order to do that, we have to change to 10, or we have to make it float. And as you can see here, there is an error as well. So if you want to declare a float number here, you need to add f after your variable. So we want 10 here, 100 here, and change it to int. We will declare float as well. Float is best example for using float is the p-value. So p-value is 3.14. So let's assign a p-value to our p variable, val p float equals 3.14f, and as you can see here, we get a p-value here, and let's create another long, so var, like what we can do, kilometers per hour for light speed. Val hash light speed and long. So here we can assign it like very long integers as well, like this. It will not throw an exception for us. Now I want to show you that why it's not thrown exception, because long has more. As you can see here, these are the both integer numbers, but long can hold more variables than integer. so it uses more random access memory in your device. As you can see, we cannot assign that because the integer literal does not conform the expected type integer. So this is the long. So we will return to back, and we have boolean as well. So val like let's write Android is nice, and we gonna use boolean for assigning a true or false. Boolean equals true. Yes, Android is nice operating system. And let's create an boolean as well. Well, is learning good, and we assign boolean here. Boolean. This is true as well. Learning is good. And let's go. Let's assign now an string literal here. String. What we can name our website, and string here equals techbeans.com. So we can assign string literals here, or we can use like another string we can use var our Udemy website string equals udemy.com here. So now let's try changing these variables here. So we can change our website here. So reassign it like our website equals google.com. As you can see here, we cannot reassign our website because our website is declared with vals. So as I mentioned earlier, the val variables cannot be reassigned. Val variables can be assigned once when application starts and then cannot be changed. So if we change val to var, then our problem will be successfully handled here. So notice that in this code, I declared variables as val when they are unlikely to change, and as var when it's likely they will change. As you develop your own app, which we will make it a wide variety of applications, we will develop it. You can guess whether they use val or var, and if necessary, you can change a var variable to a val variable here. Or the other went around. Also in the preceding code, the string types are initialized with the value between speech marks, but integer, float, long, and booleans are not. Saving keystrokes with interface. Kotlin was designed to be as sufficient as possible. It was one of the aims of the JetBrains team to let the developers get as much done with a little code as possible. We will see examples of this throughout the Kotlin language. If you have previously coded in another language, especially Java, you will notice a significant reduction in typing. So as you see the starting of our course, I accidentally putting this end line code of Java. So in Kotlin you can use that for like similarity, but it's not necessary. It's best to don't make this unnecessary. So Kotlin can often infer the type you need from the context, and if this is the case, then you don't need to write the type explicitly like this here. So we explicitly mentioned that we want string here, but we can declare, as you can see here in these examples, we declare the techpins.com that using string type called our website is declared and initialized using techpins.com here. If you think about it for a moment, it must be a string. Fortunately, this is obvious to the Kotlin compiler too. We could and should improve presenting a line of code using type interface, such as within this code we can like var Android users equals Java and Kotlin. As you can see here, without passing this string, the Kotlin interpreter is know that this is the string type because this is double here. And if we put this integer, write this integer here, this will throw an exception here because type mismatch. This is the string, but we writing that this we want integer. This is not going to happen, so we can the variables, string variables or any variable can be declared without mentioning the object type here. We must remember, however, that although we haven't specified string explicitly, it is still a string type and only a string type. If we try to do something unsuitable string type, then we will get an error, as we explained extensively. So we will see more types interface with variables in the next two lectures, and in later chapters we will use the type interface with more complex types such as classes, arrays, and collections. Type interface will also become a good time saver by making our code shorter and more manageable. As you can see here, there is a huge differences between this string and this string. So imagine you assigning 100 strings in your code. This will be a lifesaver for programmers, of course. So it might be sound obvious, but it's worth mentioning that if you're declaring variable for initialization, later the type interference is not possible, like this, like var computer model here. As you can see here, there's interpreter thrown as an exception here. So the variable must either have a type annunciation or to be initialized. So the line of code will cause an error and application will not compile. When using the type interface, it will usually be always what type of variable is, but if there is any doubt, you can select a variable in Android Studio by pressing Shift, Control, and P simultaneously to get handy on current hint. So to getting Shift, I want Shift plus Control and plus P here. Let's press that Shift Control P here. So as you can see, nobody here. So Shift Control P is selecting a line here. Selecting line. Shift Control P. No type, no body, and this thrown as exception here. Let me drink water, please. So omitting this oscillational string int or colon type isn't going to type much on its own. So let's learn how to make expression with our variables by combining them with operators in the next lecture. Here we will learn, let me delete this, okay. Here we will learn how to repeatedly execute portions of our code in a controlled and precise way by looking at several types of loop in Kotlin. This includes while, do while, and for loops. So in Kotlin, we have three loops mainly: while, do while, and for loops. We will also learn about the most appropriate situations in which to use these different types of loops. It's completely reasonable to ask what loops have to do with programming, but they are exactly what the name implies. They are a way of repeating the same part of the code more than once, or looping over the same part of the code, although potentially for a different outcome each time. This can simply mean doing the same thing until the code being looped over, iterated, prompts the loop to end. It could be a predetermined number of iterations as specified by the loop code itself. It might be used until a predetermined situation or condition is met. Or it could be a combination of these things along with if, else, and when loops are part of the Kotlin control flow statements. We will look at all the major types of the loop that Kotlin offers us to control our code, and we will use some of them to implement a working mini application to make sure that we understand them completely. Let's take a look at the first and simplest loop type in Kotlin, which is while loop here. While loops, Kotlin while loops have the simplest syntax. Think back to the if statement for a moment. We could use virtually any combination of operators and variables in the conditional expression of the if statement. If the expression is evaluated to true, then the code in the body of the if block is executed. With the while loop, we also use an expression that can evaluate to true or false. I want to show you an example of while loop. So let's create a var that named assign it to 10 here, and let's create our loop now. While x is greater than 0, then print to log e x equals x equals and dollar sign and x here, and then x minus minus. So the first block of our code is outside of the while loop. So we're assigning integer to x named x is declared and initialized to 10. So we have here a while code. The while loop begins here. It's the conditions if x greater than 0. So while x greater than 0, this code will run. So the codes here you can see here. The first we will print using log.e command to our logcat. But we will do this in user interface as well. So the first time we run our while loop, now x minus minus, as you know, this is the decrement operator. You learned this in previous lectures. So x now 9, 8, 7, and until the while loop x is not greater than 0, the loop will stop and loop will not work anymore. So I want to show you by live examples. Let me open our Android debug device here, and let's run it. So our program is compiled and is now installing to our application. Let's open the logcat and press on info. So our code is run here, and lastly in one stopped because the while loop condition is while x greater than 0 is run the code, but if else then don't run the code, then stop the loop. So as you can see here, our loop worked in 9 times. 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 9 10 times. I'm sorry, 10 times our loop has worked. After last one, the loop is stopped and loop will not work anymore because x is now equals to 0. Because of that, y is 0, because we firstly we printed our this x to log and then incremented. So after incrementing, we don't printed our x's value. So x actual value is 0. So let me do one example for clear explanation. I will create a method outside the loop so you can see the final value of x. Final value of x here, and okay, and x. Here you can see, as I said earlier, let me show it is okay. As I said earlier, x final value of 0, but it doesn't print it in while loop because we're printing before subtraction x, and we printed while loop is broken and not working anymore because it's done its job, and here we printing our x final value here. So let's the previous lecture we have I have introduced you the operations and expressions here. We can use expressions in loops as well. So in the same way as the if statement, it's possible that while loop will not execute even once. Take a look these examples here. We can use while expressions in while loop. So for example, we have a name message, for example here, var new messages equals is 3, and var unread messages equals 0, for example. And for example, while new messages is greater than or unread messages is greater than 0, then run this loop, and this will print our messages while this new messages is greater than 0. So of course we can write an AND operator here as well. As I said earlier, this is no you can write any arithmetic you want in the loops or ANDs and others. So we have another loop here, do while loop, which is kind of similar to do while loop, but it has more differentiations. The do while loop works in the same way as ordinary while loop, except that the presence of a do block guarantees that the code will execute at least once, even when the condition of the while expression doesn't evaluate to true. For example, var variable, let's declare a new variable. Let's name the variable x and assign it to 10. Do we doing our do while loop now. X plus plus, it is, are we increasing by 1, and printing to log, and do block. In the do block, and for example, and x equals to x here. Oops, I forgot the tag here. Oops, the log needs for 23 characters, but I entered 24 characters. And while x is less than 10. So let's run this code and see what this code will give us. This code will give us 11. 1 minute. Yes. So this code has given us 11 because condition is not true, because x is not x. Our condition in while loop is not true because 10 is not greater to 10. 10 is equals to true 10, because this normally without do this code will not run. But with do loop, this code is running because the tradition of the do while loop in Java. This is a least used but sometimes perfect solution for a problem. Even though the condition of the while loop is false, the do block executes its code, increments the x variable to 11, as I said earlier, and prints a message to look at. The condition of the while loop is x is greater than 10, so the code in the do block is not executed again because the expression is not true anymore. The expression is out of it wasn't true ever. It false, and it just run in ones and incremented by 1 to 10 to 11. If the expression in the while condition is true, however, then the loop code in the do block continues to execute as though it was a regular while loop. Now I want to tell about your ranges here. Let's delete our code. In order to continue our discussion on loops, it's necessary to briefly introduce the topic of ranges. Ranges are intimately connected to the Kotlin topic of arrays, which we will discuss later of our video course. What follows is a quick introduction to the ranges to enable us to get to then go on cover for loops. Take a look at these examples. For example, range of numbers and equals 1.4. What is happening is that we are using the type inference to create a list of values that contains this contains 1, 2, 3, and 4. We can also explicitly declare and initialize range a list as in the following code here, while range of numbers another equals list of here, and 1, 2, 3, 4, 5. 1, 2, 3, 4 here. But the preceding code uses the list of keyword to explicitly create a list containing the numbers 1 through 4 as we created earlier in this code. How this works under the hood will be explored in the later of our video course in more depth, of course. So then we will see that there is a much more to ranges, arrays, and lists than we have covered here. It's just helpful to have this. I wanted to learn this for quick introduction to complete our discussion of loops by looking at the for loop. Now we are ready to for for loop here, and for loops. To use a for loop, we need a range or list. We can then use a for loop to step through that list and execute some code in each step. For example, let's create a list as we did earlier. Value list here, and 1 to 10 range, and let's for e in the list, and log.e looping plus, so value looping here, value or not value, it's okay, looping current value is commit, let's then delete, we don't need that. Value is e, for example. So let's run our code now. You will see more detail in this example how this works. Okay, our program is run. As you can see here, we had 10 values here from 1 to 10, and we looped each other with this command e in list. So as you can see here, current value is 10, and after that we don't have 10 values because we declared from 1 to 10, and as much as we values we had is all printed to the log with the help of for loop. So in Kotlin, the for loop is extremely flexible and can handle much more than just simple integer values. We will not explore all the options in this lecture because we need to learn more about classes first for your better understanding. We will, however, be returning the for loop in number of places throughout the rest of our video course. So I am repeating this again. If you have any questions, please ask, and I will answer your question as fast as possible. Now we can go to our controlling loops here. Okay. Controlling loops is important in Kotlin loops. Having just discussed all the ways that we can control looping throughout code, it's important to know that sometimes we need to break out of a loop earlier than the condition of the loop specifies. For such occasions, Kotlin has the break keyword. As you can see, break. I want make a break with while, make a code that uses break and while loops in same way. So var count down here, and it's equal to 10, and let's create a while our countdown is greater than 0, then if countdown inside our while loop, of course, is equals to 5, then break. Okay, so let's log now. Log.e countdown and please let's countdown here. So and this tract countdown minus. Let's run our code now. Our code is running. So as you can see here, the while loop supposed to show us 10 times because our countdown has 10, but we had added a condition here. If countdown equals to 5, then break the code. As you can see here, we can't see 5 because the countdown was 5, and the breaking he breaked the code, our compiler, of course, and the while loop is no longer running here. So you can see from the presenting output that we countdown equals to 5, and the break statement executes, and execution exits the file a while loop for before it gets to print to logcat window, as you can see here. Sometimes you might want to execute only part of the code within a loop, but not stopping loop entirely. For this, Kotlin has the continue keyword, as I want to show you this. Let's okay. Kotlin has continue keyword as continue, as you can see here. So what does this continue keyword do? Let's create an example for you to better understanding. Okay, let's create a var, that var count up equals 0, and while count up is less than 10, count up plus plus, and if count up is greater than 5, then continue. And let's print log here as well. Every time our code loop runs, log will print to logcat. Log e count down, and the second is count ups. What? Okay. So we now we will create an inside and outside loop, of course, because we have two variables, which is the first is inside, and second the second is outside loop. So you will see why I'm doing this. Log.e outside here, and count up, and the inside loop, of course, for better understanding, and count up count up. Let's run the code here. Okay, delete this. as you can see here. In the preceding code, we initialize a variable called count up to 0 here. And we then set up a while loop to keep executing while count up is less than 10 here, as you can see. And inside the while loop, we increment by increase by 1 count up. The next line of code checks to see whether count up is greater than 5, sorry, not 1, is greater than 5, and if it is, the continuous statement is executed. The next line of the code prints the value of count up to logcat window. The line of code that prints the value will only execute when count up is 5 or lower, because the continuous statement sends the execution of the app back to the start of the loop. So take a look at the following output to verify this what's happening. As you can see, 1 2 3 4 5, oops, and 10. As you can see here, the presenting output that count up is printed while its value is 5 or lower. Once its value exceeds 5, the continuous statement prevents the line of code that does the printing from being executed. However, the final code of the code outside the loop prints the value of count up, and you can see that is the value of 10, indicating that the first line of code in the loop, which increments count up, executed continuously throughout the completion of the while loop condition. The break and continue keywords can also be used for loops and do while loops. In this lecture, we used if, else, and when to make decisions with expressions and branch our code. We saw and practiced it with while, for, and do while to repeat parts of our code. Furthermore, we used break for breaking out of a loop before the condition would otherwise allow. And we used continue to conditionally execute only part of the code in a loop. It doesn't matter if you don't remember everything straight away, as we will constantly be using all these techniques and keywords throughout the course. We will also explore a number of more advanced ways to use some of these techniques. In the next lecture, we will take a much closer look at Kotlin functions, which is where all our tests and loops code will go. Regardless of the programming language used, application development is largely an exercise in applying logic. And much of the art of programming involves writing code that makes decisions based on one or more criteria. Such decisions define which code gets executed, how many times it is executed, and conversely, which code gets passed by when the program is executed. This is often referred as flow control. Let me delete this. Flow control. So since flow control, it controls the flow of a program execution. Flow control typically falls into categories of looping control. The flow of a program execution. Flow control, looping control and conditional flow control, whether or not code is executed. This lecture is intended to provide an introductory overview of the both types of flow control and in Kotlin. Looping flow control. In this lecture, we will gonna begin by looking at a flow control in the form of loops. Loops are essentially sequences of Kotlin statements which are to be executed repeatedly until a specified condition is met. The first looping statement we will explore is for loop. For, as you can see here. The for in loop is used to iterate over a sequence of items contained in a collection or number range. The syntax of the for in loop is as follows. For example, let's create var variable and the name in or variable var variable string here, and let's this works like that. For variable name in collection or range here. In this syntax, variable names is the name to be used for a variable that will contain the current item from the collection or range through which the loop is iterating. The code in the body of the loop will typically use this name as a reference to the current item in the loop cycle. The collection or range references the item through which the loop is iterating. For example, this could, for example, be an array of a string values, a range operator, or even a string of characters. For example, let's make an little example here, which we will discuss more detailed in this lecture. For example, for index in 1 to 5 here, and print or log is better, log value of index is index here. Let's run our code. So let's open the logcat window here, and as you can see here, our string array integer array is iterated here. So the loop begins by starting that the current item is to be assigned to constant name index. The statement then declares a closed range operator to indicate that the for loop is to iterate through the range of numbers starting at 1 and declaring and ending to 5, starting with 1 and ending with 5, and here at 2, 3, 5, 6, 7, and like so. The body of the loop simply prints out a message here, message to the logcat indicating the current value assigned to the index constant and resulting in the following output. The for in loops is of particular benefit when working with collections such as arrays, which this is the kind of array as well. And in fact, the for in loop can be used to iterate through any object that contains more than one item. For example, let's create a loop here with string. For example, hello academy, and then index in hello here, and what's the problem? Index here, index in hello academy. Oh, okay, we did it accidentally. So let's run it again. So as you can see here, we iterated hello academy 1 alphabet 1 by. So the operation of for in loop may be configured using the down to and until functions. The down to functions causes the for loop to work backwards through the specified collection until the specified number is reached. For example, let's create an example here. As you can see, we did an example and we printed our string here, one alphabet one mine, L, O, and here's a space bar here, and A, K, A, D, M, E. Okay, so let's create another, for example, here. So for example, let's create an for loop as well here. For index in 100 and down to 90, down to 90 here, and let's log.e log and print index here, index to string. So let's run this code again. And here let's open the logcat. As you can see here, we looped our with for extension from 100 to 90. So when they executed in your computer, this will show in your logcat this following output. The until function operates in much the same way, with the exception that counting starts from the bottom of the collection range and works up until, but not including, the specified endpoint, a concept referred to as half closed range. Let's try this as well. Okay, let's delete this and let's try another loop again. For example, for index in 1 until 10, and print here log as well. Let's delete this, we don't need anymore. So log.e log and index that put string, because log wants a string here, and let's run it again. So let's open our logcat now. As you can see here, we've from 1 to 10, but not including 10, printed to a logcat here. So we have the increment used on each iteration throughout the loop may also be defined using this, for example, step function here, until 10 and step 3. Step 3. Let's run this again. Let's open the logcat. as you can see here, we loop through 1 to 197 with every increasing 3 3 3 3, as you can see, 10 13 16 19 22 25 and so. So as you can see, we're done with our for loops for now, and in next lecture we're gonna discuss and you will learn while loops as well. So as we discussed in previous lecture, the Kotlin's for loop described previously works well when it is known in advance how many times a particular task needs to be repeated in a program. There will, however, be instances where a code needs to be repeated until a certain condition is met, with no way of knowing in advance how many repetitions are going to be needed to meet that criteria. The address is neat. Kotlin includes a while loop. Essentially, the while loop repeats a set of tasks while a specified condition is met. The while loop syntax is like this. For example, while condition, and here our code. In this syntax, condition is an expression that will return either true or false. And here, Kotlin statements, for example, code, here comments represents the code to be executed while this expression is true. For example, let's create a variable var my count here assigned to 0, and let's create a while loop while my count is less than 100 and my count plus plus increment our my count, and let's print this to our log here. Log count my count here and count. Let's run this code. Yeah, our code is run. Let's look at. As you can see here, we printed 100 times our count here, as you can see here. So in this example, the while expression will evaluate 1 minute, let me delete this. Will evaluate whether the my count variable is less than 100. If it is already greater than 100, the code in these braces is skipped and the loop exits without performing any tasks. If on the other hand, my count is not greater than 100, the braces is executed, and the loop returns the while statement and repeats the evaluation of my count. This process repeats until the value of my count is greater than 100, and at which after this point the loop exists. We have another loop as well, the do while loop. It is often helpful to think of the do while loop as an inverted while loop. The while loop evaluates an expression before executing the code contained in the body of the loop. If the expression evaluates to false on the first check, the code is not executed anymore. So for example, let me check this. Let's make my count 200, and let's check if this code will run here. As you can see here, we don't see anything because the while loop will not run if the expression is not true. So for this job we have do while option. Do while loop is provided for situation where you know that the code contained in the body of the loop will always need to be executed at least once. For example, you may want to keep stepping through the items in an array until a specific item is found. You know that you have to at least check the first item in the array to have any hope of finding the entry you need. The syntax for do while loop is like that. Let me show you. Here, the first do and code here, and after that we're gonna use while code here, while expression here. So it will, for example, first do the do, and after if the condition is still true, this code will loop. But if not, the do while loop will execute inside this braces code at least at once. So we made these examples previous lecture, so I won't discuss that because it's so easy. If you know a while loop, then you know do while loop as well. So let's go to breaking from loops. We haven't created a loop. It's possible that under certain conditions you might want to break out of the loop before the completion criteria have been met, particularly if you have created an infinite loop. One such example might involve continually checking for activity on a network socket. Once activity has been detected, it will almost likely be necessary to break out of the monitoring loop and perform some other task. For the purpose is breaking the loop out of the loop, a Kotlin provides the break statement, which we have discussed in previous lectures of our code, which in this lecture we will not discuss that. In this lecture we have discussed break and while and do while loops more detail, which we discussed previous lectures. I want just to be clear that you will learn more details about for loops, because loops is most important thing in programming. We have learned continue and break loops as well. So thank you for watching. In next lecture we're gonna you will learn conditional flow control with more depth examples. The if expression is perhaps the most basics of control flow options available to the Kotlin programmer. Programmers who are familiar with C, Swift, C++, or Java will immediately be comfortable using Kotlin if statements, although there are more subtle differences. The basic syntax of the Kotlin if statements if is like that. For example, here if boolean and then expression and then our code here. Unlike some other programming languages, it is important to note that the braces are optional in Kotlin if only one line of code is associated with the if expression. In fact, in this scenario, the statement is often placed on the same line as the expression. Essentially, if the Boolean expression evaluates to true, then the code in the body of the statement is executed. If, on the other hand, the expression evaluates to false, the code in the body of the statement is skipped and not executed. For example, let's create an example here. While x assigned to 10 here, and if x is greater than 9, then print log.e condition condition x is greater than 9. Let's run it. Oops, we don't implemented our log, so we implement it immediately. Okay, or I want to show you an text box here, which we will discuss more about that. Text view, here text view, and assign it to val here, and text view, enter, find view by id, r.id dot text view, and if this condition is true, then text view dot set text x is greater than no 10 is greater than 9. And let's run our code here. As you can see here, we printed to the screen x is greater than 9. At this point, it is important to notice that we have been referring to the if expression instead of the if statement. Reason for this is that unlike the if statement in other programming languages, the Kotlin if returns a result. This allows if constructs to be used within expressions. As an example, a typical if expression to identify the largest of two numbers and assign the result of variable, for example, it's greet, and if x, for example, integer x, or I think so, x var x equals 10 and var equals 20, and let's create an if expression. If x greater than y, then largest equals x, and else largest, 1 minute, largest var largest for example, largest equals x, else largest equals y. So the same result can be achieved using the the same result here can be achieved using the if statement within an expression like this. For example, let's create a variable which will return true or false. Var variable here, and is assign if condition here, and this returns a val here. Let's make this example. If x greater than y, then this will return something here, as you can see here, and else nothing here. This can be written like that as well. Return 1, else return 0, like this. So we can use if else in our expression as well. Then the next variation of the if expression allows us to specify some code to perform if the expression in the if expression evaluates to false. For example, if boolean true or something, and then here else, we're putting our codes here, and we have else as well, and if this condition is not true, then our else code will be executed. So we have you learned in this expression in previous lectures, but I will show you. I want to show you again. For example, if let's create an two variable. The first is integer Mike, or where Mike equals assigned to 19 years old, for example, or and var for example John here is 17 years old, and let's run if Mike is older than John, then text view dot set text Mike is older than John, else then text view dot text set text set text John is older than Mike. So let's run our code here. So our code is run. So as you can see, Mike is older than John because our first if expression is executed here. So I want to teach you that when statement as well. The Kotlin when statement provides a cleaner alternative to the if or else if statements here. Construct and uses, for example, like this syntax, when value and then our match here. This is like the switch case function in Java. If you know Java, this will be familiar to you. For example, match one and statement, or match two statement 2, and like that. So let's create an when statement example with that. So let's write when our oops, we don't have to delete it. 1 minute. Let me. Okay. We will use Mike and John in our example as well, and when for example Mike if Mike is 17 or 18, 19 or 20 years old, we will print it. So when our Mike is 17, then or 16, Mike is 16, then print or let's just text view dot set text Mike is Mike or 16 years old. Let's copy this as well. 1 2 3 4. So 16, the second is 17, and create that 18 and 19, and else Michael is Mike is less than 16 or bigger than 19. because we don't added conditions to 16 to night, and this is not a clever idea, but I want just to show you how this when condition works. As you can see, Mike is 19 years old, and our last expression, Mike is 19 years old, is run here. Functions are the building blocks of our applications. We write functions that do to specific tasks and then call them when we need to execute that specific task. As the tasks we need to perform in our applications will be quite varied, our functions need to be catered and to be very flexible, of course. Kotlin functions are very flexible, more so than the other Android-related languages. We therefore need to spend a whole lectures learning about them. Functions are intimately related to object-oriented programming, and once we understand the basics of functions, we will be in a good position to take on wider learning of object-oriented programming. We already been seen and used functions. Some were provided for us by the Android API, such as onCreate and other the lifecycle functions, as you can see here. We wrote other ourselves, for example, top click and bottom click, however, we haven't explained them properly. And there is more to functions that we have seen so far. The basic function declaration is like this. First, writing the fun, then declaring function name like print to log here, and then we can then we need to write code that uses function. Without just declaring the function, it's useless. We can call this function from our method here, print to log, but this is useless and will not change anything on program and will not help to your jobs here. But I will write some code to print something on logcat. For example, log.e function runned, and we will write hello world. As you can see, let me open display capture here. Oops, this. As you can see here, our program is run here, and let me close this, and as you can see here, our logcat is run and our function is run as well, function run hello world. The first line of the function is the declaration, and all the code contained within an opening and closing curly brackets is the function body. We use the fun keyword followed by the name of the function like this, and this is the function body, of course, followed by opening and closing brackets here, open this close bracket and open bracket, and the name is arbitrary, but it is good to practice to use names that describe what function does. We can assign function parameters as well. The declaration can take many forms, and this gives us lots of flexibility and power. Let's create a function that uses parameter, or we just upgrade this function as well. So, for example, I want my function to get one parameter, which is string here, and message. As you can see here, message string, I'm sorry. Message string here. As you can see here, print to log function is now throwing an error because it needs some variable to input here. So for example, Android is best here, and the error is gone, and we can now write our code. And then, for example, print to log Android is best, and I will print whatever he said. For example, message here, and we are writing something to this. This gives this is a string as well. This string going to this message string here, and this message string going to this log.e and printing lastly. So the main function, so whatever we write to this log.e will print to logcat. Let's run it again. Our application is run. As you can see here, what we wrote here is running on a logcat as well. This part of declaration is called the parameter list. So this is the parameter list, but we can use so many parameters as well, like message string, second message here, message, and we can use the string here, string as well. And let's make Android is best, for example, TechBeans Academy, and let's run it again. It will now print different things. This will not print different things because we don't use this second method here. Let's use then. Let's run the application. So, and second message. Our log.e will print first message and then second message. So let's add some input integer as well, but we will not use yet. But I just want to this to demonstrate you how this happens. And my integer, and let's create an integer here, and it needs integer, but we will not use that. And let's run. As you can see here, Android is best, and TechBeans Academy printed to this what we brought to our function. So it is a list of types that functions, parameters is the list of types that functions expects and needs in order to execute successfully. The parameter list can take many forms, and Kotlin type can be part of the parameter list, including having no parameters at all, as we saw in our first example. As you can see here, we have 3 parameters in this our upgraded method. When we call a function with a parameter list, we must supply arguments that match whenever we call it. For example, as you can see, we declare the my integer. So in third parameter of our print to log function needs integer. So if we put there something float, as you can see, it will throw error to us. So I want to demonstrate another couple of functions parameters. For example, like this, we can add any messages we want, or we can use iteration in this while my integer is greater than 5, and then do something, as you can see here. Functions can return something. Very often we will need to get a result from a function, and it is not always enough just to have the function know the result. Functions can be declared to have a return type. And look at the next function declaration like we will do here. For example, function get a sum here, and we will use two integer that we will return a sum of these two integer, and b integer, and here return a plus b, here. As you can see here, oops, chain required unit here, integer, and okay, this is because as you can see here, I will demonstrate you here, these functions returns something here, as you can see, but without declaring special attribute to it. Every function in Kotlin is void. In Java, as if you know Java programming, you will know that in order to return something, don't return something, you have to declare void, but in every function Kotlin is a void. So in order to return something in function, you have to, after declaring these braces here, you have to write whatever object you want to return. I will return object for summing this two variables here, and after summing these two variables, this will return to return function. Look at the this part here, parameter list. The code means that function can and must return a value of the integer type to the code that called it. The line of the code inside the function body uses the return keyword to achieve this. The return a plus b code returns the sum of a and b. We can get, for example, get a sum here for 4 and 3 and 7. This line of code will work, but is a little pointless because we don't do anything with the returned value. This code, so for example, while answer here, for example, get sum and 5, 6 or 10, 6, 10, for example. And in the this function, the value returned from the function is used to initialize the answer variable. As the return type is integer, the Kotlin infers that the answer is also integer. So this, as you know, this returns an integer, and answer is an integer as well, but we can declare specially for it integer as well, like this. But it will integer whatever. We could use get sum in other ways, like for example, we can use log.e here and get a sum method run here, and for example, let's string here dollar. For example, with this we can in string we can get call a method here, get a sum and 10, for example 6, or 10 and 33. So let's run the code. Before running the code, get some function is another way by printing the returned value using a string template to print the logcat logcat window. So run this code. I want to show you how this code works. So let's open logcat. As you can see here, 43. So using this special string arguments, message arguments, we call the method named get a sum, and we get a sum 10 we write somewhere 10 and 33, and we used this method and returned a sum of a plus b. So any type can be returned from a function. For example, the float returned in function, the float can be returned as well. For example, if you want to just find the p, for example, what was the p? P was 3.14 here, and radius float as well, float, and because the float, let's delete that, we don't need anymore here, and radius float as well, we have to return a float. Well, we don't have to, but in this code we will. Okay, so this will return 3.14f multiply by radius, and this will give us a diameter here, radius, and for example log dot e. For example, our radius was 5.5. Radius code and plus no okay, for example get a sum 5.5. Why? Type float double 5.4, because we have to f after floating variable. If you want to use double, you can use without f like this. So look what is running now. As you can see here, our radius code function found 94.985. So it's also worth noting that return keyword has its uses even when the function doesn't have a return type. For example, we can use the return keyword to return from a function early. All our previous function examples without return types automatically return to the calling code when the last line of code in the body of function had executed. For example, like I want to show you some examples to you here. So for example, let's just create a function that print up to 3, that a number and integer here. So this will no return type, of course. I will use no return type because demonstrating you how this works. If a number greater than 3, then log dot e and we will print a number is too big, and a number is too big, and this will return for going back to the calling code, and otherwise log dot a number is number here. Now we can let's create call the different values here. For example, print up to 3, print up to 3, 65, 67, print up to 3, 14, and print up to 3, 1 here. Let's run this code. I will explain you more clearly after running this code. Okay. As you can see here, first is the number is executed because it's not a number is not greater than 3 is a 3. So if number will not execute and this will this code of our in function, this will execute, and this 2 will return because number is too big and will not go to this line of our code, and one will execute as well. As you can see, the last is 1 because if a number is not greater than 0. So in the function, but the if expression, for more explaining you for more clearly, the if expression checks whether a number is bigger than 3, and if it is, prints a distrangled command and uses return keyword to go back to the calling code and avoid printing the value to the localcat. From the program output, we can see that, as you can see here, we can see that when a number was 1, it was delightfully now number 1 or 3, as you can see here, we have used one number. It was dutifully printed by the print up to 3 function, but as soon as we passed into the value of like 67 or 12, we got the alternative result. In this video lecture, you will learn object-oriented programming. Object-oriented programming is a way of programming that involves breaking our requirements down into chunks that are more manageable than the whole. Each chunk is self-contained and potentially reusable by other programs while working together as whole with the other chunks. These chunks are what we have been referring to as objects. When we plan, code an object, we do so with a class. A class can be thought of as the blueprint of an object. We implement an object of class. This is called an instance of a class. Think about a house blueprint. You can't live in it, but you can build a house from it. So you build an instance of it. Often we have, when we design classes of our applications, we write them to represent real-world things. However, object-oriented programming is more than this. It's also a way of doing things, a methodology that defines best practices. There are core principles of object-oriented programming are encapsulation. Let me show you here. I have written it here. So there are core principles of object programming. Object-oriented programming is, as you see here, the first is encapsulation, second is polymorphism, and third is inheritance. These might sound complex, but taken a step at a time are reasonable straightforward. Let's start with encapsulation here. Encapsulation means keeping the internal working of your code safe from inheritance from the code that uses it by allowing only the variables and functions you choose to be accessed. This means that your code can always be updated, extended, or improved without affecting the programs that use it, provided that exposed parts are still accessed in the same way. You may recall this line of code, for example, as we done earlier on our lecture. Location manager, location manager, and here get last known location, and we passed an argument location manager that what it was, GPS provider, of course. GPS provider. This is the gave us error because we don't create a location manager. Let's create a location manager, location manager, or just okay. So with proper encapsulation, as you can see here, it doesn't matter if the satellite company or the Android API team need to update the way their code works. If the get last known location function signature remains the same, we don't have to worry about what goes on inside. Our code, as written before the update, will still work after the update. If the manufacturer of a car gets rid of the wheels and makes it an electrically powered hover car, if it still has a steering wheel, accelerator, and brake pedal, driving it should not be a challenge. When we use the classes of the Android API, we are doing it so in the same way Android developers designed their classes to allow us to. We will get deeper into encapsulation later of our video course. I want to just briefly introduce you the encapsulation term in Kotlin. Let's go to polymorphism now. Let me check, is it recording? Yes. Polymorphism now. Polymorphism allows us to write code that is less dependent on the types we are trying to manipulate, making our code clearer and more efficient. Polymorphism means many forms. If the object that we code can be more than one type of thing, then we can take advantage of this. Some future examples will make this clear, of course. An analogy will give you a more real-world perspective. If we have a car factories that can make vans and small trucks just by changing the instructions given to the robots and the parts that go onto the production line, then the factory is polymorphic. Wouldn't it be useful if we could write code that can handle different types of data without starting again? We will see some examples of later of our video course. Now lastly, the inheritance here. Inheritance. Just like it sounds, inheritance means we can harness all the features and benefits of other people's classes, including encapsulation and polymorphism, while further refining their code specifically to our situation. Actually, we have done this already. Every time we used that operator as follows, like this. We inherit app compact activity method in main activity. You will see later a more brief introduction here. The app compact activity here class itself inherits from activity. So we inherited from activity every time we created a new Android project. We can go further than this and we will see how it is useful. Imagine if the strongest man in the world gets together with the smartest woman in the world. There's a good chance that their children will have serious benefits from gene inheritance. Inheritance in Kotlin lets us do the same thing with another person's code and our own. We will try look at inheritance in action in a later lecture. Why do it like this? When we use carefully, all the object-oriented programming allows you to add new features without worrying as much about how they interact with existing features. When you do have to change a class, its self-contained, encapsulated nature means less, or perhaps even zero consequences for other parts of the program. This is the encapsulation part. You can use other people's code, such as Android APIs, without knowing or perhaps even caring how it works. Think about the Android lifecycle like Toast, Log, all the user interface widgets, listening, satellites, and so on. We don't know. We don't need to know how they work internally. As more detailed example, the button class has nearly 50 functions. Uh, button here, as you can see here. Let's import this. I want to show you how many we have. Button, as you can see here, we have more than 50 methods and functions here. These functions has every is the own function for applying it, which we will discuss later, and you will see brief examples of how these functions work in button, text view, or text box. You will see every about that. Do we really want to write all these functions ourselves just for a button? It will be much better to use someone else's button class, this is the Android API that developers write them for us, that we don't write for just waste our time for creating just setText method, especially our autofill method like this. You can create multiple similar yet different versions of a class without starting the class from the scratch by using inheritance, and you can still use the function intended for the original type of object with your new object because of polymorphism. It makes sense really, and the Kotlin was designed from the start with all of this in mind. So we are forced into using all this object-oriented programming. However, this is a good thing. Let's have a quick recap here. A class is an container for a bunch of code that contains function. I want to read class as well. That class. A class is a container for a bunch of code that can contain functions, variables, loops, and all other Kotlin syntax we have learned already. A class is a part of Kotlin package, and most packages will normally have multiple classes. Most often, although not always, each new class will be defined in its own .kt code file with the name as the its class. .kt code file. As with all of our activity-based classes so far. Once we have written a class, we can use it to make as many objects from it as we want. Remember, the class is the blueprint and we make objects based on the blueprint. The house isn't the plan, just as the object isn't the class. It's an object made from the class. An object is reference variable just like a string, and later we will discover exactly what being a reference variable means. For now, let's look at some actual code. Basic classes I want to discuss here. There are two main steps involved with classes. First, we must declare our class, and then we can bring it to life by instantiating it into an actual usable object. Remember, the class is just a blueprint and you must use the blueprint to build an object before you can do anything with it. So declaring a class, I want to discuss about you and teach you. Classes can be of varying size and complexities depending upon what its purpose is. Here the samples, absolute simplest example of a class declaration like this. For example, class car or a soldier, our class a class message here. Class message. Oops, okay. Class message or class practical system. As you can see here, the first thing to note in the previous code that I have lumped together three class declarations. In real code, each declaration will be contained in its file with the same name as the class and the .kt file name extension. To declare a class, we use the class keyword followed by the name of the class. As you can see, we created three classes here. Therefore, we can work out that in the previous code, we declared a class called soldier here, a class named message, and the class named practical system. We already know that classes can and often do model real-world things. It will therefore be safe to assume that the three hypothetical class will model a soldier, perhaps for a game, a message, perhaps for an email or text messaging app, and a practical system, perhaps for scientific simulation app. It's plain, however, that a simple declaration like the three we have just seen doesn't contain enough code to achieve any usable functionality. We will expand on class declaration in a moment. First, let's see how to go about using the classes that we have declared. Instantiating a class. To build usable objects from our classes, we will turn to another code file. So far to show the video course, we have used onCreate function in the app compact activity to demonstrate different concepts here. App could be using a class app compact activities onCreate method here. Let me check, is it recording? Yes. So while you can instantiate a class from virtually anywhere in Android because of the lifecycle function, it's quite common to use onCreate to instantiate objects instances of our classes. So let's have a look this code here that I will write. So as you remembered, we created three classes here. First is solder, message, and practical system. Here. And let's create our usual code here, and let's create an example of code that have to create class instance. So now we will class while solder. We will solder that will contain solder class here, and this assign it to solder constructor here. You will see more examples about constructors as well. Val message, let's create a message class as well. Message here, and this equals to message, and let's create a practical system. Val practical system here, right? System equals practical system. So in this code, we instantiated an instant made usable object from each of our three previously declared classes. As you can see here, we instantiated here, and our classes is here. Let's examine that the syntax more closely. Here's the line of code that instantiate an instance of the solder class here. First, we decide whether we need to change our instance with regular variables when to choose a val or var here. Next, we name our instance, we named our instance, but we could have called solder X, for example, marine or tech pins, of course. the name is arbitrary, but as with variables, it makes sense to call them something meaningful. Soldier1, for example. Also, as with variables, it is convention but not required to use lowercase letter at the start of the name and uppercase letter for any subsequent words in the same. The final part of the code contains the assigned operator equals followed by the class name soldier and an opening and closing braces. The assigned operator tells the Kotlin compiler to assign the result of the right hand side of the code to the variable on the left. Type inference establishes that solder is the solder1 is the solder type. The curious, but perhaps for looking braces after the class name implies that we are calling function VR and its special function called constructor that is provided by the Kotlin compiler. There is much to discuss about the constructors, so we will defer the conversation to a little later in our course. For now, all we need to know is that this next line of code here criticizes a usable object of a soldier type called soldier1. Let's delete soldier for more nice explanation. Remember that one of the goals of object-oriented programming is that we get to reuse our code. We are not limited to just one object of the soldier's type. We can have as many as we choose. Let's create more soldier objects here. For example, soldier John, soldier. For example, soldier here, or var John here soldier equals soldier, or banana soldier equals soldier here. As you can see here, as we can have as many as we choose. So the soldier, soldier John and banana instances are all separate, distinct instances. It is true that they are all the same type, but that is their only connection. You and your neighborhood might both be human, but you are not the same human. If we do something to or change something about solder or solder John or solder banana, the instances remain unaffected. It is indeed possible to instantiate a whole army of solder objects. The power of object-oriented programming is slowly revealing itself, but the elephant is the room at this stage of our discussion. This is our classes don't actually do anything at all because they are useless. We don't declare any functions or variables here. Our classes, this is just the classes that don't do anything for us and for our program. Classes have functions and variables. I will explain the slightly cryptic kind of heading shortly when we go to class and variables properties section later of our course. Any of the code that we learned about throughout our discussion on Kotlin can be used as part of a class. This is how we make our classes meaningful and our instances genuinely useful. Let's expand on the class declaration and add some variables and functions, our solder class. First, we will add some variables to our empty solder class, like the next code here. For example, let's delete our useless class instances here. So let's create add a declaration to our solder class. That first is val name here. What's the name? What will the name of our class? For example, name it John, for example. Name John, and a soldier has a rank as well, while rank is, let's do it private, and the is missing, while missing equals true. Remember, all this code will go in file named solder when we compile this application. So we're doing in the same file as well, but when we compile it, these classes will go to different files in compile zip. Know that we have a class declaration with some member variables. We can use them as this code. For example, let's create a val soldier1 here. Now we don't need instance because Kotlin will automatically assign that we that we will want to use soldier class here, and let's print our soldier name, or let's create let's print our soldier name to this class here. Okay, let's create two text as well. So, oops, no, not button now. So the text view one is missing. Okay, the soldier rank, and first okay, the first is, I will explain how to use with UI components, but for now let's be patient, you will learn all about that. Soldier name here. Now we assigned an ID to our views. Let's assign ID is missing, and let's delete our text views here. Okay, 1, 2, and 3. Now let's create a 3 text object while text oops, no, is missing. First is missing text view, and while soldier name oops, soldier name text view, while soldier rank here, and this text view as well. So let's find use find by id or that id, and assign is missing, and equals find view by id r that id soldier name, and finally find view by id r that id that soldier rank. So let's print our soldier names to these text views here. As you can see here, we assigned 3 variables in our soldier class. Now we want to print these 3 variables to our text views. So for example, while string or soldier name, oops, no, we already created soldier name text name here, and we will string our text name soldier name, or while text rank equals soldier rank, and while is missing boolean, or let's use no, string is okay for demonstrating you how we can use string and boolean or different integer types. Or let's add one variable as length that shoulders how your shoulders is, or date of birth. Date of birth equals 1988. And let's now we have to create a new class here as well. Here, and solder your date of birth refactor, of course. Why is missing is already created. Text bool missing here, and boolean equals is soldier or no, actually we have to do that. Soldier text name is soldier name, soldier one dot get oops get text, soldier one dot name. As you can see here, we use these variables inside our class, and soldier soldier one dot rank and soldier one dot is missing. Oops, missing layer. Now and so we have one variable as well, which is soldier's date of birth. Job of soldier, date of birth soldier. Do this integer here. Integer and let's assign oops soldier one dot date of birth. Let's create a val soldier dot equals text view. Find view by ir.id dot soldier date of birth. So we already created our code. So let's assign these variables to our text views now. It has a little way to assign this. For example, this is the, if you want to develop an application, this is the useless. You can assign your variables soldier.one variables to text views as well, but I want to demonstrate you how we can get that soldier name here for not being complicated. Let's create let's now assign our variables to text view. So is missing, if soldier is missing, bool missing, true. If it is true, we don't have to do like this. If true. You can do that like this, but it's the you don't have to. It's like useless. You can write this like that, or like that. Of course, I have demonstrated your previous lectures how to write if conditions and loop condition as well. If you want to learn about, let's get recap your information. So bool missing, if our solder is missing, then add to our solder missing is missing dot set text soldier missing. So, and then we can assign our, what's the problem? No, I don't want that. So soldier missing. Then we can add ranks our solder rank, solder name, and date of birth of our solder here. So text soldier name dot set text text name, or soldier rank dot set text soldier rank soldier dot date of birth dot of soldier, rank soldier, date of birth, dot set text, our integers. As you know, our date of birth of soldier is integer, so we can't assign. And what's the problem? Just define an Android widget a text soldier. This is text view. Solder run, text run. No, okay. We assigned this itself, so we have to. So solder date of birth, we date of birth solder dot to string, because we assign only string literals to set text here. And we done our code. Let's run our code, and let me show you your emulator. Yes, and full stacks here. As you can see here, we printed our solder class objects to our text views. As you can see here, our soldier name was John. Let me okay. So the soldier name was John. Soldier rank was private. Soldier is missing. Yes, it's missed, and date of birth was 1988 year. As you can see here, our information is printed to our application. So let's continue about this object-oriented programming exercise, because you need a lot of them for better understanding. So using the functions and variables of a class. Know that we can give our classes data. It's time to make them even more useful by giving them things that they can do. To achieve this, we can give our classes functions that have a look at this expanded code. For example, like let's delete our text views here. We will not use them anymore in this lecture. We will use log for better explaining. So as you can see, we have several information here, and for example, let's create a function that named get status here, and this will return our status name var status equals rank name rank, and if missing then status soldier is missing, status soldier is missing, and else status equals ready status ready for data. Now let's print this to our log here. Okay, log dot e status, and this will give us a status as well, status. and we can now call our function here like soldier1.get status. As you can see, we declared function inside of our class. Okay, we don't need the emulator anymore. So let's open the logcat here. Can you see logcat here? Yes. Okay. So let's open the logcat. As you can see here, our status of our shoulder is private, and you can see here our shoulder is missed. So as you can see here, our if block work and shoulder is missing. So the code is the in the get status function. Oops, the code in the get status function declares a new string called status, as you can see here, and initialize it using the value contained in rank. It then checks the value in is missing what if expression and appends either is missing or ready for data, depending upon whether missing is true or false. Let's make an missing false, and let me show what this can do. As before, we create an instance of the shoulder class and then use dot syntax on that instance to call get status function. Oops. Status function, as you can see here, we called our function. This code will produce the following output, as you see here. Ready for data, because our soldier is not missing, and our missing variable, boolean variable, is false, and this block is not working, and else block will work automatically, as you learned in conditional expressions in our previous lectures. So if you're thinking that all this class stuff is great, but at some time seems a little bit rigid and inflexible, you will be correct. What is the point of having multiple hundreds or thousands of shoulder instances if they are called Ryan and they are all missing? Certainly, we have seen we can use var variables and then change them, but this could be awkward and long-winded. We need ways to better manipulate and initialize data in each instance. And if we think back to the start of our lecture, when we briefly discussed the topic of encapsulation, then we will also realize that we need to not only allow code to manipulate our data, but also control when and how these manipulations take place. To gain this knowledge, we need to learn more about variables in classes, then a little more detail about encapsulation and visibility, and finally reveal what is going on with these function-like brackets that are we have seen at the end of the code with class variables and properties. It turns out that in Kotlin, class variables are more than just plain old variables that we have already learned about. They are properties. Everything you have learned about how to use variables so far still holds true. But the property has more to it than just a value. It has getters and setters. So let me delete this code for just a second. Okay. So it has getters and setters. Oops. And setters. So getters and setters can be thought of as a special function that are automatically generated by the compiler. In fact, we have already used them without knowing it. When we use the .syntax on a property variable declared in a class, the getter to get the value, and when we use .syntax to set the value, the Kotlin uses the setter. The field variable itself isn't accessed directly when we use .syntax we have just seen. The reason for this abstraction is to aid encapsulation. If we have previously done some programming in another object-oriented language, perhaps Java or C++, this could be confusing. But if you have used a more modern object-oriented programming like C#, then this won't be entirely new to you. If Kotlin is your first language, then you're probably at an advantage compared to someone with previous experience, as you don't carry the baggage of previous learning. And as you might guess, if the variable is var, then a getter and setter is provided, but if it is a val, then just a getter is provided. As you learned in previous lectures, the var can be reassigned, but val, let's repeat this again, var can be reassigned, but val can be assigned once in running application. So therefore, when the variables, which we will call properties most of the time from now, in the soldier class we were var, we called get and set them, but when they were val, we called only get them. Kotlin gives us the flexibility to override these getters and setters in order to change what happens when we get and set the value of properties and their associated fields. At this point, some examples using fields will make things clearer. So let's create an example that uses properties. We can use getters and setters to control the range of values that can be assigned to its backing field. For example, consider this code. For example, let's don't undo this deletion. As you can see here, we have some variables here, but all of these assigned with var. We can change to var, but I want to create a new variable here. Var bullets of our soldier, for example 100, and for example we can get and set bullets amount. So for example get and we can set them return field here, and we can set that log.e getter is used, and after that let's add our value to getter here. Let's add our value to getter here. Bullets getter is used, and value is bullets field, or field is more good. So, and after that returns value, and we have to set value as well, set here, and set value. So as you seen earlier, this is the method as well, but is the special for balance method here, and we are assigning balance to getter and setter values here. For example, field equals if our value greater than value is less than 0, then it will be 0 else value here. For example, and let's log this, that getter setter is used, and let's new value. I will explain this code now. 1 minute. Let me write, and I will explain this code line by line. This code adds a new var property called bullets, as you can see here, and initializes it to 100. Then we see some new code, the getter and setter are overridden. Strip out the code from the together and setter to see this in action in simplest code, as you can see here. This get function executes when we try to retrieve the value, and the set function executes when we try to set the value. To be clear, the code in the getter and setter executes when we are accessing the value of bullet through an instance of the solder class here. Let's delete these unnecessary applications here. We can delete getter and these unnecessary classes as well. Let's just be with our bullets. So take a look at how this will happen in our onCreate method. Let's create a new solder instance, soldier, for example, or John, for example. This John carries the solder and equals, so assign it to solder, not equals. So now we can use our getter and setter method here. For example, John dot bullets, or let's log it. Log dot e bullets equals solder dot bullets. Okay, so John dot bullets here. So let's create an for example, let's add some comments for better understanding. Getter will execute. So let's now write a setter, execute setter method. For example, reduce our bullets amount by 1. John dot bullets amount. So for example, John fired a 1 bullet, and then let's log to it, see what happens. Then bullets is equal to, now enter the message, then John dot bullets, and here the setter will execute here. Setter will execute. Now in this code we first create an instance of solder class here, and then we get the value stored in the bullet property. As you can see, this is 100. We get it with this, and print value. So let's print, and I will explain later after compiling application. Let's pause, and when our program will be ready, I will start. Oops, it's not necessary to pause because it's loaded already. Just a few seconds. Okay, our application is run. As you can see here, the first value getter is used because of this code here, and the second bullets is 100, and then getter is used again, and getter is used new value 99, and getter is used again value because we have written 2 times. The first is main method we're printing, and the second is in our getter, and second we are logging these actions, and lastly bullets equals the 99 because we decremented our bullets amount. The triggers, this triggers getter to execute. Next, we decrement reduce by 1 the value stored by the bullet property. As you can see here, I will explain this again. Any action that attempts to change the value held by property will trigger the code in setter, as you can see here. If we execute this after the executing with this code, the soldier instance called John here. We use log.e to print the value to the logcat window, as you can see here. And as this code accesses the value stored by the property, the getter code runs and prints this getter code runs and prints this value. As you can see here, the getter is used, and getter is used firstly, and this code runs. The getter then returns the value of the log.e function using this line of code, and this returns to log.e function here. When we created the property, Kotlin created a backing field. The way that we access the backing field in the getter or setter is to use the name field, as you can see here. Therefore, the presenting line of code, as you can see here, works the same way it would in a function and returns value, allowing that log.e to call in the calling code to print the value, and we will get this output in our logcat window. This line of code then perhaps in the most interesting here again, for example, here's a reference. We might guess that this simple triggers the setter to execute, but if we examine the next 2 lines of output in the logcat, we can see these 2 lines output have been generated here, as you can see here. The action of decrementing or incrementing requires the use of the getter to know what to decrement. As you can see here, if you use the setter method, you will use getter method as well automatically, and then the setter to change the value. Notice that the setter has a parameter named value that we can refer to in the setter's body, just like a regular function parameter. Next, the instance is used to output the value held by the bullets property here. And we can see that again the getter is used, as you can see here. And the output is generated from both the getter code in the class followed by the code using the instance outside the class. The final 2 lines of output are shown here. Now we can look at another example of using getters and setters. As I already mentioned, sometimes properties do not need to backing field at all. It's sometimes enough to allow the logic in the getters and setters to handle the value accessed via property. Examine this code, for example, add some pack weight and okay, var pack weight and 150 and gun weight, gun weight equals 30 and var total weight is equals pack weight plus gun weight here. So then we can assign get method here, getters, and getters equals pack weight plus gun weight. This code we create three properties: a var property called pack weight, which we will change using the instance we will soon create, a val property called gun weight here, which we will never need to change, and another var property total weight called total weight, which is initialized to packed weight plus gun weight. The interesting part is that we override the getter for total weight here, and so that it recalculates its value using pack weight plus gun weight. Next, look at how we might use these new properties with an instance of the soldier class, and we will let's create an example of how to create here. So create soldier again here, new instance, for example val strong soldier, and this will increment soldier class, or just we don't like that because the Kotlin will automatically assign it to val strong soldier. Let's print our total weight value here, log.e total weight here, total weight, and total weight is gonna be large strong soldier dot total weight here. Let's change the value of pack weight here. So strong soldier, strong, after that logging this our total weight strong soldier dot, let's change pack weight equals to 30 or 300. It's code for explanation. Let's print our total value again. Just copy this and paste this here. So in this code we create a soldier instance called strong soldier here. So next we print the value of total weight to the logcat. The third line of code changes the value of pack weight to 300. As you remember, our pack weight was 150. And then the final line of code prints out the value of total value, which we will use our overriding getter. So let's run our code again and let's see what our output will be. Yes. As you can see here, the first total weight was 118. As you can see here, 115 plus 30, it will be 180. And then we're changing our pack weight to 300. Our final result was 330, and we're printing that. So we can see from the output the total weight value is entirely dependent on the value stored in pack weight and gun weight. The first line of output starting with of pack weight 150 added to value gun weight 113 here. So let's close this. Okay, 13. And the second line of output is equal to new value pack weight added to gun weight. Just like functions, the enumerous flexible system of properties will raise some questions. So you may have questions like when to use overridden getters and setters. When to utilize these different techniques comes with the practice and experience. There are no hard rules about exactly when it is appropriate for a specific technique. At this stage, it is just necessary to understand that variables declared in the body of a class outside of a function are actually properties, and the properties accessed via getters and setters. These getters and setters are not transparent to the user of the instance, and they are provided by the default by the compiler unless overwritten by the programmer of the class. This is the essence of encapsulation. The programmer of the class controls how that class works. Properties provide indirect access to its related value called the backing field, although sometimes this backing field is not needed. In the next section, we will see more ways that we can use getters and setters. So let's move to the next lecture. Visibility modifiers. Visibility modifiers are used to control the access visibility of variables, functions, and even whole classes. As we will see, it is possible to have variables, functions, and classes with different levels of access depending upon where in the code the access is being attempted from. This allows the designers of a class to practice good encapsulation and make just the functionality and data they choose available to users of the class. As a slight convenient but useful example, the designers of a class used to talk to satellite and get GPS data wouldn't allow access or to the drop out of the sky function. There are 4 access modifiers in Kotlin. There are, I want right here, public, private, protected, and internal. Yes, internal. So declaring classes, functions, and properties as public means that they are not hidden or encapsulated at all. Let's create a new class that named, for example, satellite controller here. As you can see, our class is public here. Oops, I accidentally created the Java file here. Let me delete this here. Okay, and let's create Kotlin file here. Satellite controller here. So we could make this explicit by using the public keyword before all our classes. Public, as you can see here. We could function and property declarations, we make this public. We can use this public keyword as well, like class, function, and property declaration, but it is not necessary. When something is declared public or left at the default, no encapsulation is used. This is only occasionally what we want. Often the functions of a class that we expose the core functionality of the class will be declared public. Then let's go to private. We'll discuss in private. Properties, functions, and classes can be declared private by prefixing private keyword before the declaration. Let's define a private class here. Private, as you can see here, and let's add one variable in this class and one function. This private variable, for example, GPS coordinates, and assign it to string as well. 51 32 2 3 4 5 6 7 and 41 3 4 1 2 5 5 4. And let's create a function as well, private function drop out of sky, or then drop out of the sky. The satellite controller class is declared private as a private, which means that it is only available and can be instantiated from within the same file. An attempt to instantiate an instance, perhaps from onCreate here, it will throw an error, of course. Let's example this, test this. For example, let's create an object here, sat example sat here, and satellite controller, and equals satellite controller here. As you can see here, we can't create because satellite controller, it is private in file, but we can declare public classes here. For example, copy this to this and copy this here. This will fix our problem, because as I mentioned earlier, the available the private, which means that is only available and can be instantiated from within the same file. So these two classes is the same file now, but if we delete this cannot get instance from this, because these variables declared as private. But we don't we have not work for now variables. We just want to instantiate our class, and this class is declared private. Because of that, this throws an error here. So this raises the question of whether the class can be used at all. Declaring a class as a private is much less common than using one of the remaining modifiers that we will go on to discuss. But it does happen, and there are various techniques that make it a viable tactic. It is more likely, however, that a satellite controller class will be declared with a much more accessible public visibility. Moving on, let's create an public, change private to public. As you can see here, our problem is gone here. We can now create instantiated to example set. As you know, here our class and our function and variable, not a class public here, is private, declared with private. So even when satellite controller is declared to be public, the private GPS coordinates property is still not visible instances of the class. Like this, for example, if you want to get these instances here, example sat dot, as you can see here, this is the default class functions. We cannot see any of them GPS coordinates and drop off the sky. The GPS coordinates property is inaccessible because it is private here. And as we saw from our discussion of properties earlier in this lecture, when the property is left at its default, it is accessible. The point of these access modifiers is that the designer of the class can choose when and what to expose. It's likely that a GPS satellite would want to share GPS coordinates. However, it's also very likely that it wouldn't want the users of the class to play any part whatsoever is calculating the coordinates. This suggests that we would want users of the class to be able to read the data but not write or change it. This is an interesting situation because a first reaction might be to make property a val property. This way the user, like this for example, as we discussed earlier of our courses, this way the user could get the data but couldn't change it. The problem within this is that GPS coordinates obviously do change, and it needs to be a var property here. Just not a var property that's changeable from outside the class. When we declare a property as private, Kotlin automatically makes the getter and setter private too. We can change this behavior by overriding the getter and or setter to solve our problem of needing a var property that is not changeable from outside the class, readable outside the class, and changeable from within the class. We won't leave the default setter so it can never change externally, and override the getter so it can be read externally. So for example, let's delete this private here and make let's set this setter method private set here, and we have private function dropout of sky as well. This code, the satellite controller class and GPS coordinate property are public, as you can see here. Let me check, is this recording? Yes. Furthermore, GPS coordinate is a var property, as you can see here. 1 minute. As you can see here, var coordinate, and therefore is mutable, which means changeable and reassignable. However, look closely at the line of the code after the property declaration, because it sets setter to private, which means that code outside of the class can't access to change it. But because it is a var property, code within the class can do whatever it likes to do it. We could now write like this on create function to use our class, for example. For example, let's create a log here, and chords here equals satellite. Oops, we don't declared it yet. Var satellite controller here satellite oops, why is that? Because let's delete this code as well here. Okay, let's satellite controller and satellite controller as well. Okay, satellite controller here, and let's assign it to satellite controller here. And we can now use satellite controller dot GPS coordinates. Know that the setter is made private by the code. We cannot change the value from an instance, but we can happily read it. So let's run it, for example. Clear log cut here. Let's pause the video, and after color gradle build, I will continue. As you can see here, we printed our coordinates to logcat, so this code works. So I want moving on to discuss the function of the drop out of the sky function. This is private and totally inaccessible here. As you can see, this is private. So only code within the satellite controller class can call that function. if we want users of the class to have access to a function, as we have already seen, we will simply leave it at the default visibility. So as you can see here, let's try this. Satellite. No, what? Why satellite? I accidentally. Okay. Satellite controller dot, as you can see here, we have our drop out of the sky function is now accessible here. And the satellite controller class might have function that looks something like this. For example, let's create an update. Let's make private again, and let's create, and as you can see here, we can't use this function anymore because the function declared as private. And let's write an update coordinates function. I will not declare this as private, and update coordinates here, and GPS coordinates equals, for example, equals 21.919192, and this will be, for example, 23.896543 here. And this code, a public update coordinates function was added. This is public as well. This allows the instance of the class to use this following code. For example, satellite controller dot update coordinates is a usable function now. This will trigger the execution of the update coordinates function, which we will cause the class to internally update the property, which can then be accessed and provide a new value. This begs the question, what data should be private? The level of visibility that should be used can be learned partly with common sense, partly through experience, and partly by asking a question: who really needs to access the data and to what extent? We will practicing these three things throughout the rest of our course. Some more hypothetical code that shows some private and more private functions of satellite controller class here. For example, let's create a private class now. Private function do diagnosis, for example, or diagnostics here. And for example, let's create an one function as well. Recalibrate sensors. Oops. Recalibrate sensors here. And we have update coordinates as well. And for example, we have let's create a function run maintenance here, and this function will run these three functions, which is do diagnosis and recalibrate sensors here. And if big problem here, for example, let's create a big problem var as well. If var big problem is boolean equals false, let's do this private as well. We don't want to use anybody our code. Big problem Then if there is a big problem, then drop out of the sky. Drop out of the sky. This code, there is a new private Boolean property called big problem here. It can only be accessed internally and it cannot even be read externally. There are three new functions. One public property called run maintenance here, which runs the two private functions for do diagnostics and recalibrate sensors. Oops, we have alphabetical mistake here. Which runs to do diagnosis and calibrate sensors. These two functions called access and change the value of big problem if needed, as you can see here. In the run maintenance function here, a check is done to see if big problem is true, and if so, the drop out of the sky function is called. So now I want to explain the protected and internal visibility modifiers as well. So when the protected visibility modifier is used, its effects are more nuanced than public and private. When a function or property is declared as protected, it is almost private but not quite. The other key of object-oriented programming topic of inheritance that we will explore in the next lectures allows us to write classes and then write another class that inherits the functionality of that class. The protected modifier will allow functions and properties to be visible to such classes but hidden from all other code. We will explore this further throughout our course. And lastly, internal. The internal modifier is nearer to public than the others. It will expose the property function to any code within the same package. If you consider that some applications only have one package, then this is quite loose visibility. We won't use it much. I just wanted to let you know about it for the sake of completeness. Now we're done with visibility modifiers. What we have covered, despite being several pages, minutes long, it's only scratching the surface of visibility modifiers. The point is that they exist, and their purpose is to aid encapsulation and make your code less prone to bugs and more usable. Combined with properties, functions, getters, and setters, Kotlin is immensely flexible, and we could go on all day with more examples of when and where to use each visibility modifier and when, where, and how to override getters and setters in different ways. It is much more useful to use the techniques to build working programs. This is what we will do throughout this course. And I will often refer to why we use specific visibility modifiers or why we used a getter or setter in a specific way. I also encourage you to the basics classes demo application at the end of this chapter of our course. Constructors. Throughout this lecture, we have been instantiating objects, instances of classes, and we have gone into some depth about the various syntax. There is one small part of the code we have been ignoring until now. For example, we see several times this code, as you've seen, for example, while soldier1 equals soldier, you've seen soldier. You've seen this code in previous chapters of our lecture. The braces on the end of the code that initialize the objects looks just like the code form in the previous lectures. We have called a function without any parentheses. That is in fact exactly what's happening. When we declare a class, Kotlin provides behind the scenes a special function called constructor. So I will example you how constructors work. We have declared and initialized all our instances in our previous lectures in a single line each. Often we will need to use some more logic in initialization, and often we'll need to allow the code that initializes an instance of a class to pass in some values, just like a function. This is the reason for constructors. Often this default constructor is all we need, and we can forget all about it. But sometimes we need to do more work to set up our instances so that it is ready for use. Kotlin allows us to declare our own constructors and gives us three main options: primary constructors, secondary constructors, and init blocks. A primary constructor is one that is declared with the class declaration. For example, let's create an example. Let's delete and create a new class called book. And let's see, I will explain this code later. Title, string, for example, var sold integer. So in this code we have declared a class called book and provided a constructor that takes two parameters here: the title that takes string variable and sold that takes integer variable. So it requires an immutable string value and mutable integer value to pass it to it when it's initialized. Providing a constructor like this, then using it to instantiate an instance, declares and initialize the title and sold properties. There is no need to declare or initialize them in the usual way as we done in previous lecture for learning. For example, let's create an book object as well now. For example, val my book here and equals assign it to book here, and for example Sherlock Holmes, and sold is, for example, 1,000 or 10,000. So in this code, an object called my book is instantiated using the primary constructor and properties title here and sold are initialized to Sherlock Holmes and 10,000 respectively. Just as with functions, you can shape constructors to have any combination, types, and number of parameters. The potential downfall of primary constructors is that the properties take their values from the past in arguments without any flexibility. What if we need to do some calculation with past in values before assigning them to properties? Fortunately, there are ways we can handle this. Secondary constructors. A secondary constructor is one that is declared separately from the class declaration, but is still within the class body. A couple of things to note about secondary constructors is that you can't declare properties in the parameters, and you must also call the primary constructor from the code of the secondary constructor. The advantage to a secondary constructor is that you can write some logic code to initialize your properties. For example, let's make a secondary constructor. For example, let's make an meeting, for example. Let's read my book class here, and create a class named meeting, class meeting here, and we gonna get an two properties, which is day and person, value day, string, and person, well, person string here. And as you can see here, there are we can get this meeting day and person as constructor here. So let's make another constructor now. For example, let's create a time firstly, of course. Time string equals assign it equals to be decided. So the time is not decided yet. And now let's make a secondary constructor now. Constructor here, day string here, or oops, variable day string here, or I think no, it's we don't need a day here. So constructor day string person string then time string and this here, and day and person, as you can see here. So after that we're gonna use we have to open a braces firstly here, and this dot time equals time here. So in this code we declared class named meeting here. The primary constructor declares two parameters, as you can see here. First, two properties, one called day here, and one called person. Next, a property called time is declared and initialized to the value of to be decided. What follows is the secondary constructor. Notice that the parameters are preceded by the constructor keyword, as you can see here. You will also notice that the secondary constructor contains three parameters here: day, person, and time. The same as the two as the primary constructor, and one more called time. Note that the time parameter is not the same entity as the time property that was previously declared and initialized. They are not same here, as you can see here. The secondary constructor contains only throwaway parameters, and they do not become persistent properties like those of the primary constructor. This allows us to firstly call the primary constructor passing in the day and person, and secondly, in the body of the secondary constructor, assign the value passed in via the time here parameter to the time property, as we this the time assigning to time. Literally, I mean, we need to talk about this keyword here. When we use this inside the class, it has the effect of referring to the current instance, so it acts on itself. Therefore, for example, this dot day and time, or person, this code calls the primary constructor that initializes the day and person properties here. Furthermore, that this dot time, let's select this useless code. Fortunately, this dot time code that has the effect of assigning value passed in the time parameter here, the actual time property, that is that time. So we are assigning time to our argument time here. Users of our class can create instance of the meeting class when they don't know the time via the primary constructor, or when they do know the time via the secondary constructor here, they can create two ways. So let's use our class now, meeting class. So let's create here, and let's firstly initialize our value meeting here. Okay, meeting. The meeting will be Tuesday. And the second person name is gonna Bob here. Then let's add secondly, when do we know the time? As you know here, we used the main constructor, primary constructor here, and we're gonna use the secondary constructor here, and let's create another meeting here. Another meeting equals meeting dot Wednesday, or Wednesday, and the name of our person is, for example, Dave, and the time is 3 p.m. So this code we initialize two instances of the meeting class, as you can see here, and a meeting and another meeting. With the first instantiation we call the primary constructor Thursday and Bob, and because we didn't know the time, and with the second we call the secondary constructor because we did know the time. We can have more than one secondary constructor if required, provided they all call the primary constructor here. Init blocks. Kotlin was designed to be sufficient language, and often there is a more sufficient way to initialize our properties. If the class is not depending upon multiple different signatures, then we can stick to the more sufficient primary constructor and provide any required initialization logic in an init block. That's probably not theory. Let's use everything we have been talking about in a working app. Next, we will write a small application that uses classes, including primary constructor, secondary constructor, and init block. We will create a few different classes using what we have learned throughout this chapter of our course to put the theory into the practice. We will also see our first examples of how classes can interact with each other by passing a class as a parameter into the function of another class. We know how to do this in theory already, and we did it, some little and small examples of it. We just haven't seen it in very big practice yet. We will also see another way to initialize our data when the class is first instantiated by using an init block. We will create a small application that plays with the idea of simulating ships, dogs, and seal battles. So let's create firstly the destroyer. For example, let's delete our old codes. We will create several classes here. I will show you how to create classes. Let me show you, is this recording this side of our application? Okay. Now create a new create a new Kotlin class by clicking to main activity and name it. Oops, it doesn't. 1 minute, please. Okay. Let's change to this desktop display. So by right clicking, is this recording now? Yes. By right clicking, click on new, and then click on Kotlin here. 1 minute. Kotlin class file here, and name it destroyer here. So let me change to regular. So the new classes are created for us with a class declaration and curly braces ready for our code. The auto-generated code also includes the package declaration, which will be different based on your choice when you created the project. This is what this code looks like. So I'm gonna create another class in the same way. For example, carrier, and the third class named shipyard here. Is this recording? Yes. So let's start by coding our first part of the destroyer class here. What's the problem here? Oops, main activity. Oh, okay. So let's start by coding the first part of our destroyer class here. So what follows in the constructors, some properties and init block. So let's add codes to project. For example, our destroyer will get a name named and string object string here, and then we want to know what is the name of ship. For example, var name string, and we assign nothing to it, just empty string, and private as we done examples in previous lectures, we're going to use set as well, private set. So what type of ship it is it? So for example, if we need to know what type of ship is it, we need to add a variable named type, and our ship type is destroyer, destroyer, and how much ship can it take before sinking. For example, private var hull integrity, and it equals to 200, and how many shots left in the arsenal. For example, var ammo equals 1, and let's don't set our examples directly. Let's use set blocks here, private set, and what our ship's shot power is, private shot power, var shot power 60. We will no external access to we will not create an access to this, and because we initialize this as private here. And let's now begin init block here, init here. So we can, this will init the name, and we can use name as well, equals assign to it, and type and name here, name. So the first thing to notice is that the constructor receives a string value here called name. It is not declared with the val or var property. Therefore, it's not a property, it's just a regular parameter that will cease to exist after the initialization of the instance. We will see shortly how can make use of this. In presenting code, we declared some properties. Notice that the most are mutable var except type here that initialize to destroyer. Also notice that the most are private access except for 2. The type property is public, as you can see here. Let me do type property is public, and therefore fully accessible via an instance of the class. The name property is also public, but has a private setter, as you can see here. We can get but cannot send. Set this. We have to set inside our destroyer class. This will give access to the instance for getting value, but protect the backing field value from being altered by the instance. The hull integrity, ammo, shot power, and sunk properties are all private, as you can see here. We have has to be sunk, has the ship been sunk. Let's add sunk as well. Forgot it. Private var sunk equals false. Assigned to false, and there are private, of course. Okay, here. So, but be sure to make mental note of the values assigned to and the types of these properties. The final section of the preceding code is an init block here. Okay, init block, in which the name property is initialized by concatenating the type and name properties with a space in the middle. Next, add a take damage function to our destroyer class. Function, great, okay, function take damage here, and let's create an integer that damage shows us damage in the get parameter damage taken, that will be integer, and if not sunk, then hull integrity minus equals damage taken. Ox minus equals damage taken. Ups the damage taken here. And let's log it to log.e. For example, damage name damage taken equals here damage taken, and let's add another. Let me please, let's fix this. Okay. Okay, so now let's add another log here. Oops. Now let's add another log here. Log.e. Next we will print hull integrity, how much health our hull has, hull integrity, and hull integrity here, and this equals to our hull integrity. Hull integrity, hull y, hull and we're gonna pass an hull integrity here, hull integrity. So if our hull integrity is less than or equal to 0, then log.d our destroyer and name, our destroyer's name has been sunk, hit uppercase letters, and then bring sunk to true. So if this sunk is not is our destroyer is sunk, then this means if this block will not execute, then we will use else here, else the already sunk, oops, this is not a proper way. This has to be here, else, oops, and already sunk. So log dot d, let's print this to logcat here, and error here, and our ship does not exist. Ship does not exist. So in the taken damage function here, the if expression checks that the sunk boolean is not true. If the ship isn't already sunk, then hull integrity is reduced by subtracting the value of damage taken, which was passed in as parameter. Therefore, indirectly, the instance will be affecting hull integrity even though it is private. The point is that it can only do so in a manner decided by the programmer of the class. In this case, us. As we will see, the private properties will eventually be manipulated in some way. Also, if the ship is not yet sunk, to log.e here calls output the damage taken and the remaining hull integrity information to the logcat window. Finally, in the not sunk scenario, which is, as you can see here, not sunk scenario, a nested if expression checks whether the hull integrity is less than 0. If it is, then a message is printed indicating the ship has been sunk, and the sunk boolean is set to true after, as you can see here. When the damage taken function is called and the sunk variable is true, the else block will execute, and the message will be printed that the ship doesn't exist because it has already been sunk. Next, add the shoot shield function. Let's add this function, which we will work in conjunction with the take damage function, or rather, to be more precise, the take damage function of one ship instance will work in conjunction with the shoot shield function of other ship instances, as we will see soon. For example, phone function shoot shield here, and this gets our one integer, returns one integer here. So let the calling code on know how much damage to do. Return if our ammo is greater than 0, ammo -1 minus, and the shoot power, shoot power here. So else 0. This will return 0. So in the shoot shield function, I will explain it now. If the ship has any ammo, if ship has ammo more than 0, the ammo property is decreased by 1, and the value of shoot power is returned to the calling code. If the ship has no ammo left, as you can see, there is else, ammo is not greater than 0, then the value of 0 is returned to the calling code. Finally, for the destroyer class, add to served ship function, which sets ammo to 10, hull integrity to 100, so that the ship is fully prepared to take damage again via take damage here, and deal damage via shot shield. So let's create an service ship function here. Function service ship here, and this will assign ammo to 100 and hull integrity to assign to 100 as well. Ammo not 100 is some 100 is so great. 10 is okay for ammo. Next, we can quickly code the carrier class because it is so similar. Just make a note of the slight difference. It says in the values assigned to type and hull integrity. Also notice that instead of ammo and shoot power, we use attacks remaining and attack power. Furthermore, shoot shell, as you can see here, and ammo it has been replaced with launch aerial attack, which seemed more appropriate for an aircraft carrier. So for example, let's create a carrier here. So this carrier gets a name string, and then let's create a var name here and string here, and let's add something to it. Then let's assign private setter to it. Set. Okay. And what type ship is it? It is an carrier type ship. Let's val type, and this equals the carrier. And how much the ship can take before sinking? Private var, or yes, var hull integrity here, and this equals 200. And how many shoots left in the arsenal? For example, var attacks remaining here, and this equals to 1. And this cannot be, let's do the private setter, so this cannot be set it by directly externally. For example, private set here. And is this ship has been sunk, so private sunk var sunk equal assigned to false here, because we already created that false sunk, so the carrier sunk after shooting. So let's create an init here, init, and this dot name, I will explain this as well, equals type and name. Here. Let's create our demo. Let's copy. This is the same function as well. Yes, or just let's do it again. Function take damage here, and oops, project. Okay, function take damage. Damage taken. Oops. Function take damage. Damage taken, and this will be integer. And if our carrier is not sunk, then hull integrity minus equals damage taken. As I said you earlier examples of our code, this is the same as hull integrity equals hull integrity minus damage taken, as you can see here. but we will use replace with minus and equals methods. So then let's print this whole integrity and damage taken to our log. And if whole integrity, let's create a nested if whole integrity is less than or equals to 0, then log dot whole integrity, yes, log dot e carrier here name has been sunk. This name of our carrier and has been sunk, and sunk to true. Sunk equals true. So let's do this else loop here as well, and if else the will work, this means that our carrier is already sunk, and log dot d or error and ship does not exist. Ship does not exist. So let's create and launch aerial attack as well here. Function, create a native function and launch aerial attack here, and this will return an integer here, and let the calling code know how much damage to do. So return if our attacks remaining is greater than 0, and attacks remaining minus decrease attack decrement attack remaining, and attack power, return attack power. Where is our attack power? Attack power. Oh, we don't have attack power here. We don't create that thing accidentally. Let's set attack power to 120. Var or val. Yes, var or private. Var attack power equals to private val attack power equals to 100. Yes, and return attack power here, and add an else condition here, else 0, return 0. And let's create a new function as we created in earlier, destroyer. Create an fun service ship and this will restore our attack remaining to 20 and whole integrity to 200. Attacks remaining to 20 and whole integrity to 200. So the final code before we start using our new classes is the shipyard here. Let's do the same to shipyard, which is it has two simple functions. The first is let's create, and the first is function service destroyer, fun service destroyer. Destroyer, this takes and destroyer, and destroyer that service ship. Then The second is service carrier, one service carrier, and this will go as carrier, and carrier dot service ship here. The first function, service destroyer here, takes a destroyer instance as a parameter, and inside that function simply calls the instances service ship function here. The second function, service carrier, has the same effect but takes a carrier instance as parameter. While these two functions are short and simple, their later usage will soon reveal some quite interesting nuances to do with classes and their instances. Now we will create some instances and put our classes to work by simulating a fictional naval battle, and add this code to onCreate function in the main activity class. For example, val friendly destroyer here. Oops. Run this friendly destroyer, and assign to destroyer, create an instance destroyer, and let's name this destroyer invincible, and let's create a object that called val friendly carrier equals carrier indomitable, and let's create two enemy destroyers as well. Val, what's the problem here? Friendly carrier. Yes. Okay. Val enemy destroyer, and is assigned to destroyer as well. And this will be gray that, and create an val enemy carrier as well, assigned to carrier, and name it big gray that here. And let's create a friendly shipyard as well. Val friendly shipyard here, and this shipyard here. Okay. So let's create our fictional battle here. For example, oops. For example, let's make with comments. It will be amazing for us. And friendly destroyer will take a damage from enemy destroyer. Enemy destroyer that shoot shell. So our friendly destroyer will take damage again. Will take damage from enemy carrier that launch aerial attack, and then fight backing we are fight backing our application, fight back, and enemy carrier will take damage now. Enemy carrier that take damage from us, friendly carrier that launch aerial attack, and our enemy carrier will damage from our destroyer as well. Oops, enemy carrier that take damage. That friendly destroyer as well. And let's shoot shell here, and let's take a stock of supplies the situation. Take stock of the supply situation. Supplies situation, and log.t here. We'll get friendly destroyer name. Log.e. This will get an friendly destroyer that name, and ammo equals to our friendly carrier that oops, our friendly carrier that attacks remaining. Here we will print to stocks how many attacks and how many ammo we have, and let's print our oops, this has no to carry destroyer. With this code we're getting our attacks remaining, no, ammo and what it can be do, friendly destroyer name and ammo here. And as you know, we have two friendly destroyer here. We now friendly wars, and one is destroyer and second is carrier. So let's print carrier ammunition as well. So here the friendly carrier dot name. Oops, I'm sorry. Friendly carrier that name attacks equals to friendly carrier that attacks remaining here. So I think this is almost 35 minutes, so I will cut this lecture here, and we'll continue in next lecture. So it will be so amazing and fun to create this code. So I'm waiting in next lecture with you. So let's continue where we've been. So let's print our friendly carrier. So we printed this too, and now we need to shipyard to our friendly carrier and service destroyer. So for example, you will see friendly carrier shipyard, friendly shipyard dot service carrier, friendly carrier, and friendly shipyard that service destroyer and friendly destroyer here. Now so let's add the command doc at the shipyard and here let's take this stock of the supply station again. Let's copy this here and stock situation again, situation x2, and let's finish off the enemy here. Enemy destroyer that take damage from our friendly destroyer, destroyer dot show shield, and enemy destroyer will take damage as well. Enemy destroyer will take damage as well. Take damage as well here with our friendly destroyer, friendly carrier that launch aerial attack, and enemy destroyer will take damage from our friendly destroyer, again from destroyer that shoot shell. So finish of the enemy. So let's review that code. The code begins by instantiating two friendly ships, which is friendly destroyer and second is friendly carrier, and two enemy ships, enemy destroyer and enemy carrier, enemy destroyer and enemy carrier as well. Then enemy destroyer and enemy carrier. In addition, a shipyard instance, as you can see here, called friendly shipyard is also instantiated in preparation for the inevitable carnage that will follow. And as you can see here, next with friendly destroyer, objects takes damage twice, from once from enemy destroyer and once from enemy carrier. This is achieved by the take damage function of the friendly destroyer here, passing in the return value of the shoot shield and launch aerial attack. And we are all in here and we are fighting back. Next the friendly fight back by dealing 2 attacks on the enemy carrier object. As you can see, we are fighting back. One from the friendly carrier, launch aerial attack, and one from the friendly destroyer by shoot shield. As you can see here. So now the states of the two friendly ships are then output to logcat window, like how many ammo we had, how many attacks we have. And now the appropriate function of the shipyard instance is called on each of appropriate instance in turn. There is no enemy shipyard object, so they will not able to repair and rearm because they are fighting in our yard. So now friendly shipyard will service carrier dock at the shipyard, and friendly shipyard service destroyer into friendly destroyer here. And next the stats are printed again so that we can see the difference after visiting to shipyard. And then perhaps inventivity, the friendly forces finish off the enemies here. And let's run the app and you will see what is our code does here. Let's open the logcat window here, open the BlueStack as well. This is Gradle building now. Let's pause the video. So our compilation process is done and we are waiting for our device to run. Okay, so let's delete this. Let's run again. As you can see here, as I say, here is the output again. that I said you. The first destroy invincible damage taken 60, and hull integrity is for 140. Destroy invincible damage taken 120. Hull integrity 20, and a snow. And after that, our the enemy's hull integrity goes to -40. So we done our these examples now. I think this was fun, and I'm waiting you in the next lectures. Object-oriented programming and inheritance. We have seen how we can reuse our own code and other people's code by instantiating, creating objects from classes. But these whole object-oriented programming things goes even further than that. We will get to see inheritance in action in this lecture. In fact, we have already seen it, but now we will examine it more closely, discuss the benefits, and write classes that we can inherit from. Throughout this lecture, I will show you several practical examples of inheritance, and at the end of the chapter, you will improve our naval battle simulation from the previous lecture and show how we could have saved lots of typing and future debugging by using inheritance. In this lecture, we will cover object-oriented programming and inheritance, using inheritance with open classes, overriding functions, a bit more about polymorphism, abstract classes, and lastly, inheritance example lab. What if there is a class that loads of useful functionality in it, but is not exactly what we want? Think about when we wrote carrier class, our previous lecture, it was so close to the destroyer class that we could have almost copy and pasted it. We can inherit from a class and then further refine or add to how it works and what it does. You might be surprised to hear that we have done this already. In fact, we have done this every single application we created. When we use this syntax here, for example this, we are inheriting. For example, you may recall this function main activity inherits app compact activity. Here we are inheriting from the app compact activity class and all its functionality, or more specifically, all the functionality that designers of the class want us to have access to. We can even override the function and still rely in part on the overridden function in the class we inherit from. For example, we override the onCreate function every time we inherited the compact activity class. But we also called on the default implementation provided by the class like this super.onCreate, and we're giving as parameters on saved instance. But we also called on the default implementation as you can see here. In this lecture, we override many more of the activity class lifecycle function. Note that you can have more than one level of inheritance, although good design usually suggests that there are not too many levels. As an example, I have already mentioned that app compact activity inherits from activity, and we in turn have inherited app compact activity here. With this in mind, let's look at some example classes and see how we can extend them just to use the syntax as a first step and to be able to say what we have done it. Using inheritance with open classes. Some terminology that would be useful to learn at this point is that the class that is inherited from is known as the super or base class. Other common ways to refer to this relationship is parent and child class. The child class inherits from the parent class. By default, a class cannot be inherited from. It is called a final class, not open for extending or inheriting from. It's very straightforward. However, to change a class so it can be inherited from, all we need to do is add the open keyword to the class declaration. I want to show you the basic inheritance example here. For example, let's create a class that's named open solder with open keyword open class, for example, solder. So here and oops. Okay, so let's add a function to solder function should and log that e action bang 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 bang. So this code, which uses the open keyword with the class declarations, enables the class to be inherited from. We can go now ahead and create objects of the solder type and call the should function like this. For example, while soldier assign it to soldier here, and let's create and let's use the solder dot should function here, as you can see here. Oops. So the present ending code would still output bang bang bang. Let's see. So our Gradle build is running and it's installing here. As you can see here, our solder.should function is run, and which is bang bang bang. So oops, I'm sorry, my computer has so many sounds here. So, it's old. If you want to refine or specialize our use of the solder class, however, we could create a specialized type of soldier and inherit to shoot from. Should function. We could create more classes, perhaps special forces, paratrooper, and use this syntax to inherit from the soldier. So let's create a again class, again repeat this process, and let's create a class named special forces here and inherit this solder. So and function sneak up on enemy and log that e action sneaking up on enemy. So notice the use of the colon to indicate inheritance, and this is because we used colon, so the special forces inherits from soldier. It also adds a sneak up on enemy function. Next, consider the following code. For example, let's create a new class called class paratrooper here, and let's inherit from solver here, and for example, function jump, as you know, paratrooper jumps from the plane, jump out of plane, and let's print for example log again, log.e action, and here jump out of plane. So this code also makes paratrooper that inherit from soldier, and it adds a jump out of the plane function. So let's create in child classes here. For example, let's delete this soldier class that we used, and val special forces, and assign to special forces. Oops, special forces here, and let's create an let's use this special forces that should, and special forces sneak up on enemy function as well. I will explain them later. Special forces, special forces that should, we have should code as well, and let's create a val paratrooper paratrooper and paratrooper here, and paratrooper dot jump out of the plane, and paratrooper dot shoot. I will explain this now. This code, we instantiated a special forces instance and the paratrooper instance. The code demonstrates that both instances have access to the shoot function in the base class, and both classes have access to their own specialized functions. As you can see here, we use special forces sneak up to upon enemy, and we use paratrooper that jump out of the plane. So let's run our code again, and I will show you what will the exam result of our code. As you can see, our output is like this. So this is even more to inheritance than this. So look at what happens when we need to further refine the functionality of our super or base class. So we you've seen inheritance in Kotlin here, but I will explain it more detail in this lecture. So let's go to overriding functions. Overriding functions is something we have done already, but we need to discuss it further. We have overridden the onCreate function in every app we created here. And consider that we might want to add sniper class. At the first, these might seem simple. Just code a class, inherit from solver, and add a get into position function perhaps. What if we wanted to make the sniper class shoot differently to regular solver? So for example, we will now create a sniper class that inheritance from solver. For example, class sniper inheritance from solver, and here for example log dot let's create an new method, for example override we overriding our function now. As you've seen this code, every time we created an app, we overriding on create function, and we are overriding the solder's shoot function here as well. Override function shoot and log.e here, and we're gonna go action snipe steady sniper build steady, and adjust for wind. Sniper has to adjust for wind for shooting long distances. Adjust for wind, and bang. Sniper kills just one bang from long distance. So, and let's create an get onto position function as well. Function get into position as well, and here log.e action here, and preparing, let's write an preparing line of preparing line of side to target here. What's the problem? Because its fan cannot be overridden because our class y makes solder that's open here. As you can see, if we want to override our function, this has to open as well. So I want to explain why this happened. Error. You might thinking that job is complete, but this causes a small problem here, as we've seen here, and fix that with our integrated development environment. This is an error in the sniper class as shown in here. The error is because the shoot function was not written to be overridden. By default, functions are final, just like classes are. This means that the child class must use it as it is. And the solution is to go back to the soldier class here and add the open keyword in front of the shoot function here. Open. Here is the updated solder class, as you can see here, and our problem is gone here. Now we fixed the error and can write another code to instantiate the sniper class and use the overridden shoot function. For example, val sniper and equals assigned to sniper here, and let's use the sniper that shoot near, and sniper that get into position. Let's run this code again. Open the logcat. So we can see that the overridden here, as you can see here, we can see that overridden function has been used. It's also interesting to note that even though the child class has overridden a function from the parent class, it can still use the function from the parent if it wants to. Consider what might happen if the sniper ran out of ammo for his sniper rifle and needed to switch to his other weapon. So let's create and add a sniper ammo to our sniper class here. As you can see, in sniper we have two functions, and let's add one variable as well here, sniper here, and variable sniper ammo equals, let's give the sniper 3 ammo here, and when so we will use when condition as well here. One should. Let's delete this. We will paste it more. When sniper ammo is greater than 0, then if true, then let's log it here as we copy it here, and let's decrease sniper ammo by 1. And if false, it is false, then super that should. This is so interesting, so you will see why we done this. So let's run this again. Oops, no, I won't explain the first. So this is a new version of the sniper class. There is a new property called sniper ammo, and it is initialized to 3. The overridden shoot function now uses a when expression to check whether sniper ammo is above 0. If it is above 0, then the usual text is printed to the logcat window, and the sniper ammo is decremented after printing logcat window. This means that the expression will only return true 3 times. The when expression also handles what happens when it is false and calls super.should. This line of the code calls the version of the should function from the soldier upper class. So let's try our code here again. So let's open the logcat window here. As you can see here, because we have 3 ammo here, the true version of our condition is accepted and the false is not run. As you can see here, the default message for sniper ammo is printed here. But if our ammo was 0, if we don't have an ammo as we wanted, the sniper will go for soldier weapon. So let's run it again with 0 ammos of our soldier class. Open the logcat window, and as you can see here, our sniper class used bang bang bang. When can see the first three calls to sniper.shoot here get output from the overridden shoot function in the sniper class, and the fourth still calls the overridden function, but the false branch of the when expression calls the super class version of the shoot soldier when get the output from the soldier class. So in later lecture I'm gonna teach you the polymorphism and as you know, in previous lectures I have discussed about polymorphism, but in this later lecture I will discuss you and teach you the polymorphism fundamentals and polymorphism examples. So goodbye. We already know that polymorphism means many forms, but what does it mean to us? This means that we can write code that is easier to understand and simpler to change. Also, we can write code for the superclass and rely on the fact that no matter how many times it is subclassed, the code will still work within certain parameters. Let's discuss an example here. Suppose that we want to use polymorphism to help write a zoom management application. So we will probably want to have a function such as feed. Let's also say we have a lion, tiger, and camel classes, which all inherit from a parent class called animal. We will also probably want to pass a reference to the animal to be fed into the feed function. This might seem like we need to write a feed function for each and every type of animal. So let's delete our previous examples of our code and begin our examples here. So we can write polymorphic function with polymorphic arguments. For example, let's create an function inside our main activity class function for feeding animals, and animal to feed and pass an animal. Oops, not animal, feed, and we will pass an animal class here. Let's class animal and animal here. Okay, and add feed any animal here. This function has animal as a parameter, which means that any object that is built from the class that inherits from animal can be passed into it. So you can even write code today and make another subclass in a week, month, or year, and the very same functions and data structures will still work. Also, we can enforce upon our subclasses a set of rules as to what they can and cannot do, as well as how they do it. So clever design in one stage can influence it at other stage. But will we ever really want to instantiate an actual animal? And abstract classes and functions. An abstract function is a function that is declared with the abstract keyword. No problem so far. However, an abstract function also has no body at all. To be clear, an abstract function has no code in it. So why would we ever want to do this? The answer is that when we write an abstract function, we force any class that inherits from the class with the abstract functions to implement override that function. For example, here is a hypothetical abstract function example here. For example, read the function again, abstract function attack, and here it returns integer. Or let's create here, paste this here, and let's do the make an animal abstract as well. No body, no code, not even a simply empty curly braces. Any class that wants to inherit from that class must implement the attack function with precisely the signature of the presenting declaration here. An abstract class is a class that cannot be instantiated, cannot be made into an object. So it's a blueprint that will never be used then. But that's like paying an architecture to design your home and then never building it. You might be saying yourself, I can't have got the idea of an abstract function, but abstract classes are just silly. If the designer of a class wants to force the user of a class to inherit before using their class, they can declare a class as abstract. Then we cannot make an object from it. Therefore, we must inherit from it first and make an object from the subclass. Let's look at an example like we make a class abstract by declaring it with the abstract keyword. So let's delete this and select this as well and create an abstract class. Abstract class and some class here, or we don't have to curly braces here. And all functions and properties here. Yes, but why? Sometimes we want a class that can be used as a polymorphic type, but we need to guarantee it can never be used as an object. For example, animal doesn't really make sense on its own. We don't talk about animals, we talk about types of animals. We don't say, oh, look at that lovely fluffy white animal. Or yesterday we went to the pet shop and got an animal and an animal bed. It's just too well abstract. So an abstract class is kind of like a template to be used by any class that inherits from it. You might want a worker class and extend to this make miner, steel worker, office worker, programmer, and of course programmer as well. So, but what exactly does a plain worker do? Why would we ever want to instantiate one? The answer is that we wouldn't want to instantiate it one, but we might want to use it as a polymorphic type so that we can pass multiple worker subclasses between functions and have data structures that can hold all types of workers. We call this type of class an abstract class, and when a class has even one abstract function, it must be declared abstract itself, like this function. So for example, abstract function, silly function here, as you can see here. As you can see, we can't declare a normal function here. It has to be abstract. Or we can add body as well. But in this lecture, I will create an abstract function here. Is our code is recording? Yes. So this means that the abstract class can give some of the common functionality that will be available in all its subclasses. For example, the worker class might have the height, width, and age properties. It might also have the getPaycheck function, which is not abstract and is the same in all the subclasses. But the doWork function, which is the abstract and must be overridden, because all the different types of worker do work very differently. Let's class uses using inheritance example application. So we have looked at the way we can create hierarchies of classes to model the system that fits our application. I want to delete these codes here and let me drink water. This is what we're going to do in this example. Put most the functionality of the carrier and destroyer classes into ship super class and inherit from the ship class for both carrier and destroyer class. So you have introduced polymorphism, abstract classes and functions as well in this lecture. Later of this lecture, as we created a fun battle worship application in previous lectures, we will create in later lectures, but with inheritance. It will be so fun. So I'm waiting you in next lecture. Classes using the inheritance example application. We have looked at the way we can create hierarchies of classes to model the system that fits our application. So let's build a project to improve upon the naval battle we had in the previous lecture. This is what we are going to do is put most of the functionality of the carrier and destroyer classes into ship support class, and inherit from ship class from both carrier and destroyer, and therefore save a lot of code maintenance. Use polymorphism to adapt the service ship function in the shipyard class so that it takes ship as a parameter and can therefore service any instance that inherits from ship, thereby reducing the number of functions in the class. We will also see that not only is there this code achieving the same functionality as before, but is more encapsulated than before as well. So create a new class called ship. So I want to show you here how to create a new class in Android Studio. Click on our project and go to first new and click on the Kotlin class file here and name the ship here. Okay. So here. Now I will write our code and explain later for better understanding. Ship and add 3 parameters to it. The first is val name takes string. The second is private var type string as well, and private val max attacks this integer. Oops. Integer, and the last maximum whole integrity here. Let's add maximum here and max whole integrity, and this will be integer as well, as you can see here. So we have 3 parameters in ship function here, and that's stats our ships have. In previous lecture we done this. Private var sunk is ship sunk, false, and hull integrity private var hull integrity, this will be integer as well here, and here was the problem at initialize. Yes, and we have protected keyword as well here, and protected what attack protected access modifier, as you learned earlier previous chapters lectures. Attacks remaining and integer here. Initialize to this 0 as well, and let's create init here. So init function, we discussed what is init function previous chapters. Whole integrity equals this dot maximum whole integrity here. Okay, maximum whole integrity, and attacks remaining 1. Oops, that's the problem as well. Okay, this is we can write these codes in new line, but this is properties of our ship class. So remove this and create abstract property whole integrity, and I'll just select for now this. We will fix them later, and our ship has to take damage function take damage here, and we have to write some damage taken that integer, because damage taken integer. So print how many damage our whole integrity take, and decrease our damage taken into whole integrity damage taken. So, and let's log this to our logcat. So name of our, let's import, and the name of our pool and damage taken here, and this equals to our damage taken variable. Taken variable here, and let's print whole integrity after that. Okay, name whole integrity here, and is equals to our whole integrity. I will explain this code later for better understanding. And if our whole integrity is less than or equal to 0, then then this means our battleship is sunk. This dot there, and type and name, apparent name, or name of a battleship, and has been found here. And let's bring our sunk value from false to true, because our battleship is sunk. Then else then this means our battleship is already sunk. Log.e error ship does not exist. And let's create a service ship as well. Function service ship here, and add a text remaining equals maximum attacks here, and full integrity equals to so we will restore all whole integrity and attacks remaining to maximum whole integrity and maximum attacks remaining here. And let's create another function that shows statistics. Function show stats here, and log.e here, type name, the first type, and name our ship name, attacks here, attacks remaining for printing the statistic here, and the second is whole integrity. We want to print here whole integrity. That's right. Come to me. So whole integrity here, and let's create an abstract function attacks, and that returns to integer. Function attack, and this function returns an integer here. Oops. Okay. So first you will notice that class is declared abstract here. So we know that we must inherit from this class, and we cannot use it directly. Scan down near the end of the code, and you will see here an abstract function called attack, We now know that when we inherit from ship, we will need to override and provide in code for a function called attack. This is just what we need, because you might remember that aircraft carriers launch attacks and destroyers shoot cells. Scan back on the top of the this code, you will see that the constructor declares 4 properties here. As you can see here, first is sunk, hull integrity, attacks remaining, and as you can see here. So can see here we have inserted 3 variables and 4 constructor code as well, and 2 of the properties are new and the 2 have the same uses as the previous project. But we now how we call the constructor is what is interesting, and we will see that shortly. The 2 new properties are max attacks here and max hull integrity here, so that the shipyard restores them back to a level appropriate for the specific type of ship. In the init block here, let me show you, is it recording? Yes. In the init block here, the properties that were not initialized in the constructors are initialized. What follows is the take damage function here, and which has the same functionality as the take damage function from the previous project, except that it is in the just the ship class and not both the carrier and destroyer classes. Finally, we have a show stats function here for printing the statistics related values to the logcat window here, as we done in earlier previous project. So meaning that those properties can private too, of course. Notice that all the properties are private except for name and one protected property called here attacks remaining here and name here. So remember that protected means that is only visible inside instances and that inherit from the ship class. So now let's code the destroyer class, but we have a problem here. What is that? It's because creating more actions here. Maximum hull integrity. No. Let me think, please, what it can cause this. Init maximum hull integrity, create abstract here, maximum hull integrity here. So we fixed that, and now let's create an destroyer class here. Right click on that, the same, and create a destroyer. So the destroyer takes 1 parameters and returns a ship object here, name string. Oops, okay, and this returns the ship object. So and a ship object takes 3 parameters here. The first is name of our destroyer class and our type, which is If we're creating destroyer object, then the type will destroyer, of course, destroyer. And the third is attacks, maximum attacks 10, and max hull integrity is 100. And then let's create a private variable that should power private var should power is assigned to 60, and let's create a function, override function, that we will override attack function here. Override function attack, and let's this will return integer, and let's return if our attacks remaining is greater than 0, and decrease attack remaining by 1, and then should power here, should power, and else 0, return 0, and we will return should power. And if this attack remaining is less than 0, then we will return 0. Now let create a carrier class here that inherits from let me show you how to create class again. So click on right click project and click on Kotlin class file and carrier here, and okay, let me change to again display capture. So as you can see here, we have a new problem. Why implement as a constructor parameter maximum hull integrity as well. Okay, so why we don't want that? Let me delete this maximum hull integrity. We just want to get an abstract private one here and delete this. Okay, I made a mistake here, but I will fix that. So now let's create a carrier class here. This returns, this is will likely like a destroyer class, but it will different name and different object, gets string as name and returns ship parameters like destroyer, and similar to destroyer. And this ship parameters takes name. The second is type of our carrier, and this carrier, let's have an attack remaining maximum attacks to 20 and 20 and maximum hull integrity to 100, and it create a private attack power for no external access, private var attack power for no external access, and let's add this to 120. And let's override function attack and return if our attack remaining is greater than 0, then attack remaining decrease by 1, and return attack remaining decrease by 1, and return our attack power here, and else return 0, as you can see here. Notice that the both presenting two classes here, destroyer and carrier, only string value class receive only a string value named called name here. Our carrier takes one string parameter, and destroyer takes one string parameters as well as a constructed parameter. You will for sure notice that the name is not declared with the val or var, so it is not a property, as you can see here. Just a throwaway parameter that will not persist. The first thing each of the classes does is inherit from ship and call the constructor of ship class, passing in name along with the values appropriate for either destroyer and carrier. So as I said you earlier, this is the inheritance symbol. So for example, our main activity inherits from app-compat activity, and here our carrier inherits from ship, and destroyer imports from the same as the ship inherits from. So this is the inherits fundamentals. We have discussed it earlier chapter, and we had did so many examples about that. And this will last example of our inheritance project. So the first thing, each of the classes does is inherit from ship and call the constructor of ship class. As you can see, the constructor takes value, string, type, string, max attacks, and maximum hull integrity here. The passing a name along with the values appropriate for either destroyer and courier. So both classes have an attack related property. Destroyer and destroyer has shoot power here. What's the problem here? Why this is red? We don't have an error here. Okay, it's just Android Studio bug. So both classes have an attack related property. The destroyer has shoot power here, and the carrier has attack power here. Then they both implement override the attack function to suit the type of attack they will carry out. So as you can see here, they both overrides this function. However, both types of attack will be triggered in the same way with the same function call. So let's call the new shipyard class here. Display capture, and let's call the shipyard class here as we did earlier, class creating shipyard here, and it's okay. So the shipyard class will have one function service ship. This will take an ship object to take as parameter here ship to be serviced here, and this gives a ship type of object here, and ship to be serviced that service ship here as we did earlier, and log.il. Let's log this servicing, and here servicing our ship name here. Okay, and ship to be serviced dot name. Our is print the ship to be services name here. In the shipyard class, there is now only one function. Oops, let's implement this log here. As you can see, there is only one function. It's a polymorphic function, takes a ship instance as a parameter. It then calls the service ship function for the super class, which will restore the ammo, attacks, and hull integrity back to the levels appropriate for the type of ship. So it's true that the shipyard class is superficial, but we could have called service ship directly without passing the instance to another class. But it neatly demonstrates that we can't create two different classes at the same time because they inherit from the same type. The idea of polymorphism goes even further than this, as we will see in the next lectures when we talk about interfaces. After all, polymorphism means many things, not just the two things. Finally, add the code onCreate function in the main activity code. Let's write it and let's put our hard work into action. So let's create a value named friendly destroyer, as we did earlier. Friendly destroyer here. Uh, this will just initialize to destroyer. Name it invincible, and let's create a variable called friendly a carrier equals carrier, and it's assigned carrier, and let's name it indomitable indomitable here, and let's create an enemy carriers and destroyers as well, because without enemy there is nowhere. Enemy destroyer destroyer, and let's name it gray death and let's carrier enemy carrier, let's name it destroyer swimming blue that here, and let's create a friendly shipyard here. Friendly shipyard shipyard here, and let's make a small battle here. Small battle, and let's take damage for firstly take damage our friendly destroyers. Friendly destroyer that take damage from name enemy destroyer that attack power, and let's friendly destroyer take damage as well. Friendly destroyer take damage from enemy carrier as well. Enemy carrier that attack here, and let's give our enemy carrier damage, enemy carrier that take damage that from our friendly carrier that attack here, and enemy carrier that take damage from our friendly destroyer here that attack. Let's take a stock of the supply situation. Print here statistics of stock supplies here, and let's make a friendly shipyard that service ship, and let's service our friendly carrier, and then service our friendly shipyard that service ship friendly destroyer here, and let's first show the our statistics and then service ship. For example, friendly carrier that show stats, and friendly destroyer that shows stats as well here. And here lastly, let's service our ship, service friendly ships, and here then let's take our stocks how statistics again, and let's finish off the enemy and end with the beta. Finish the enemy, and then enemy destroyer, this enemy destroyer that take damage from our friendly destroyer that attack, and enemy carrier that take damage from our friendly carrier as well, friendly carrier that attack. And let's take an enemy destroyer, take damage again, free, and the destroyer that attack, and so let's run this. As you can see here, we had taken invincible damage, so there is a lot of information here which you can read or do it yourself, of course. So the first, let's I want to tell the pattern of by quick here. The first, we are attacking the friendly ship, then fighting back and sinking the enemy carrier, then we're printing stats, then visiting the shipyard for repairs and remaining, the printing the stats again here, and then finishing off the final enemy, as you can see here. There's a lot of information here. So in this output we can see an almost identical output. However, we achieved it with less code and more encapsulation. And furthermore, if in 6 months we need a submarine class that attacks with torpedoes, then we can add without changing any pre-existing code. If you haven't memorized everything, or if some of the code seems to be too in-depth, then you have still succeeded. If you just understand that object-oriented programming is about writing reusable, extendable, and efficient code through encapsulation, inheritance, and polymorphism, then you have the potential to be a Kotlin master. Simply put, object-oriented programming enables us to use other people's code even when those other people are not aware of exactly what we will be doing at the time they did the work. All you have to do is keep practicing, because we will constantly be using these same concepts over and over again throughout the course. So you don't need to have even begin to master them at this point. So thank you for watching. Practice, practice, and practice. By the end of this lecture, the missing link between our Kotlin code and our XML layouts will fully reveal it, leaving us with the power to add all kinds of widgets and UI features to our layouts as we have done before. But this time, we will be able to control them through our code. In this lecture, we will take control of some simple UI elements, such as a button, text view, and in the next lecture, we will take things further and manipulate a whole range of UI elements. To enable us to understand what's happening, we need to find out a bit more about the memory in an application. And two areas of it in particular, the stack here, stack and heap. In this lecture, we will cover like Android UI elements and classes, garbage collections. Our UI is on the heap, more polymorphism, nullability, for example, val and var as well, casting to different types we will cover in this lecture as well. So all the UI elements is classes too. When our application is run and the set content with is called from the onCreate function here, and the layout is inflated from the XML UI and is loaded into memory as usable objects. They are stored in part of the memory called heap here. But where is the heap place? We certainly can't see the UI instances in our code, and how on earth do we get our hands on them? The operation system inside every Android device takes care of memory allocation to our application. In addition, it stores different types of variables in different places. Variables that we declare and initialize in functions are stored in area of memory, called memory here, and memory. So, known as the stack. We already know how we can manipulate variables on the stack with straightforward expressions. So let's talk about the heap some more. Think of the heap as a separate area of the same warehouse as where our regular variables are stored. The heap has lots of floor space for odd-shaped objects, racks for smaller objects, lots of long rows with smaller size cubby holes, and so on. This is where objects are stored. The problem is that we have no direct access to the heap. Think of it as a restricted access part of warehouse. You can't actually go there, but you can refer to what is stored there. Let's look at what a reference variable really is. It's a variable that we refer to and use via a reference. A reference can be loosely but usefully defined as an address or location. The reference, address, or location of the object is on the stack. So when we use the dot operator, we are asking the operating system to perform a task at a specific location, a location that is stored in the reference. Why would we ever want a system like this? Just give my objects on the stack already. Where is why? A quick break to throw out the trash. This is what the whole stack and heap does for us. As we know, the operating system keeps track of all our objects for us and stores them in a devoted area of our warehouse called the heap. While our application is running, the operating system will regularly scan the stack. The regular racks of our warehouse and match up references to objects that are on the heap. Any object it finds without matching reference, it destroys. Or in current terminology, it garbage collects. So if any object there is a stack without matching reference, it destroys, or with correct terminology, it collects the garbage here. Think of a very disconcerting refuse vehicle driving through the middle of our heap. Scanning objects to match up the references on the stack. No reference means it is garbage collected. If an object has no related reference variable, we can't possibly do anything with it anyway because we have no way to access it or refer it. This system of garbage collection helps our applications run more efficiently by freeing up unused memory. If this task was left to us, our application would be much more complicated to code. So, variables declared inside a function are local on the stack and are only visible with the function where they were declared. A property of an object is on the heap and can be referenced from anywhere where there is a reference to it, and if the access modifier encapsulation allows. So, let's take a quick look at what we learned about a stack and heap. So, the first is you don't delete object, but operating system sends the garbage collector when it thinks it is appropriate. This is usually when there is no active reference to object. Variables are on the stack and are local to the specific function with which they were declared. Properties are on the heap with their object instance, but the reference to the object instance, its address, is a local variable on the stack. We control what goes on the stack. We can use the objects on the heap, but only referencing them. The heap is kept clear and up to date by the garbage collector. An object is garbage collected when there is no longer and a valid reference to it. So, when a reference variable is removed from the stack, then its related object becomes viable for garbage collection. And when the operating system decides that time is right, usually very promptly, it will free up the RAM memory to avoid running out. If we mentioned a reference to an object that didn't exist, we will get a null pointer exception here, error. Null pointer exception. Error. And most common in Java. And after this error, our application will crash. One of the major features of Kotlin is that it protects us from occurring. So in Kotlin, there is almost no null pointer exception here. In Java, which Kotlin is trying to improve upon, a null pointer exception error is the most common cause of an application crashing, unfortunately. We will learn more about how Kotlin helps us to avoid null pointer exception errors in the section near the end of this lecture. How does this heap thing help me? Any UI element that has an ID attribute, as you can see here, set. For example, let's add a button as well here. Let's here and here and here, as you can see here. Any UI element that is ID attributed, here you can see here in button we have ID, that button ID, or let's add button here, button 1, and set in the XML layout can have its reference retrieved from the heap and used, just as we can with the classes we wrote and declared ourselves over the previous two chapters of our course. If we created a project with empty activity template or basic activity template, feel free to do so, but you don't need to. Drag a button on the UI as I did. Let's change to refactor here, as I did. Infer the constraints and run the application on an emulator, and you will get this. For example, let's run our emulator, and let me, okay. Bullet tags here, oops, here. Here, let's add this to here. Let's make it a bit smaller here. Our application is compiled. As you can see, our UI widgets, it's here. We can touch button and see the texts that we assigned. So let's close, let's disable here and continue to our lecture. This is what we should expect, except from what we have already seen in the first 5 sections. If we added a line of code on a function, for example, like this, as you know, our ID is button1, and let's add a function to button1, button1 here, and let's assign it to, for example, button1, as we did our with button1 dot set text here. Let's assign text, for example, like this, our example text. As you can see, we cannot directly use our UI IDs here. We have to create an object from it. In order to create an object from our UI element, let's create and name it firstly var. All var is okay as well. Button1 and make it text view. Let's use text view because we need to, we have to initialize to as well, because when we click on the button, the text view have to run, change. So button1 button, and let's insert import here. As you can see here, we imported button here, and button1.1 find view by id r.id dot button1, and button1 dot set on click listener and view dot on click listener. Set on click listener, let's add braces here, and let's initialize our text view as well. Val text view one and text view here, and find view by id r.id.text view. So let's when we clicked button, they change the text view text. So text view one dot set text our new text example, and let's run our code here. The code is now compiling. I will stop video here. Our code is compiled here. As you can see, now I will click the button, and as you can see, we change our text with button1 that set on click listener function. So this is quite exciting because it shows we can grab a reference to a whole bunch of stuff from our layout. We can then start using all the functions and properties that these objects have that provided by the Android API. So let me close this here, and so the button instance of the code refers to the ID of the button widget in the XML layout. As you can see, let me delete this, and I will explain this code in here. Or yes, okay. The text instance in our code then refers to the text view property here. Oops, the text instance in our code is refers to the text view property and of the text view class, and this refers to this object, this UI element here. If you think that after almost 8 chapters we are finally going to start doing some neat stuff with Android, and you will be right. Let's learn about another aspect of object-oriented programming, and then we will be able to build our most functional app so far. So, using buttons and text view widgets from our layout with a little help from interfaces. For this, as you know, in previous lectures we learned about interfaces, but I want to discuss about interfaces for better understanding you, and after that I will show you the brief introduction of interfaces, how interfaces work with text widgets from our layout. So what is an interface? An interface is like a class. Nothing complicated there here then, but it's like a class that is always abstract and only has abstract functions. We can think of an interface as an entirely abstract class with all its functions and properties being abstract. When a property is abstract, it doesn't hold a value. It has no backing field for the property. However, when another class implements or uses the interface, it must override the property and therefore provide a backing field for storing a value. Okay, so you can just about wrap your head around an abstract class, because at least it can pass on some functionality in its functions and some state in its properties that are not abstract and serve as polymorphic type. But seriously, this interface seems a bit pointless. Let's look at let's create a possible example of an interface, then we can discuss it further. So interface here, and let's name interface some interface and val some property. Let's make property string, and let's add some function as well. Some function here. So the function of an interface have no body because they are abstract, but they can still have return types and parameters. To use an interface, we use the colon syntax after the class declaration. For example, let's create an another class here. Some class here, and let's add some interface. It's interfaces are written in outside of main block. I just want to show that to you. So here, delete that and implement as a constructor parameter. Okay. Okay. This code, the property and function, has been overridden in the class that implements the interface. The compiler forces the user of an interface to do this, or else the code will not compile. If you are inheriting from a class at the same time as implementing one or more interfaces, then the superclass simply goes into the list with the interfaces. It is convention to make the different relationship clear. To put the superclass first in the list, this is however not required by the compiler. This enables us to use polymorphism with the multiple different objects that are from completely unrelated inheritance hierarchies. If a class implements an interface, the whole thing can be passed along or used as if is that thing, because it is that thing. It's polymorphic with many things. We can even have a class implement multiple different interfaces at the same time. Just add comma between each interface and be sure to override all necessary functions. In this course, we will use the interface of the Android API more often than we will create. So, for example, in this lecture, we have used one such interface and we'll use later in this lecture on click listener interface. Many things might like to know when they are being clicked, such as a button widget or text view widget. So, using an interface, we don't need different functions for every type of UI element we might like to click. So, in this lecture, we created a application by created after clicking the text changed, and I have explained you more interfaces and how UI elements work in Kotlin. And later lecture, we will create a more complicated example and more nice example in interfaces. So in this lecture, we will create a very interesting example UI application that works with help of interfaces. So let's create a new project. Click on new project and click on select empty activity from phone and tablet section here and click on next, and let's name it Kotlin UI and click on finish and choose language as Kotlin as a default and click on finish, and let me change my B Studio to our IntelliJ recorder here. So now we will create a project that using buttons and text view widgets from our layout with a little help from interfaces. So I will pause this video now. This can take some minutes to build our project, and I will continue after building project here. Now I will develop a layout, and you can watch and repeat me as well. I will explain all of the code that I will write here, and let me just develop this, create this layout here, and I will explain this later. We need 6 buttons and 1 text view here. 1, 2, here and here, and we need 6 buttons here. One, 2, 3, 4, 5, 7, 5, 6, 7, 8. 8 buttons. We need 8 buttons. For example, 2. And oh no, we need a 6 button. 8 button is too much. So let me create this here and here, here and here. Oops. Here and oops. I will stop video now and I will show you after constraining these layouts. one, and lastly here. And we have added text view. Let's increase this text view font here. Font or size, text size to 34 is okay. 34 is okay. So now let's name our buttons now here, and I don't want blueprint, I just want design here. So we will create we had created 6 buttons, which these buttons in text property have will have add, take, grow, shrink, hide, reset. So let's create, for example, add here, add and grow. I will explain all of this code later. Just watch, and if you want, you do as well. Hide, add, grow. We will make a very interesting application using Kotlin interface. Take, shrink, and reset. Reset here, and so now let's name the text view as well here. Let's name, for example, button or text num, and we have to give ID of our buttons here to initialize more easily. And for example, let's give add button and button add ID, grow button refactor. Let's give grow button grow ID, hide button hide here, button take here. Let me check, is this recording? Yes. Button take and button shrink and button reset, and we have not done constraints properly, so let's add more constraints as well, X and Z here, and let's add here as well. Oops. So, and let's add a barrier here. I will explain these terms later to you. For example, here, 1 minute, quit line, vertical, oops, horizontal, yes, here, and add this two here. Close here. This will not a good constraints as well, but we just doing an test application, so this has not to be perfect here. It can, for example, but we will do more nice examples of later, but I just want to explain you with how Kotlin uses interfaces. So what the button take problem here, oops, here, and let's run our code. Is our constraints works properly. Let me show you the emulator here. There's tags here. Don't look at this. This is just our old project, as you know. So as you can see here, our buttons is work, but they are useless, just a UI components until we add code to them. So let's close our BlueStacks here, Android emulator here, and continue our work. So 1 minute. Okay. So the precise position and text on the buttons are not very important, but the values given to the ID properties must be same. The reason for this is that we will be using these ID values to get a reference to the button instances and text view instance in this layout from our Kotlin code, as you can see here. So let's switch to main activity and create an example view. For example, view after app compact activity view dot let's import this view here, view dot on click listener. So as you type, you will get pop-up list asking you to choose an interface to implement. If you don't write it properly, the Android Studio IDE will help you. For example, on click listener, as you as you can see, and select the first here. Notice that the main activity declaration is underlined in red, showing error here. And now, because we have made main activity into on-click listener by adding it an interface, we must implement an abstract function of on-click listener, the function called on-click. So when we add the function, the error will be gone. For example, we can get add Android Studio to add it for us by left-clicking anywhere and on the code containing the error, and then by using the keyboard combination Alt Enter, we can and then clicking Alt Enter and click then Enter again. And as you can see, let me show you. For example, as you can see here, you can do that. Just bring mouse here and make main activity abstract. This is not a solution we want. And bring your cursor here and press in the same time Alt and Enter. And as you can see here, the first option is implement members. Click on implement members and click on click and OK. As you can see here, our error is gone. Let me change to our original. Okay. So for now, add this property to our main activity class here, for like this private value var value here, and is equals to 0. We have declared an integer property called value and initialized to 0. Notice that is a var property because we need to change it. Next, inside the onCreate function, add these 6 lines of code here. Button add dot set on click listener here, and of course we have we first initialize. As you can see, there is an error showing us because the button add object is not here and not initialized yet. So let's initialize all of these buttons. Button var or val button or button button add here, button add height growth button grow. Oops, button. Oops, okay. Button add, button here, and find view by ID are that we haven't implemented yet. Implement and find view by ID are that ID button add here. It's val button grow button and find view by ID r dot id button grow. Now button what we had button height, button shrink, button take, button height, button assign find view by ID, find view by r dot id that button height. Well, this has an short solution, but I want to show you all of this for better understanding. And button take, button find v by id or that id that button take, and we have to implement another button. Let me check, is this recording? Yes. Button take, button grow, button add, and we have to button reset and button hide, button grow, button take, button reset, val button reset, button as well, and assign to find view by ID r dot id dot button button reset here. And we now have 5 buttons, whereas our one shrink. Yes, we have button shrink here, while button shrink button, and last button we initializing r dot id dot button shrink. So now let's set the click listeners to this. So while button add that set on click listener, I will explain all of this code later. Just be patient and wait or 2 or 3 minutes. I will initialize that and set on click listener this button grow that set on click listener this as well. Button height set on click listener this button take that set on click listener this button reset set on click listener this as well, and lastly button shrink set on click listener as well here this. So this precedent code sets up our application to listen for clicks on the buttons in the layout. Each line of code does the same thing but on different button. As you can see it in this code, we have that button shrink, button reset, button take, button hide, button grow, and button add. And here we initialized, and here where we click it on click listen, we set it on click listeners on there. For example, button refers to the button. Button add refers to the button in our layout with the ID property as you can see here, button add, this button, and the ID property of the button add, and button take refers to the button in our layout with the ID property button take. Each button instance then calls the set on click listener here, set on click listeners, and sets up our application to call the on click function of on click listener interface. Now whenever on our buttons gets clicked, the on click function will be called. All this works because main activity implements on click listener interface. If you want to verify this, temporarily delete the, for example, viv.onClickListener here, code from the end of class declaration, and our code will suddenly be riddled with sea of errors, as you can see here. All of these keywords are error, all of these on-click methods are error, and as you can see, all of their errors. So let's undo this. This is because this keyword, as you can see here, is no longer of the on-class listener type. As you can see, let's read again. And therefore, it cannot be passed to the set on-click listener function of the various buttons. And the on-click function will also show an error because the compiler has no idea what we are trying to override. The interface is what makes all this functionally come together. So let me check, is this recorded? Yes. So now let's redo this. So now let's scroll down and to the on-click function here, and the Android Studio added for us after we implemented the on-click listener interface. Add the float size variable declaration and an empty when block inside it, so looks like the next code. Let's delete this to do and add an while size and float here, and let's create when v.id here. Why? Because v.id, and so remember that as we discussed earlier, the when you learned when what is the when keyword does, so I will not discuss here. You learned it as you remember, and when keyword, I will repeat this as well. When keyword will check for a matching value to an expression. The when condition is v.id, and the variable is passed to the onClick function, and v.id identifies the ID property of whichever button was clicked. It will match the ID of one of our buttons layout. So let me delete this. Okay. Let's add next block of code here. For example, let's make an ID text num text with here, or text value is better, text value, and let's initialize there as well, while text value text view find v by id or that id does text value. So now let's write our condition with when expression r dot id dot button add, and this will trigger here, and let's add another. Let's add button add and value. As you can see here, we will add value. With button add function, we will add value. I will explain all of this code later. And value and text value, text or text value, for example, text value dot text here. and let's add text value, for example value we added here, and let's create and again when expression here r.id, when our r.id is button take, then let's create an expression, and button take here will decrease our value here, and r.id dot we had button reset as well, button reset here, this will reset our value and assign to value 0. So this preceding code is where the first three when branches here they handle the RID, button add, button take, and button reset. The code in the button add branch simply increments value variable, and then it will does something new. So this is known codes. So but I will add an new code here as well. So text value that's set on click listener as well. It is an code for you, and you will learn now this. So after adding the value to with this button add function, we will print to this text value. So in order to do this, as you can see, the text value cannot be usable from here. So we will bring text value outside the function, and now we can use text value here. Text value dot text here, and this equals to value here. So then let's do again take button take here, text value, or just copy it. This is not difference here, and button value text as well. So it sets the text property of the text value object. This has the effect of causing this text view to display whatever value is stored in value object. So the take button does exactly the same, only it subtracts one from value instead of adding one, as you can see here. Button take. The third branch of when statement handles the reset position. But reset button sets value to the 0 and again updates the text property of text value. At the end of whichever when branch is executed, the entire when block is exited. The onClick function returns, and life goes back to normal until the users click next click. Let's move to examine the next two branches of the when block. For example, let's write this. So r.id dot button grow as well, grow here, and here here its size equals text value dot scale x, and text value dot text scale x equals size plus 1. I will explain later. And button shrink as well, but r.id dot button shrink here, and this does the instead of operation. So size assigned to text value dot text scale x and text value dot text scale x equals size minus 1. These two branches handle shrink and grow buttons from our UI. We can confirm this from the ID's button grow value and rd.id button shrink value. What is new and more interesting are getter and setter of the text view class that are used on the buttons. The getter of the text scale property returns the horizontal scale of the text within the object it is used on. We can see that the object it is used on is our text view txt value instance. The size equals code at the start of the line of code assigns a returned value to our float and variable size. The next line of our code in each when branch changes in the horizontal scale of the text using the setter of the text scale x property. When the grow here button is pressed, the scale is set to size +1, and when the shrink button is pressed here, the scale is set to size -1. The overall effect is to allow these two buttons to grow and shrink the text in txt value. So let's add final branch here which is button height, r.id dot button height. Let me check, is this recording? Yes, button height. And we will add button height to if, let's add an if statement, text value that visibility is equals, if visibility is equals visible, then change it to invisible. Text value that visible set or yes, visibility and checks equals view dot invisible. So, and change the text of the button, button height dot set ops not like this. Why button height is not working? Because button height is inside of our class. We can do all of this class, but we don't need to. We can do this as well here after text value, and now we can use this. Oops, we cannot use this as well. Why is that? Then we don't write button height here. I will fix them later. So then let's add an else statement here. Else here the txt text value dot visibility equals to view visible, view dot visible. We don't want to stay our text value invisible for all time. Button height, we cannot write this. Why? Button height here. Can we text value here? Yes, but we cannot write. This is because we have not initialized here. So we will take button height here from this and paste this here, and we will take button. Oops, we have not initialized button height. Yes, we have not initialized button height here. So let's initialize button height. I forgot. Button height dot set on click listener this here, and now we can use button height. So button height dot, oops, we cannot use. Why? What's the problem with button height? What button height here, and take this to here outside of the method and button height outside of the method here, and we can button height that we can use them now. Text show, and this here, and add this instead of show. Let's write here height, or not here, else in show height. So we done. This code takes a little bit of explaining. So let's take it a step at a time. First, there is an if-else expression. So let's delete unnecessary new lines here. So we have if-else expression nested inside when branch. So the condition to be evaluated is text value here, text value visibility equals visible. The first part of that, before this equality operator, use the visibility properties getter to return the value describing whether or not the text view is currently visible, as you can see here. The return value will be one of the three possible constant values as defined in the view class. They are view.visible, view.invisible, and view.gone, which we had not used here. If the text view is visible to the user on the UI user interface, the getter returns the view.visible. The condition is evaluated as true, and the if block is executed. Let me check, is this recording? Yes, and if block is executed. Inside the if block, we used the visibility properties setter and make it invisible to the user with the view.invisible value. In addition to this, we change the text on the button height object here. Let me show you. Button height object to show using the text properties setter. After if the if block has executed, the text value will be invisible. And when we have a button on the user interface that says show, show, when the user clicks on it in the state, the if statement will be false and the else block will execute. In the else block, we reverse the situation here. We set the text value object's visibility property back to the view.visible and the text property on button height back to height. In this is any way unclear, just enter the code and let's run the app and revisit the last code explanation here. So let's run the app. Let's add this BlueStacks as well. So our code is compiling now. Okay. Oops, button height that, but we have to set on click listener here, not here. And let's run it again. So our application is compiled and ready to install. We have another error. We have error. Oops. No, let's run it again. What's the problem? So I will no, let me just watch it. So install. When we install it, we have error in this line. So because we cannot use that, so we oh yes, text value here. So text view, we will add another code here. Text view that text view equals find view by id, find view by id r.id. I will explain this why this error is occurred. Text view find.id text value and delete this, because find view by id is on creates method here and we cannot use this. And what's the problem here? Text view add getter. What? Text value here, change to var, written. So add button height as well here. We will button height initializer to do here, or we can just initialize here. Let's change it to here and text view text view or to do let's just to do here and initialize this here. Button height equals find view by id r.id dot text value here. So after pausing the video, I fixed that problem. Because of that, we have to initialize our variables. This is because we overriding and we are overriding an instance here, which is interface. I forgot. We overriding interface, and the firstly we have to let init and our variables here, and then in onCreate method we have to initialize, and then we have to set on click system. I don't change the image. So let's run our code now. And this was just a little mistake. So let's run our code. I hope so you see. Yes. So when we click on add here, when we click on add here, we are increasing our text view here, and when we click on take, we are decreasing here, and let's increase and click on grow. As you can see, our text is growing here. If you click on shrink, the text is shrinking, and after 2 clicks the text is disappeared here. Because of that, it's had so much shrinked, and as you can see here, the text is grown now. And let's click on the height string. As you can see here, when we click show, as you can see the text showed here. When we click on height, this text changes here as well as we did. So when we click reset, our code resets to 0, and when we click shrink again, our code is on shrink size. So as you can see, we can use a negative numbers as well, and here. So this lectures is so I hope you learned so much things about this, like interfaces, late init, variables, and so much other things. This lecture was a long lecture because our programming code was a bit of tricky here for you, and I wait. As discussed in previous lecture, Android provides a number of layout managers for the purpose of designing user interface. With Android 7, Google introduced a new layout that is intended to address many of the shortcomings of the older layout managers. So this new layout, called constraint layout, combines a simple, expressive, and flexible layout system with pure powerful features built into the Android Studio Layout Editor tool to ease the creation of responsive user interface layouts that adapt automatically to different screen size and changes in device orientation. This lecture will outline the basic concepts of constraint layout, while the next lectures will provide a detailed overview how constraint-based layout can be created using constraint layout with the Android Studio Layout Editor tool. But actually, I think this lecture will probably one, or if this lecture will more than 30 minutes, I will make this lecture two. Separate these lectures too. First, a GUI to Android constraint layout, and then the professional example of Android constraint layout here. So then, how constraint works. So, in common with all the other layouts, constraint layout is responsible for managing the positioning and sizing behavior of the visual components, also referred as widget it contains. So it does this based on the constraint connection that are set each child widget. So in order to fully understand the constraint layout, it's important to gain appreciation of the constraints, margins, opposite constraints, constraint bias, chain styles, and barriers here. So let's start. Let's get started by constraints here. I want okay. Layout width. So layout width, let's edit this so this is not the default one. Layout width match oops, not layout margin, actually layout width, wrap content here, and layout. This is, I'm editing just the text view. I'm preparing to height here and wrap content as well. Layout height, wrap content as well here. So we're done with it, and as you can see here, our default layout is constraint layout, as you seen earlier. So constraints are essentially sets of rules that dictate the way in which a widget is aligned and distanced in relation to the other widgets. The size of the containing constraint layout and the special elements called GUI lines. So constraints also dictate how the user interface layout of an activity will respond to changes in the device orientation or when displayed on a device of differing screen size. In order to be adequately confirmed, a widget must have a sufficient constraint connection such that its position can be resolved by constraint layout engine in both the horizontal and vertical planes. So we have margins here as well. So what is the margin? So margin is a form of constraint that specifies a fixed distance. Consider a button object that needs to be positioned near to the top right hand of the corner device screen. So this might be achieved by implementing a margin constraints from the top and right edges of the button, so connected to corresponding sides of the parent constraint layout here. So let's give us an example here. Let's create a button here, drag and drop a button here, or we can drop button here. So if we want to arrange this button here, why is that? Because we are arranged constraints here. It is made give error, but using the ignore constraints code here, you can ignore constraints, and the compilation process and Android Studio will not throw an error here. So let's delete layout with absolute x and absolute y. So delete this, and now for example, we want right and top size side and with a little distance. So and then margin top margin, so margin end here is gonna be 20 dp, for example, and margin top here is gonna be 20 dp as well. And let's give us a constraint here, as you can see here. So as you can see here, we have a margin top and margin end at 132, for example. Let's do it for 40 actually. As you can see here, we have arranged here. So as indicated here, each of these constraints connection has associated with its margin value dictating the fixed distances of the widget from two sides of the parent layout. Under this configuration, regardless of the screen size or the device orientation, the button object will always display it. We always position it 40 and 40 device independent pixels, DPs, or we can do it 60 if we want from margin top. So 60 is from the top and right edges of the parent constraint layer, respectively, as specified by the two constraint connections, as you can see here. So while the above configuration will be acceptable for some situation, it doesn't provide any flexibility in terms of allowing the constraint layout engine to adapt the position of the widget in order to respond to device rotation and support screens of different size. To add this responsiveness, the layout it's necessary to implement opposing constraints. So let's try now in tablet here, 7-inch tablet. As you can see in 7-inch tablet, we have 40 right and 60 margin from top. So this will not change here if you use tablet and phone here. So now let me drink some water, please. So now I want to talk about your opposing constraints. So two constraints operating along with the same axis on a single widget are referred to as opposing constraints. Let's make it this blueprint as well here. Actually, it's not a good idea. It's a design, it's more learnable. What is opposite in constraints? The two constraints operating along the same axis on a single widget are referred to as opposing constraint. In other words, a widget with constraints on both its left and right hand sides is considered to have horizontally opposing constraints in top and bottom. So for example, I will create now an opposing constraints here, one right and one bottom here. As you can see, now we have opposing constraints here. The key point to understand here is that once opposing constraints are implemented on a particular axis, the position of the widget become a percentage rather than coordinate based. So let's open the attributes here. So as you can see, we can arrange, there's percentage here. So for example, let's do that like that and or like that here. We can add horizontal bias here and vertical bias here. So for example, the widget is positioned from 0.06% from the top of the layout and in different orientation, and when running on larger or smaller screens, the button will always be in the same location relative to the dimensions of the parent layout. So this is good for many UI implementation. So if you want your application UI work on phones, tablets as well, you will implement it. So as you can see, our button is the same coordination here. So we can portrait here. As you can see, our buttons location, it doesn't change. It doesn't matter. It is a tablet or phone here. So now I want to talk about the constraint bias here. Let's delete text view. Actually, we don't need for it now. So it has been established that a widget in a constraint layout can potentially be subject to opposing constraint connections. By default, opposing constraints are equal, so resulting in the corresponding widget being centered along the axis of position. So Let me delete that. Here. So this is the center of the opposite connection here, as you can see here. To allow for adjustment of the widget in the case of opposite constraints, the constraint layout implements a feature known as the constraint bias. As you can see here, vertical bias and horizontal bias here. So constraint bias allows the positioning of the widgets along the axis of the opposition to be biased by a specified percentage in favor of one constraint. So for example, we can adjust this like that here. Now we have a bias 0.33% and 68%, so we can change it here as well here. So now I want to talk about the chains here. So constraint layout chains provide a way for the layout behavior of two or more widgets to be defined as a group. Chains can be declared in either vertical or horizontal axis and configured to define how the widgets in the chains are spaced and sized. Widgets are chained when connected together by bidirectional constraints. So I want to show you how to create a widget here. So let's create a tree button here so here we need to assign left, and then we need to assign bidirectional here, as you can see here. Now that, and now that here, and now we adding here that here and here. Let's bring it a little bit here and this higher. So now we will assign a bidirectional constraints here. Now we're assigning to button first to button 2 here, and oops, and we're assigning this to this, and after that select this 3 button by pressing control here, and click here, and center horizontally here, and center vertically here, and let's create a chain here. Chains, horizontal chains. We have spread package spread inside, and packet here where we have vertical chain as well, but I will explain what these are. As you can see here, we created a chain here. So let's now okay, as you can see here, we created chain here. Actually, we have to assign 0 here. So we're done with that. So this chain, for example, let's change to tablet mode here. As you can see, our buttons position is not changing here. We can use TV as well, and our buttons position is not changing. I will explain how and why it is done. So the first element in the chain, let's portrait here. So the first element in the chain heat, which translates the top widget in a vertical chain, or in the case of horizontal chain, the leftmost widget. The layout behavior of the entire chain is primarily configured by setting attributes on the chain heat widget. We have actually 4 chain styles here. So the layout behavior of the constraint layout chain is dictated by chain style setting applied to the chain heat widget. The constraint layout class currently supports spread chain, spread inside chain, and weight chain, package chain here. So spread chain, the widgets containing within the chains are distributed evenly across the available space. So this is the default behavior for a spread chain. So this is the spread chains here. So spread inside chains we have as well. The widgets containing in the chains are spread between the chain head and the last widget in this chain. So the head and last widget are not included in the distribution spacing here. So let's create a chain here. Chains spread inside chain. As you can see, this is the spread inside chain here. Spread inside chain style actually. So we have a weighted chain here. So all of the space taken up by each widget in the chain to be defined with weighting properties here. Let's create an chains and create not. So we have weight chains as well here. So how weight chains is done. So this is not a weight chain here. So we have lastly we have packet chains here. So we have packet chains as well. So the widgets actually the weight chain is not using anymore because I will not tell you about weight chain because it's deprecated and not using by developers, and this is not the best way to create an UI with weighted chain in constraint layout. So we have a packet chain as well. So the widgets that make up the chain are packed together with any spacing. Actually without any spacing here. A bias may be applied to control the horizontal or vertical positioning of the chains in relation to the parent container. So let's create a packet chain here. As you can see, there's into these three buttons. We have no space here. So let's look at how many lectures. So here we have 70 minutes lecture. So in next lecture we will learn more deeply about constraint layouts and chains. Actually, we're done with chains. So we will learn the chains more detailed here. So I'm waiting you in next lecture. Thank you for watching. Working with guidelines. So guidelines are special elements available within the constraint layout that provide an additional target to which constraints may be connected. So multiple guidelines may be added to a constraint layout instance, which may in turn be configured in horizontal or vertical orientations. So once added, constraint connections may be established from widget in the layout to the guidelines. So this is particularly useful when multiple widgets need to be aligned along an axis. So let's create an guideline example here. I want to show you. So we need a guideline that search guideline horizontal or vertical as well. We only want vertical, so we can arrange this guideline however we want here. So I want to arrange here, and I will create a 3 button here, 2, 3, and 1 switch here. So here now we can assign our buttons and all other views widgets to a guideline here. As you can see here, we can arrange this to our guidelines here, and we can do whatever we want. So guidelines is good for UI developing, so and the responsiveness for applications here, as you can see here. So this is the how guidelines usable. So now I want to show you configuring the widget dimensions. So controlling the dimensions of a widget is a key element of the user interface design process. So the constraint layout provides 3 options which can be set to on individual widgets to manage sizing behavior. So these settings are configured individually for height and width dimensions, for example, fixed, match, and match constraint, wrap, content. So we have 3 configuring widget dimensions here: fixed, matched constraint, and wrap content here. So fixed widget is fixed to a specific dimensions. So match constraint is allows the widget to be resized by the layout engine to satisfy the prevailing constraints, also referred to as any size or match constraint here. This is not the case. Layout width and layout height is not a constraint. So wrap content we have as well. So wrap content, the size of the widget is dictated by the content it contains, text or graphics. So now let's work with guidelines here. Let me drink some water. So working with barriers, so we can delete these buttons and guidelines and switches here. So rather like guidelines, barriers are virtual views that can be used to constrain views within layout. So as with guidelines, a barrier can be vertical or horizontal, and one or more views may be constrained to it. To avoid confusion, these will be referred to as constrained views. So unlike guidelines, where the guidelines remains at the fixed position within the layout, however, the position of barriers is defined by the set of so-called reference views. So barriers we introduce to address an issue that occurs with some frequency involving overlapping views. So now let's create an example here. So the key points to note about the above these layouts here. Let's barrier, vertical here. Let's add a button to it. Vertical barrier. So the key points to note about this layout: the set match constraints node and the left hand edge of the view is connected to the right hand of the view here. So as you can see, our vertical barrier is here. So clearly, because view 3 is only constrained by view 1 and it doesn't resize to accommodate the increase in width of view 2, causing the views to overlap. So constraint layout advantages. I want to talk about constraint layout advantages here. So constraint layout provides a level of flexibility that allows many of the features of older layouts to be shared with a single layout instance, where it would previously have been necessary to nest multiple layouts. So this has the benefit of avoiding the problems inherent in layout nesting by allowing so-called flat or shallow layout hierarchies to be designed, leading both to less complex layouts and improved user interface rendering performance at runtime. So constraint layout was also implemented within a view to addressing the wide range of Android device screen sizes available on the market today. So the flexibility of constraint layouts make it easier for user interfaces to be designed that adapt to the devices on which application is running. So constraint layout availability. So although introduced in Windows in Android 7, constraint layout is provided as a separate support from library from the main Android SDK and is compatible with older Android versions. So API level so far back as API level 9, which is Gingerbird. So there is no Android systems almost working in Gingerbird. There is a newer phones here. So this allows applications to make use of this new layout to run on devices running much older versions of Android. So constraint layout is a layout manager introduced in Android 7. It is designed to ease the creation of flexible layouts that adapt to the size and orientation of the many Android devices now on the market. So constraint layout uses constraints to control the alignment and positioning of the widget in relation to the parent constraint layout, instance, guidelines, barriers, and other widgets in the layout. So constraint layout is a default layout for newly created Android Studio project and is a recommended choice which you're designing user interface layouts. With this simple yet flexible approach to layout management, complex and responsive user interface can be implemented with surprising ease.